Welcome to NDC Security!
More than 350 people are attending this year's event. That's simply amazing. Thank you so much for coming.
Thank you to all our speakers who traveled in from near and far. We really appreciate you being a part of NDC Security.
Thank you to our fantastic partners. These are amazing companies.
Please don't forget to evaluate the sessions. Red, yellow, green.
All sessions are recorded and made available after the conference. Check out our YouTube channel.
Don't forget to download the official NDC Conferences app. It's available both on Android and iOS.
Remember the code of conduct. Be nice to each other. And if you have an issue, reach out to the crew.
Food and refreshments are going to be served all throughout the entire conference in its breaks, with a lunch at 12:40. And tonight, don't miss out on our great party, which is going to have amazing food and drinks.
The keynote speaker has more than 30 years of cybersecurity experience at Microsoft. He's the co-architect of the Microsoft Security Development Lifecycle. Please welcome Michael Howard!
Well, good morning. Thank you so much for joining me. Wasn't kind of expecting that introduction. So my name is Michael Howard. I'm here to talk about one of my favorite topics. I work in the Microsoft Red team. Probably some of the most talented people I've ever met at Microsoft. Some people call them evil, but not evil. Definitely some of the most talented people I've ever met across the company. I will admit one thing right now, though. The title is actually a bit of a lie. Actually, it's a complete lie. It's not 25 years. And this isn't working. There we go. Let's try to get this to work. I am not moving. Oh, there we go. There we go. There we go. So I said it's 25 years of the Microsoft SDL. It actually really isn't. It's not 25 years at all, but it's definitely 25-ish years of the Microsoft SDL. And you'll see why I mention that as I go through the slide deck. A couple of people have asked me about the image that I have on the little blurb about me doing the keynote. And it's actually a photograph of me diving on a very famous shipwreck in New Zealand called the Rainbow Warrior. It's not a great shipwreck. It's not very deep. It's about 80 feet deep. But it's interesting in as much as it's the only shipwreck I've ever actually dived on that's actually been sank twice. It's not often you get to dive on a shipwreck that's sank twice. So anyway, as to the agenda, I say agenda of sorts, and there's a reason why I say that. I've never in my life actually ever managed to stick to an agenda, ever. It's just something I've never been able to do. Hopefully one day I will stick to the agenda, but I'll be honest with you, today is not that day. I'm not going to stick to the agenda today at all. All right, so what is the Microsoft Security Development Lifecycle? It's something that was introduced almost 25 years ago, really in a response to vulnerabilities that we had across the company, most notably in Windows. It's a series of recommendations and requirements. It's things that you should do and things that you must do to help secure products. It's updated constantly, and that's really important. But also, we've removed things from the SDL. And this is a very important point. I really want to stress this. You can't just keep adding more and more cognitive burden to your development environments and expecting engineers to stay on top of it. If something doesn't work, remove it. If you need to replace it with something else, then replace it. But it's really important that when you're evolving these environments, that you don't just keep growing it and making it harder and harder and harder. And it eventually just becomes a tax that engineering staff have to pay. So I really want to stress that. And a really good example of that is some of our static analysis tools. There were some tools that just became outdated and replaced with better ones. So rather than requiring the old ones, we just got rid of them. So some literary history. So I've written a few books across the years. Probably the most well-known one is Writing Secure Code that I did with David LeBlanc. David was in Office at the time, and I was in Windows at the time. Two teams that absolutely adored each other. That is a joke, by the way. But we wrote Writing Secure Code together, and that really sort of put David and I essentially on the map. It became sort of our magnum opus. I also wrote the book, Security Development Lifecycle, with my manager at the time, Steve Lipner. Now, what's really interesting about these books, though, is that two of them, Building Secure Software and Writing Secure Code, came out about 3 months apart. Building Secure Software was written by good friends of ours, Gary McGraw and John Viega. David and I went on to write other books with John Viega. What was interesting is that that book came out 3 months before Writing Secure Code. Ours is very Windows-centric, theirs is very Linux and open source-centric. We both published roughly kind of very similar books, roughly very similar timeframes. We didn't know each other were writing the same books. We didn't know that. But what's interesting is, how did that happen? Like, why did two totally disparate books get released at kind of the same time? And we believe that the industry recognized that there was a sea change happening in a focus on building more secure products and a recognition of vulnerabilities that came out. I will also, this is the first time I've actually even brought this up, because we literally got the cover just a couple of days ago. I actually got another book coming out, Threat-Driven Software Development. It'll be out in June. I wrote that with three very good friends of mine. So Lee Holmes, he was the security program manager on PowerShell back in the day when it started out as Monad. And Sean Hernam works in Azure Security. And what makes this book different, I think, is that, so Sherrod DeGrippo, she's a deputy CISO, and she's probably one of the world's most preeminent experts on threat intelligence. And she helped us write this book. Every chapter actually has some flavor text at the beginning that frames that chapter through the lens of threat intel. And the whole point of this is that you can't just keep saying, hey, do these things, do this thing, do this security thing, do this security thing. You got to look at it through the lens of threat actors. Is that actually what they're doing? Because if not, you may be wasting your time in terms of prioritization of time and effort. So that's why we wrote this book. All right, so let's get back to SDL. Actually, before I get onto this slide, which shows the evolution of SDL, I want to give you a little bit of prehistory. Before the SDL, there's a thing called SWI, the Secure Windows Initiative. There was less than 10 of us working on it. When I say less than 10, more like 5, but there's a lot less than 10 people working on this. We were all technically in Windows, and our job was really to focus. We were the first bunch of people to really focus on securing features versus security features. And it's a very, very big, very different mindset. So we had these things called security bug bashes. We had bug bashes with Windows, with Office, with Exchange, with SQL Server, with the developer division, with all sorts of divisions across Microsoft. And it was really just a day's effort to look for security vulnerabilities. I primarily looked after all the developers, all the people actually writing the code. A colleague of mine, Jason Garms, mainly focused on working with program managers, working on threat models and secure design. And another friend of ours, Chris Walker, he worked mainly with the testers, working on building test plans and, most importantly, building fuzz tests as well. The whole point of these bug bashes, there would be some education at the beginning of the day, and then we would have the rest of the day we'd be looking for bugs, security vulnerabilities. And then we would triage them later, basically just file bugs. All we cared about was just file bugs, and then we would triage them. The problem with that process is we were basically having people write code that wasn't fantastic, and then have a security bug bash looking for security bugs and fix all those security vulnerabilities. You can't do that. It's absolutely unsustainable. They were fun, I'll give you that. They were certainly fun. And you could even argue that the real goal wasn't even to look for security vulnerabilities. It was really there for education. You could think of it as education at the beginning, and then some homework for the rest of the day, and then hopefully further on, people would start to write more secure software because of the bug bashes. But they're really, it's just not scalable. We had prizes as well, but it's just not scalable. I also had a personal baptism of fire. So I was actually, some of you will snigger when I tell you this, I was actually the security program manager for IIS, for Internet Information Server, for a long time. Primarily late version of IIS 3, then 4, then 5, and then early versions of 6. IIS 5 especially had fantastic security features. It was the first web server that had built-in Kerberos authentication. We had really tight certificate services integration. We had digest authentication. We had certificate revocation. We had the whole 9 yards, right? It was really sort of security buzzword compliant. But it also had lots of security vulnerabilities in it. In fact, 3, 4, and 5 all had lots of security vulnerabilities. How many of you ever remember Code Red? The worm? Yep. NIMDA, another one. They were all on my watch. But I'll be honest with you, they're all on my watch. Not exactly something I'm particularly proud of, but you learn from these things. Most of the vulnerabilities were memory safety issues and canonicalization problems. And then other ones, we saw a real rise in SQL injection as well, because we had active server pages with COM integration, which then had SQL Server integration, which was just an avenue for SQL injection. So back then, my lexicon of words that were thrown around all the time were things like ACLs, DACLs, SACLs, SIDs, tokens, privileges, logon sessions, split tokens, all this stuff that was all Windows security features. And that was really IIS 3, 4, and 5. But then post IIS 5, IIS 6, by the way, the code name for IIS 6 was Kevlar. My idea for the code name was going to be Voyager, as in the Voyager spacecraft. It just keeps on going. But Kevlar was settled on because it's bulletproof. And IIS 6, I'll go down, I've said this publicly many, many times, IIS 6 is an incredibly secure and incredibly robust web server, and always has been, since 6. 3, 4, 5, not so much. But 6 onwards, it's been a fantastic web server. But what was interesting there is we basically just threw a whole bunch of code away and started from scratch and built it understanding the threats that web servers were exposed to. And my lexicon changed completely to things like dynamic analysis, threat modeling, authorization, authentication, SQL injection, crypto, cross-site scripting, fuzz testing, all these things. My lexicon completely changed. My career went from building security features to securing features, and it is a completely different mindset. So I really want to stress that last point down there. Security features does not equal security features. Secure features does not equal security features. So you go back to the books. If you look at the very first book that I worked on, which is around the Windows 2000 days, that was all about security features. All the books I've worked on since then have been about securing features. Very different mindset. So let's now go back to the SDL evolution itself. So when SDL started back in the day, we had Code Red. It was a security vulnerability in IIS 4 and 5. Yes, 4 and 5. Then we had the Trustworthy Computing Memo came out. And then we had SQL Slammer, which is a worm that infected SQL Server. How many of you have heard of or know of SQL Slammer? Okay, a few of you. Then we invented the SDL, the Security Development Lifecycle. Again, it was a small group of people who started it out, and we started pushing it across the whole company and made it a requirement across the company. Then we started to evolve it. We shipped it to customers. We made a lot of documentation available to customers as well as tools. We then started to focus on SDL for Agile, because you could argue that SDL back then was very heavyweight, was kind of quite waterfall-y, and it didn't really match the development practices of other development teams across Microsoft who had adopted Agile methods. Moving through the PSN hack network, the reason why that PSN attack, PlayStation Network attack, was so interesting is because we were learning from other people's mistakes. We weren't just looking at our own mistakes, we were looking at everyone else's mistakes as well. And what could we learn from those mistakes and feed those into our development practices too? Finally, around SDL version 7, we now got this regular cadence of about once every 6 months, which then became once a year. And then SolarWinds came out. Very, very well-known, very famous supply chain attack. Then there was Executive Order 14028 came out. And then finally we had SDL Continuous Assurance, which I'll talk about in a moment. But I wanted to spend just a split second on Executive Order 14028, which came out from the White House. This was really a sort of documentation around this is what the industry should do. If you're providing software or services to the federal government, the US federal government, then you need to do these things. A big part of that is also SP 800-218, which is around secure software development. That document makes a lot of references to the Microsoft SDL, makes a lot of cross-references. In Europe, there's also ISO 27034-1, and a big part of ISO 27034-1 is Annex A, which is a complete run through of how to map the Microsoft SDL to the requirements in 27034. So the SDL has had a lot of impact across the world, not just in the US. All right, let's look at a little bit of code. So I mentioned Slammer before, which is a security vulnerability in SQL Server. This is the essence of the code. There's actually a lot more to the code than this. If you're really interested, up on my GitHub, I have a repo that actually has a more complete source code sample of the bug that led to the Slammer worm. Essentially, we've got a receive from. Receive from is a UDP read, right? Which should, immediately the hairs on the back of your head should stand up because that's a UDP read, which means that it's completely unauthenticated, right? So people are just dropping packets on the network that are not authenticated, and that's where the vulnerability exists. It ends up finding its way into SSRP enum, and that's where the problems really begin, because it can take 256 bytes off the network, but it then copies it into a 128-byte buffer, and that's a buffer overrun, right? And it's a stat-based buffer overrun, which is the most lethal of all the buffer overrun types. So what's interesting, if you look at that bug, and you say, okay, how could SDL have prevented that if SDL had existed at the time? And it basically, I'll go out and say right now, that bug could never happen today at Microsoft. And I would hope across the industry because of things that we've done in our tooling. So for example, in Visual Studio today, if you try to compile that, or Visual C++, it won't compile. Because sprintf, which is where the vulnerability lies, is deprecated, completely deprecated. So you get a C4996 warning, and your compilation would stop. Now, normally a level 4 warning is just a warning. But in the case of Visual C++, we actually stop compilation. It's an error. It's actually a fatal error. Also, if you turn off C4996 warnings, which is a bad idea, but if you did, then ban.h, which is the header file that we require, would also prevented it. Visual Studio will give you red squigglies underneath sprintf to show that there's a problem. If you use semgret, which is a tool that we use quite a bit at Microsoft, that will also detect the problem in the editor. CoQL and Prefast, which are two static analysis tools, they would find the same bug in CI/CD pipelines. How many of you are familiar with CoQL? Okay. So CoQL is a fantastic tool. It's available on GitHub. If you have a public repo, you can actually run CoQL free of charge. When someone does a pull request, it can actually just check your code statically. It's a fantastic tool. It basically creates a database of your code, and you can query it. Almost like that's the QL part of CoQL. Prefast is another tool. It's a C++ tool. If you compile C++ code with /analyze, you're actually using Prefast, even though you don't realize it. If you look on the disk, you'll see a pfx.dll, and that's the actual, it's actually Prefast. Fuzzing would easily find this as well. If all of these fail for some reason at runtime, then GS, which is a compiler option, which actually today is enabled by default, would actually find the bug at runtime and kill the process dead. And we have other defenses like address space layout randomization, no execute, control flow guard, many other defenses as well. They would all swing into action. What's really cool about those things, the last two, is they are fail-fast mechanisms. We detect there's an error and kill the process dead. Now people say, well, the process is dead. Yes, the process is dead, but it sucks less than running malicious code. Yes, it sucks. It sucks that the process is dead, but you've also got a nice clean stack trace to where the failure was, which is really nice. But yeah, it sucks less. But it sucks less than running malicious code. So Slammer was a bug in C and C++. Well, actually in C. This slide is actually a very difficult slide for me to talk about because I basically was brought up on C and C++. My very first job at Microsoft was supporting the C compiler and the Windows SDK. So you can imagine I've got a long love affair with this stuff. How many of you remember the Windows message pump? You're old. Seriously, how many of you realize, oh my, okay, how long have we got? How many of you realize that a Windows GUI app works by passing messages around? Okay, you're slightly less old than this guy. All right. Well, at least you know that. That's really important. Yeah, people don't realize, when you click on a mouse, there's a message that's sent to your window handle, WM_L mouse down or button down or something. Yeah, it's all passing messages around. The fact that we abstracted that away is kind of sad, but by the same token, that stuff was an absolute pain in the backside to write. Anyway, so this is actually a very difficult slide for me because I have a long love affair with both C and C++. But there's a thing called undefined behavior, and all programming languages have some level of undefined behavior. Here's a good example in C and C++. How many of you are familiar with the post and pre-increment operators in C and C++? Same it's in C# as well, right? So if you did something like A++, plus, A, plus A, plus A++, what's the result? It's undefined behavior. Because the compiler can evaluate that in any order it wants. It's undefined behavior. I was going to talk about Rust there, but I won't do it yet. So undefined behavior can lead to insecure code. And it's very easy to get undefined behavior in C and C++, most notably memory safety issues, memory corruption problems. And so the fourth bullet point here, it's hard for me to say, but it's time to move away from C and C++, even modern C++. The people say, well, you can write safe C++. Yes, you can, if you do it all the time and do it correctly all the time and everyone gets it right all the time, and you don't fall back to using the non-STL, the non-standard template library functionality, and there's no arrays to pointer degradation and that sort of stuff. It's just too easy to get it wrong all the time. And so it's time to start really reconsider the role of C and C++. Dave Weston, the corporate VP in Windows, we had him on the Azure Security podcast, and I said, why don't we're talking about Rust and all sorts of other stuff, and I said, why don't we just tell people use modern C++ and stick with modern C++? And he said, Michael said, that's a terrible North Star. He said, because it's too easy to get it wrong. And next thing you know, you've got undefined behavior, you've got memory corruption, you've got remote code execution. You're back to square one again. We need to focus on languages that actually allow you to write correct code from the get-go. So how many of you are familiar with this line of code? I'll just imagine all of you. All right, so this is the stir copy, right? You're copying the okay, let me explain it. You're copying the source buffer, into a destination buffer. C copies until it bumps into a trailing null. So we're always told to replace that with this. The problem with the first example, is if the source is bigger than the destination, in other words, the trailing null that says this is the end of the sentence at the end of the string, if that's bigger than the size of the destination buffer, you overflow the buffer. And now you've got memory corruption. So everyone says, well, just use stir ncopy and put n in there, and n is the size of the destination. That makes sense, right? It actually doesn't. So if you look at the way a string works, it has a trailing null at the end. That says this is the end of the string. If you don't believe me, this is what it looks like in the debugger. If you look at that the last byte there, it's a zero. It's a trailing null. So that says this is the end of the string. So here's a pop quiz for you guys. How many, and just humor me, even if you don't know what it is, just take a guess. How many of you think n should be just the length of just the data, the hello world? So how many of you think it's just that? It's just n. How many of you think it is that? Oh, come on, humor me. Okay, I'm going to say half of you. Okay, how many of you think it's n plus 1? You've got to include the trailing null. The other half. Half of you is wrong. I don't know which half it is, though. But one half of you is wrong. I actually generally don't know which half, because you should never use stir ncopy. By the way, Microsoft, stir copy, stir ncopy, stircat, stir ncat, getS, sprintf, and all their evil brethren, they're all banned. You cannot write code with those. You saw the code example I gave with Slammer. Those sorts of things will come into play and prevent it from ever compiling. So the point I'm making here is that even this simple thing everyone gets wrong as well. So we need to move to only using memory-safe languages. The good news is that the industry as a whole is starting to do this. And for me, it really falls into two categories. Actually, at Microsoft, it really falls into two categories. Rust for systems programming, low-level operating system, databases, that sort of stuff is written in Rust. And then for non-systems programming, which is kind of like everything else, C#, Java, Go, TypeScript. Notice JavaScript is not on that list. There are no words to adequately describe how much I despise JavaScript. And the fact that you are laughing means you agree with me. So let me give you some examples why I think JavaScript is an absolutely atrocious language. What the hell is going on? I don't even know what the heck's going on here. I don't know. You got a string minus a number is 8. That's a syntax error in my book. A string plus 2 is actually 102. That's a syntax error in my book too. String 10 minus string 2 is 8, a number. Okay. And actually, the funny thing was, I actually thought the next example was actually correct until I realized that the minus is before a string. How can you have a minus string? And the result is 10 minus 2. I mean, they're all different. Anyway, look, I realize there's some JavaScript wonks in here probably like cringing right now, saying, Michael, why don't you just learn the language? No. No. I'm a big believer in correct programming. Like, no, it's just correct. People say, well, that's correct. There's a subset of correct to me, which is no surprises. Let me keep going. Then you got this. Let's sort this array of bananas, apples, cherries, 10, 2, and 3. 10, 2, 3, apple, banana, cherry. Syntax error. Or this next one, 10, 10, 10 dot map parsing gives you 10, not a number, and 2. What's the next one? Oh yeah, apparently an empty array is actually the same as a not empty array. By the way, all this is actually straight just in the console, right? I've not done anything special, I've typed it in the console, in the developer tools console in the browser. Well, I mean, come on. 1, 2, 10, 21 dot sort is 1, 10, 2, 21? Anyway. Not a number is exactly the same as not a number. False. Now, the IEEE expert, yeah, there's always one. The IEEE guy is like, oh, well, everyone knows that comparing not a number to anything is always false. So what about this one? Type-defined not a number is exactly a number. True. Okay. I'm not done yet, by the way. An array plus an array is an empty string. An array plus braces is an object. Function braces plus an array is 0. Function braces plus function braces is not a number. I don't know about you, but anyway, I'll leave you with one last one. This one's one of my favorites. This is how you get the word banana. B plus an A plus A plus A is banana. So there's actually, I was going to say there's some logic behind this, but I don't think you can use the word logic here. BA, okay, I get that part, plus, what it's doing is doing plus A. It's doing a unary plus on the letter A, which is not a number. So that's where the NaN comes from in the middle. It's not a number, and then a lowercase it to hide the fact that it's not a number. Anyway, that's how you get banana out of that. Anyway, so don't use JavaScript. But you should use TypeScript. I mean, I took the exact same code, threw it into TypeScript, and look, half of them are syntax errors. Just use TypeScript. It just transpiles down to JavaScript, but at least getting that front-end correctness check, if nothing else. It's a way better language. All right, back to C and C++. So I mentioned before that if you're writing, we should really be thinking about deprecating C and C++. Again, a very, very hard thing for me to swallow because I do adore both languages. By the way, there are 2 languages, it's not one language. So at Microsoft, what we're doing is, so Mark Russinovich has made it plainly available and plainly obvious to people in Azure in our cloud environment. that there's no new C++ code to be written. It must be Rust. And we're now refactoring huge quantities of C and C++ code as well over to Rust. System code. Not an easy job, but it's something we just have to do. So some of the pros of Rust, very, very fast. When people say, oh, on par with C and C++, no, as fast as C and C++. No garbage collector. This is huge. Don't get me wrong, I'm a huge fan of C#. I actually like Go as well. But I don't like the garbage collectors, especially because you can't control, you don't have complete control over performance. In other words, what I mean by that is you don't know when the garbage collector is going to kick in, and all of a sudden you've got some delays going on. And if you've got something that's taking 1 million requests a second, you probably can't afford to take that garbage collection hit. Compile time memory safety, which I'll talk about in a moment. Lack of undefined behavior, huge detail. Again, I'll talk about in the next slide. Compiler errors are actually useful. They are really useful. You almost get like a whole screen of text explaining why the error is what it is. Massive library support, they're called crates in Rust. The last one at the bottom there is ownership and borrowing. That's one of its key safety mechanisms, this notion of ownership and borrowing of data, and I'll give an example of that in a moment as well. Some of the cons, steep learning curve. It's a huge learning curve. It takes a long time to learn Rust and to become proficient at it. It's another language to learn. You've got a whole other tool set to deploy. Evolving Windows API support. We're doing a lot of work here to provide crates that interface into Windows. And one of its biggest cons is ownership and borrowing, because it's such a difficult concept to get in your head. Rust is a huge thing at Microsoft. I actually just snapped, like literally at the airport on the way out, the Rust newsletter came in at Microsoft, and I emailed the guy, and I said, hey, do you mind if I take the screen grab of the top of this and just paste it in the slide deck? And he said, yeah, go for it. Rust is a huge deal at Microsoft. There's a whole infrastructure, a whole bunch of people who work on this stuff. It's huge across the company. There are some Rust correctness guarantees. The first bunch of them, these are all compile time guarantees. This is at compile time, not at runtime. These are all at compile time. All these buckets of things like use after free, double free, array indexing, going off beyond the end of an array, all that sort of stuff, they're all prevented at compile time. And then at the bottom, 3 are really interesting. No abandonment problems with mutexes. How many of you have written multi-threaded code? How many of you enjoyed it? You two are so lying. It's like there's no way you enjoyed writing multi-threading. Okay, you two that said you enjoyed it, how many of you, of the 2 of you, how many of you, it worked first time? Precisely. Was in Rust? Okay. Okay, yeah, okay, you didn't lie. Okay. Okay, no. Okay. Did it compile first time? No, it didn't. It compiled first time, seriously. Okay, so this is actually really important. Like things like forgetting lock mutexes. One of the big problems, you can have these things called abandonment semantics, where you can have a thread take a lock on something, and then another thread wait for it, and then this thread dies or something, but the lock isn't released. So now you've got another thread that's now locked, because this thread's gone away. How many of you know that Windows actually has 2 types of mutexes? One of them is hidden from you, you don't realize it, because it's not really raised. So back in the day, Windows had a lot of OS2 backward compatibility in the very early days of Windows NT. And so the mutex that came from OS2 did not have abandonment semantics, which means that if a thread dies holding a mutex, the mutex stays locked. And Dave Cutler said that's brain dead and called it a mutant instead, and then created a mutex that actually is the same as a mutant, but with abandonment semantics. And that's the mutex that you all know and hate in Windows, but that's the actual real mutex. But the original mutex was actually called a mutant because it had no abandonment semantics. But you got things like critical sections, spin locks, semaphores. The nice thing is that Rust will guarantee at compile time that you will not get these locked mutexes. Same with data races across threads. And this, a lot of it boils down to lifetime guarantees, which is actually something else that Rust really makes explicit. You could have 2 arguments going into a function that have 2 different lifetimes. Like one may exist inside a loop, and then in an inner loop, maybe the other variable. Well, if the inner loop finishes for some reason, that second variable is no longer valid. And Rust will actually detect that at compile time. The downside of that is that compile times are slow, right? Because it's doing all this work ahead of time. But the nice thing is, if it compiles, it is thread safe. That's huge if you've ever written multi-threaded code. If it compiles, it's thread safe. The problem is getting it to compile. But once you get it to compile, at least you know your code is thread safe. All right, so one thing that I will, if you want to learn Rust, here's something I'll tell you up front you need to know. The borrow checker will drive you absolutely nuts. How many of you have written some Rust or played or dabbled around with Rust? How many of you are hitting your head against beyond Hello World, how many of you were hitting your head against the borrow checker? Yeah, all of you. So look, I realize this code, people are looking at this code who are Rust wonks, like, oh, Michael, you would never write Rust code this way. That's true. You wouldn't, but just humor me. So here we've got in line 2, let name equals a string called Michael. And then I pass that name to a function called say hello. Now I go in there, and once say hello says, hello Michael, then I say print line again, line 6, say welcome back Michael. So what would you Rust wonks, keep quiet. Everyone else, what would you expect to see on the screen? Would you expect hello Michael, then welcome back Michael? Would you expect that? Yeah. News for you guys. See that red squiggly under the word name on line 6? This doesn't even compile in Rust. And the reason is that variable name, you've passed ownership of that variable to say hello. Essentially, the variable name no longer exists. Now, there's ways you can, look, you pass it by reference. You wouldn't even write this anyway. You would use a string literal, which will be fine. But the point is that borrow checker you're going to be mad at the borrow checker for a long time until it finally clicks. As I mentioned before, the good news is that the error messages and warnings you get from the compiler are fantastic, will really help you. There's a great talk that was done at NDC TechTown, well worth looking at. It says Rust is not about memory safety. Yes, it is. But it's not just about memory safety. I think that's a more accurate title. Let's go back to some of today's security pressures. The big ones for me are a huge need to shift left. Also moving to DevSecOps is a huge deal. And also this massive cognitive burden. I can't stress this enough. A term that we're using at Microsoft right now is the word toil. There's a lot of toil to know what to do. People are not necessarily security alpha geeks. They're just not, which is actually a good thing. Because if everyone in the world was a security alpha geek, we would never ship a software product ever again, right? Because it would be really secure, but just never ships. But you want to give people enough knowledge that they do the right things. There's huge cognitive burden on our engineers today, huge amounts. And so we're doing as much as we can to relieve as much of that cognitive burden as possible. Then we have bad actors. That's why we wrote that book, Threat-Driven Software Development, is an understanding of what the bad actors actually do and how they ply their trade. And then finally, you got things like certification and regulations. I realize these are not security. They're not, but they have a big impact. So this is where the Microsoft Secure Future Initiative came in. Think of SDL as being very, very code-centric, but SFI being much, much broader, with a big focus on ops as well. A lot of issues that we have over the years have not just been code, it's been configuration, it's been ops. A lot of the sort of precursor to SFI was a series of attacks by a threat actor named Storm 558, and they were attacking a lot of, especially US organizations, going after tokens, authentication tokens, or authorization tokens. And so we came up with this SFI, which is a big superset of SDL. It encompasses some of the SDL stuff, but a big focus is on ops, not just on code. So the SFI has 3 pillars: secure by design, secure by default. To me, they're some of the 2 most important. Secure by design, getting everything right. Secure by default is recognizing you never will. That's a really healthy tension to have. It's like, hey, let's just get all the code right. Well, what happens if we don't? What happens if we can't? What happens if threats evolve that we don't even know about? So that's why we have the secure by default. It's having secure default configuration so that the chance of attack is reduced substantially, or perhaps the blast radius, because of network isolation, is reduced substantially. The main parts of SFI are protecting identities and secrets. This is probably one of the biggest areas because of the way authorization works and the way the attackers are going after identities. Same with secrets. If I can get your credentials, and I've got your credentials. Protecting tenants and isolating production systems from attackers. Protecting networks, also including things like network isolation. Huge, huge deal. There's a big focus in SFI on isolation. Isolating networks, identities, to reduce that blast radius, assuming that attacks will happen. Monitoring, detecting threats. This is really the ops part of it. Is we recognize it. So in the red team, we found issues where there's not been good detections. The job of a red team is to apply pressure to the environment. We have incredibly skilled operators in the red team, and the whole point is to apply that pressure to our environment so we can see how the blue team reacts, and so we can find out where issues are in the environment. When I say apply pressure, that's just a euphemism for attack, but it's essentially what we do. And then finally, making sure we have better response, because vulnerabilities will happen. What's the response? How do we remediate those issues? And then down the bottom is this continuous improvement, especially paved paths, and I'll talk about paved paths towards the end. SDL supports so many of these SFI principles. SDL sort of dovetails quite nicely into what a lot of SFI does. But again, SDL is very code-centric. SFI has code issues, code concerns, but it's much, much, much broader, especially around ops. The other big change that we've had over the SDL over the last few years is to move to this continuous SDL model. In the old days, you have all this activity tracking, right? Where are your threat models? What are the results? Are you doing? You're running these CoQL queries. What warnings are you getting? Are you resolving these issues? What time frame are you using to resolve these issues? Huge checklist that people would have to go through. Massive amounts of cognitive burden. Lots of process. So what we've moved to is something that's a lot more streamlined. And rather than just eliciting, pulling the data out of things, we get these tools to push data to a central location so that things can be tracked. So we can actually see, is everything green? Sort of get green, stay green. Is everything green? Oh, there's something turned red. What's going on here? Oh, they haven't run CoQL or whatever, right? We found some banned APIs. Compiling failed because we found some banned APIs, that sort of thing. And then we can drill into things. So it's much more sort of event-focused, and it's more, considerably less friction. I'm a big fan of reducing friction. If you can reduce friction, then you can get engineers to do what needs to be done, because it's easiest to get done. Another big one for us has been detecting secrets and preventing secrets. By the way, detecting secrets means detecting secrets in the pull requests as well, so that we can detect them before they're pushed into the source code. So we'll do things like pull request blocking. What's interesting also is that we have this thing called the Common Annotated Security Key, or CASK, which is a way of annotating a secret so we can see that it's actually really a secret. If you see like some random, in some code, like just some random string, what is it? You have no clue. Is it a key, an encryption key? Is it a passphrase? Is it a secure access token to access some resource? What the heck is it? What we now do is we prepend an annotator that says this is a blah, blah, blah. So for example, this example right here, and by the way, this is a real key, which I have now deleted, so don't try using it. It says GitHub_pat. So it's a personal access token in GitHub. And so we know it's a GitHub pat. So if we see that random string and it's got GitHub pat at the beginning, you have to guess what it is. It's a GitHub pat, which means that we can detect and tell you you've got a GitHub pat in the code. And we know precisely what it is with 0 false positives. So that's really huge. So you should be going to take a look at Cask and start annotating your secrets with Cask identifiers. Makes life so much easier for finding real secrets. So the big question I get a lot, with SDL, now coming up onto 25-ish years, have we actually made any progress? And the answer is emphatically yes. Absolutely we have. Whole categories of vulnerabilities have just gone. You don't see trivial memory corruption anymore. You just don't. It's been replaced with complex memory corruption, which you could argue now the hard work starts, right? Because we found the easy ones, now we've got the difficult ones. And that's why we know those difficult ones exist, primarily because of C and C++. And so we can't fix all those things, and we can't find all those things, and we know that every C and C++ product out there has probably got some latent memory corruption vulnerabilities that are very, very difficult to spot through static analysis, through dynamic analysis. And so we have to move. And Microsoft, that big move is towards moving more code to managed languages or memory-safe languages like Rust and C# and Go, not JavaScript. However, with all that said, identity does add new wrinkles. If I look, one of the big things that I do is I look at the vulnerabilities that are found from the red team operations and say, okay, what can we learn from these things? You've got to realize these people, I made a bit of a flippant joke at the beginning about, evil people. They're not evil, they're just really, really good, like world-class talent. And you sometimes think to yourself, how the heck did they find this thing? But a big part of what I do is understanding what those issues were, and you'd be amazed how many are related to identity. Because that's the new boundary, right? The network was historically the boundary. It still is a boundary, don't get me wrong. It's a very important boundary. But the boundary now is really identity. And if I can compromise that, then I'm now in the boundary. And that's why authentication, sort of identity in general, authentication and authorization vulnerabilities are of real concern. I'm not going to go into the stuff on the right-hand side of the diagram. It's a whole nother discussion unto itself. But if you see like admin consent, unused or dangling redirect URIs, delegated permissions, that combination is really terrifying. So, and also device code flow. For any of you have a solution that uses device code flow? And you know what? Even if you did, you would never admit it. We've deprecated device code flow because it's just so dangerous. In fact, I think, and I realize it's been recorded, so I hope I'm right here. That's what I understand today is Entra ID by default has device code flow disabled by default because it's too easy to phish. So I want to give you a real example. This is a real Microsoft Red Team operation. The operator snuck into a building. There's a building, the door didn't close. By the way, I want to point something out. The Red Team, we have an objective. That's it. And we do whatever it takes to get to that objective. Whatever it takes to get to that objective. And in this example, a door didn't close properly on a building. By the way, this is not James Bond. This is a real operation, a real Red Team operation. So a couple of people snuck in and put, in one of the kitchenettes, put some little, give us your feedback on, what's the state of the kitchenette? Scan here with the QR code. That was a phishing hook. And we found an app that we could take advantage of that had a dangling URI. So if you know the way OAuth 2 works, there's a redirection URI. Well, one of the URIs was dangling. In other words, it was a DNS name, but there was no code behind it. It was dangling. So we wrote the code that was behind the URI, and now we've got the person's token. Well, actually, it was a refresh token, but that's all we need. We've now got a refresh token. We can now get a bearer token. Now we can do whatever that person's doing. Even if they've gone through the multi-factor authentication phase, we've now got a valid token that we can use. So that's a real example. Then once we've got those tokens, we could do all sorts of fun. That's all I'm going to say about the op. There's a lot more to it, but that's all. That's the bit you need to know. All right, what about the role of AI in all of this? This is a Microsoft presentation. Of course, AI is going to raise its head. We have found that basically developers plus good AI leads to incredible productivity, amazing productivity, especially around security. There are some challenges, of course. Vibe coding, we've all seen the big, people have in their job descriptions, I debug vibe coded code, because a lot of the code isn't fantastic. But if you have a very well-grounded model and you have very good examples, you can actually do a lot of, increased velocity when it comes to software development. I want to move to the last one, which is you've got to make sure you've got reliable sources for your models, your LLMs, if you're going to use them for production code. So the SDL is really adapting to AI as well from a security standpoint. You've got to think about using AI securely, but also securing AI. They're two very different things. A bit like security features, there's none equal secure features. It's a similar idea. We've now got threat modeling for AI. We're now doing things like AI system observability requirements in the SDL if you're building a system that uses AI. AI memory protections, and I don't mean RAM, I mean just the memory, the context that goes into a large language model. The middle one there about agent identity and RBAC enforcement, if you think about it, this is a classic security thing, right? Like running at least privilege, we all know about least privilege, right? And then strong RBAC policies, strong authorization policies. That's just classic stuff. That's got nothing to do with AI, but it's very important when you're considering protecting AI. Modeling, protecting models, like where do they go? Do you pull like some random model from some random place on the internet? That's just as bad as downloading random code versus pulling them down from a well-vetted, correct repository. And then shutdown mechanisms. When we detect that an LLM is being used for evil, like how do we shut things down quickly? So threat modeling versus threat modeling AI, we now push inside Microsoft, threat modeling for AI systems. If you look at traditional threat models, there's a big focus on the data and the software. But the big part of AI threat modeling is understanding those AI models and understanding the fact that they're not necessarily deterministic. Right? You may get multiple responses, different responses from the same input. So we look at things like data poisoning, like how are the models actually protected? How do you make sure a system does the right thing? So I worked on some, when I was in Azure Data, I worked on a Copilot for Cosmos DB. And a big part of that was we assumed that if you say, how do I query this database for blah, 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 we assumed that the query that came back was wrong. That was our assumption. And so we made sure that you connected as a low privilege user back to Cosmos DB when you were doing this. Because we assumed that the SQL statement that came back was going to be malicious. Because it's non-deterministic, where we don't know what's going to come back. There's other checks that we make, there's a lot of checks that we make as well to make sure that the query actually represents what you originally asked, but we also assume it's going to be rogue. So you need to think about those things when you're building systems. And then, then you got really simple stuff, just the most simple stuff. Like I've got some code up on here for analyzing or pulling apart an OAuth 2 token. Real simple query on the right-hand side there, perform a security check, around this OAuth 2 code. Every single one of these things on the right-hand side, I actually did a hand review of every one of them. They're all correct. In other words, they're all real bugs, every single one. And that query is dumber than a bucket of rocks. I mean, amounts of effort required on my part to write that is zero. And the benefit that I get from it is incredible. Now, that's even without data flow analysis. So imagine if you can start marrying static analysis with AI. So then you got more complex queries. We actually had a spate of issues inside Microsoft where there were some OAuth 2 token issues. And so we thought we'd go in and actually really look at massive amounts of source code and see if we could get to the bottom of some of these issues. This is an example of actually one of the prompts. Actually, it's abridged, so it would fit on the screen. But this is just an example of one of the prompts that we used. This next slide will absolutely blow you away. If it doesn't, I'll be shocked. I mentioned before about this cognitive burden and this huge toil on engineering staff. So one thing I mentioned before we were working on, and still are working on, is updating a lot of sort of OAuth 2 authorization vulnerabilities caused by not parsing an OAuth2 token correctly. And so if you look at, this is to do with the Entra SDK migration. So we're moving from some old code, moving the whole of Azure to use the new updated, more secure Entra SDK. If you look at the mean time to resolve, now don't get hung up on the timeframes there of 5.9 months. Man, that's a long time, but this is code that is so deep in the bowels of Azure, we have to be very careful how we deploy it. So look at a human only is 5.9 months, but with some of the new AI work that we have using agents, 1.6 months. Or another one was time to understand the technical guidance plus the actual changes all the way to a pushed pull request. 13 hours down to 15 minutes. We then measure the result to actually double check that the result is actually correct. And we're up in the 99, 98, 100% correct. Better than a human being. That's pretty mind-blowing if you think about it. So it reduces a lot of human toil. But what I want to point out, notice we didn't say AI in the right column. It's human plus AI. There's always a human in the loop. I've got some links in the speaker notes for this particular slide. You should go and look at all of these. So those figures that I showed you were before. The woman involved, Jenny Ferris, she wrote a lot of this material, and it's well worth looking at. It's how we're using agents to actually increase developer productivity with very high confidence. However, I will warn you about one thing, and that is that LLMs don't get the code right all the time. They just don't. You've got to make sure you have very good models that understand the correct, have good code as its base data. So here's an example of a quick query I wrote. Write some C# code that takes 2 strings and creates a SHA-256 hash of the 2 strings. Here's the result from Gemini 3, and it's wrong. I then did the same thing in ChatGPT 5.2, and it's wrong. Did the same thing in Claude Opus 4.6, and it's wrong. And then I tried Grok 4, and it's wrong. They're all wrong. And the reason is they're taking 2 strings, concatenating them, and taking the SHA-256 hash. Anybody know the vulnerability class? It's a length extension attack in hash functions. So basically, you never, ever take 2 strings and slap them together and hash them. You never do that. You can do it with SHA-3, but no one's using SHA-3. But the other ones you can do, but you use like SHA-256, SHA-512. This is a vulnerability. If you want to know what the vulnerability is, without going into all the details, let's say I've got a secret message, not secret, but it's an authenticated message. So a secret plus the actual message, and then hash it. The secret, or the message could be attack at dawn. But I could actually take that hash, the result of that, and actually create a new message, which is attack at dawn, except if it's raining, then attack at 1. And it will still result in the correct hash without me knowing the secret that was added to the hash. That's called a length extension attack. Very subtle, but very real. All right, let me wrap this thing up. So some core by the way, originally this was like 3 lines. And then I just kept going. So these are the core sort of takeaways from all of this. Absolutely, if you're using C and C++ today, have a strategy for moving on to memory-safe languages. Use languages that support correctness, not JavaScript. Stop the bleeding. What that means is stop writing or put processes and tooling in place to make it harder to write new insecure code. It's not going to be perfect, right? But at least stop the bleeding. Burn down technical security debt. You could argue that a lot of what SFI is doing is burning down technical security debt. Go and look at some of the SFI reports where we actually talk about what technical debt we've removed. Evolve, because threats evolve, right? As new threats evolve, so there's a big part of what we're doing at Microsoft now revolves around getting OAuth2 tokens right. Paved paths are absolutely critical. What that means is make it as frictionless as possible for developers moving forward. Standardized libraries, like thou shalt use this library. Don't go rolling your own code, use this library. Create correct and actionable guidance. Don't just say, hey, don't do this. As security professionals, we're very good at saying, don't do this, because that's dumb. But we're not very good at saying, do this instead. And here's how to measure whether you're doing it correctly. Be careful with regressions caused by security. We see this, it happens. I wouldn't say it happens a lot, but it happens when you don't want it. So be very careful with regressions that you introduce with security. You've got to automate as much as possible. Cognitive burden and toil are a huge concern on engineers today. How many of you have heard from either yourself or have heard from your staff or colleagues or whatever, just this whole AppSec thing is just a burden. There's just so much we need to do. None of you? What the hell are you doing? Oh, thank you. Treat initial AI code as a junior developer. Don't, until you get good models that produce good quality code, just treat it as a junior developer. There must be a human in the loop when it comes to AI. I've said this for I don't know how long. Security features does not equal secure features, never has and never will. OAuth code is today's the weak point. Like identity code is a huge, huge weak point. And then input validations are still a massive issue. If you look at prompt injection, indirect prompt injection, model poisoning, and so on, a lot of those are just input validation problems. That's all they are. And to give you an idea of how much of an issue this is, I actually took from the book, one of the book drafts, the identity chapter was supposed to be 25 pages long. I stopped at 60. Look at that's just the section on validating OAuth 2 tokens. That's terrifying, in my opinion. For something so critical, you have to write 40 pages of stuff. So I'll leave you with one last thing. This is from a slide deck that I wrote in 2002. You can tell it's from 2002 because it's 4 to 3 aspect ratio. There are only 2 types of security issues: input validation problems and everything else. Although I gave a quick talk of some of my colleagues and they said, hey, add this one, and off by 1 errors. Whatever. All right, I'm done. I hope this is useful. I realize it's an absolute, ton of content. By the way, that's 50 slides if you don't know. I hope you found that of use. If you have any feedback, comments, I'm going to be milling around. More than happy to take your questions. There's the feedback form up there, I hope. I was asked to add it to the slide deck, so I hope it's not a rickroll. Anyway, thank you so much for your time. Appreciate it. Well, thank you so much. I appreciate it. Thank you so much. I appreciate it. All right. Thanks again.
Yeah? Okay, good morning. Good morning. So this was an exciting moment. Hope you're all doing very well today. I am Michelle Bustamante, and I'm going to talk to you about authorization in .NET and a little bit about architecture practices at the end and challenges we typically run into in making decisions around the architecture. So I will start with saying authorization is hard, probably harder than your typical identity problem to solve, usually because of the scale with which it usually traverses your applications and your systems with so many UIs and backends and multiple micro UIs and services and every single process essentially it touches. You have to think a lot about the architecture and the patterns and the design ahead of time. And there's also different approaches that people can take. We have, your typical role-based access control, which would be, I'm a user, I log in, I have roles. We map the roles to things we can do in the system. I can show and hide features in the application. I can enable and disable APIs, I might call. But that typically turns out to be problematic because roles become misused or they grow into multiple meanings. Now I need more roles. We've had some systems where people end up with literally hundreds of roles when all they really needed was more granular permissions tied to less roles, so that it was more manageable. And then that also gave you a little more flexibility. When the meaning of role changes, you don't have to change code because it just changes the permissions you get. So permission-based access control helps us with a more fine-grained approach to authorization and lets us think at the claim or permission level. And so there's that approach. And then we have attribute-based, which is really more about providing additional data to the evaluation. Things like, additional data about the user, their birth date, the time of day they logged in, other context that could be relevant to the evaluation. And then in addition, we have resource-based, which would be, how do I make a decision based on the resource I'm trying to access right now? So it's one thing to log in and find out, you're a user with these roles, and now I have these permissions, and those are typically, birthright assignments, meaning they're fixed, they're not conditional. And then we've got the conditional evaluations, which are the attributes or context. And then on top of that, we might have to look at, do I own the resource? Therefore, I'm allowed to access it. Do I belong to the company or tenant? Therefore, I'm allowed to do certain things within that tenant. So it becomes additional layers of what we would call context to add to the evaluation choices. And then, of course, policy-based would allow you to combine all of these things into one thing so that you can ask different questions and evaluate based on, roles and permissions and attributes and other context and the resources we're trying to get to all at once. So these are all, again, complicated in the sense that you have to have an idea of your design and your plan so that you can imagine how this will traverse many, many services, many applications. So that's part of what makes authorization somewhat hard, is the thinking in advance and the planning. And then we've got just the fact that there's no one solution. If you look at a new system at every single company, it will be different, the way they've approached authorization. Some of them bake it into the application, completely custom. Others try to centralize it in its own system with a proper, solution that is auditing and providing compliance and regulatory considerations. And then there's so many things in the middle of those two extremes where they have them in the identity system or they have them in some other custom code that's external to the application and shared, but not a business system. In the past, we used to build systems on something called XACML, which is a terrible XML, language for authorization that typically was embedded in appliances like axiomatics, in government with heavy use, not so popular with day-to-day programming, of course, because it was terrible to work with. And then, of course, now we have AuthSend, which is a new and up-and-coming protocol for interacting between your applications and the place you do authorization, which is really just trying to standardize every system you talk to that it talks the same language in case you have to talk to many, or so that people can write code and switch systems and it still works. This is still evolving, and so it's not really the point of the talk as much as to say there's a lot to think about when you get from here to the idea of writing code and authorizing to what do we want to do to scale across our entire system or ecosystem. Okay, so many things to think about. But, let's start with just the fact that it's design intensive, which means the thinking has to happen somewhat up front. And of course, we have to overlay that with the how. What can I do in my actual code, depending on the tools I'm using? So we're going to focus on some of the things we can do in .NET. So I'm going to start with authorization is not equal to authentication or vice versa, right? So authentication is who are you? I've logged in, you have my user ID, you have information, maybe a few claims about me, my email address, whether I'm active or not, what my user state is, the time that I logged in, things like that. But typically it should not contain anything to do with my authorization in a perfect world, because of course, my identity system, is issuing tokens carrying small number of claims, and we don't want to bloat the tokens with tons of roles and permissions because that's a problem as well. So we typically like to separate the concern from you are authenticated from you now have to collect information about what are you allowed to do, because that can grow as you go to each application and API. So just starting with that coupling that we frequently see people do, I'll just say that, again, what happens when you couple authentication and authorization also becomes, the idea of role explosion, where you suddenly are adding more and more roles to make up for the fact you don't have permissions, because usually identity systems just deal with roles. And so now we're, again, new meanings to authorize over here and there. We have new roles, more roles. Now we have hundreds of roles. The thing about token bloat is the bigger problem. When I authenticate to an identity system and come back, if the tokens are too big, then during the redirect cycle, the browser just doesn't know how to handle those cookie sizes or those token sizes. Even if it's a server-side redirect, eventually there's a cookie involved within those redirects. And that frequently gets blocked by API management or other gateways or firewalls because they have limits. And even just recently, Azure had a firewall or Azure APIM change to the size of the headers, and a bunch of folks that we work with that are doing authorization using identity server and some other, again, token sizes that were extreme, suddenly stopped working until they fixed the setting. So things like that can happen. We want to avoid that. The other thing is, how long should the user's permissions or roles be valid? Caching and invalidation becomes a thing. And if you're logging in and you have an SSO session, those claims are fixed in the JWT or in the token. And now, how long should that be valid? If I'm using that token to all of these APIs during my session, what if we change my permissions? What if we take me out of a role? There's all this caching to think about as well. So again, lots of these are reasons why we don't want to couple authentication and authorization. We also don't want our identity system to be polluted with business logic around why I have a role or not, or how I assign a permission. And so again, just the idea is if you can keep it clean, keep authorization out, identity is pure, authorization is a different problem to solve. Equally as hard, maybe even harder, but at least don't couple them. So each application will have different ways to handle the authorization once we've decided, okay, I have a user, now let's find out what they can do, let's gather their roles, permissions, claims. So we might, again, just require that the user's authenticated and check that they have the right scope for a token, for an API in their token. That would be an identity concern. That's fine. When we get to API scopes, again, also an identity concern, but it's authorization of really the application calling the API, not the person or the user. And then we get into roles, permissions, claims, and then other rules that we might have in context. So the extreme, of course, being centralizing management to a third-party system. So let's go ahead and just talk. I'm going to do a bunch of demos showing many different ways to do this. I wanted to provide you with some context up front before. So, the basics that we will always see is you're probably going to, in your application, set up OpenID Connect login to an identity system. So we'll have your typical, add authentication, where you set up the scheme, and we're redirecting to an identity provider. And then we're going to indicate, obviously, which is the name and role claim, all of the basics for redirecting and setting up a session in the app before we do authorization. And then when we want to prevent access to anything that should not be anonymous, so imagine that my application has maybe a home page that's anonymous, but everything else requires authorization, at least that you're authenticated to start with, then I would add authorization and, inject into DI services whatever I need in there, like logging capabilities and other context. And of course, start by requiring authorization, which would give me default behavior. So what I want to talk about is, what do I get by default out of the box, and what can I do from there? The other thing that we might talk about is, again, how do I, if I protect the entire application with default authorization, start exposing some endpoints for anonymous access? And the old way back in the day was to use attributes. So, I authorization data handlers that would allow you to say anonymous, or, imperatively ask for permissions or roles or other things. So we're going to have different ways that we might expose an anonymous endpoint. But we're not going to use attributes, because instead of the reflection-based of the past, now we have minimal APIs, and we have razor pages, which allow us to do inline, and it's actually compiled. So it's a different process than previously. So with that said, I'm going to go ahead and do some demos. So let's see if you can see. Can everybody see that at the back? Or do we need to make it bigger? It's okay? A little bit bigger? All right. I didn't get a chance to do that while we were setting up in here, so up front needs the bigger. Yeah. Forgot the glasses today, right? Okay, so let me just get a font going here. Okay, sorry about that. Now I have to find my settings. And text editor, there we are, sorry. Maybe I need the glasses. So I'm going to make that 20. And it's probably going to be, not a lot of words on one page, but we'll be fine. Now we can see that, right? Okay. All right. So, and of course, I'm in the wrong browser. I'm in the wrong one. So maybe I should have done that over here. Can we see this? I think it's just the same size. All right, so what I have here is I have an application and an API. My user interface right here has a setup for identity, which we've already talked about. It's got, adding the razor pages. It's got add authorization, which is the default services, which will basically be make sure the user's authenticated. And then, of course, somewhere down here, we say we want to use authentication authorization, get it into the pipeline, and then we require authorization at the end. So what that will do is, by default, secure all of the pages. And what I'll do is just give this a run. So I think it's probably already running. So this is my web app. And what it'll do, this is running with Aspire, by the way, so I can get logs and things right here. So this is my web app here. And it's going to ask me to log in because, of course, all of the pages are protected. So if I log in as Alice, and oops, I have to type her password correctly. Alice. Okay, I can type. So we've got a home page that tells me when I logged in. We've got, a couple other pages, one that shows my claims. You can see I've got a bunch of things coming back from identity because I've put all my roles and some features and tenant data, which we'll talk about. And then we got some buttons for calling APIs in different ways for authorization. So at the end of the day, these are the pages that I have accessible right now. So nothing really much to see there except for that it was protected until I authorized myself and authenticated. So because this default require authorization is applying to everything, then I'm going to need to go to my, index page. And if I want to allow anonymous, I can come in here and I can do the old way, right? So this is adding the attribute that will allow anonymous access. And if I just quickly break that and build and run it, and we'll run it again. So that'll refresh my Aspire here. And now this time it lets me in, but I have to sign out to prove that that'll work. So now I have access to the front page and it doesn't send me to log in until I go to the next page. And now I can be Bob, and Bob has less claims, but despite that, I can still get into these pages for now. Okay. All right. So all that did is illustrate that, allow anonymous is possible at the root, but this is also the attribute-based kind. So we're going to go back into my program CS here. And, again, this will do the default authorization, but it doesn't speak to, maybe having more granular for per page settings. And you don't do that at the map Razor pages because this actually is an all or nothing kind of application. So whatever we put here is for the entire suite of pages, because Razor pages is simpler than the MVC controller approach where you could go per method inside a controller. But the benefit of this approach is that we're doing it all in a declarative way elsewhere, and we could later do reports on where are all the places using the policies to do authorization, rather than having to go inside each page and check endpoints and things to figure it out. It can actually be done without doing that reflection. So we're going to scroll up here, and what I'll do is instead of doing add Razor pages this way, we'll do it this way. Oops, yeah. How many people love the IntelliSense in Visual Studio Code? Right? Okay, so what I can do instead is I can add options to make the index anonymous this way. And I can also do other things like add additional policy evaluation to different pages. I won't do that right now. I'm going to show that later. But bottom line is this is another way to apply on a per page basis if you like, so that you can get that granular list and have a way to discover it later. So I'm going to go ahead and break, and we'll build, and we'll run, and we'll go back here, and this will refresh. So maybe I have to click that again, and this will load it up again, and I can still get to this page, but I'm going to sign out and see if I can still get to it, and I can, but then it'll make me log in again, and I can go Bob, Bob, Bob. Okay. So, all right, so all I've really illustrated here is some basics, right? So we have the default policy. So when we think about the default policy, out of the box, it's are you authenticated? That's it. Doesn't check any API scopes at the API. It doesn't check any other details. But there's also a thing called a fallback policy. The fallback policy does nothing. So if you don't apply the, require authorization here, then fallback policy says do nothing. So if you want a system that's secure by default, where you have to opt into the anonymous, then the ideal scenario would be to make the default policy match the fallback policy, which I'll show when I go to the API. So that's one sort of general tip. So right now what I have is the UI. I'm going to go to an API and show a different set of approaches here. So let's go in here. So for the API, we have a different setup for authentication where we're doing authorization with a bearer token. We're expecting to have a token that's valid and hasn't expired, and we're expecting that it comes from the same identity provider as the UI was authenticating to. So this will go ahead and map my role claim and my name claim and just make it possible for us to evaluate that in the user principal. So it'll hydrate a user principal, attach it to the context so that everywhere I go in the API, I can get access to that and validate whatever data I get out of the token. So when I add authorization here, it'll again add the default authorization policy. And then if I scroll down here, after using authentication and authorization, my next job is to create the endpoints. And so with minimal APIs, you don't do the controller where you have multiple, different controller endpoints where you're decorating those with authorization. Instead, we're actually mapping them here, and we can supply the policies we'd like to authorize. So right now, my default is going to be just to check that there's a token. But what I can do is I can start adding, what policies do I want to add here? Like, for example, require authorization. I could just say I would like to require that you have, a user role, for example, in your token. So let's see. I think, well, that's not true. No. There. Okay, I guess you have to type it harder. Something like that. So anyway, I have an API here. It's going to require authorization. It's going to require that I have a user role right now. And so, I have to have a user that has that role. Let's go ahead and run it again. And so my UI, when I log in as Alice, has admin and user. When I log in as Bob, I have a user role. When I log in as Chris, I'm going to have, neither of those. So what I'll do is I'll log out, log in. So we'll grab Chris. And then now you can see I have a guest role. I don't have a user role. So when I go to my claims, I can see what I have in the UI from my ID token. When I call, this endpoint, it says forbidden because I don't have the role that's being required. But if I sign out and sign it as somebody that has the user role, so we'll sign it as Alice, who has more superpowers, right? User and admin role down here. So we'll go ahead and call the API, and of course I get in, right? All it's doing is returning my claims. We're good to go. So all that's showing you is, okay, so I can go to the endpoints here and I can start identifying, policies for each one. Right now, this is saying, oh, and by the way, this is minimal API, so I can map the same code, which just returns the claim, to any number of routes I want. Just to keep it simple, that's what I did here. But the decoration for authorization doesn't happen in the code base where this is declared. So if we go to the endpoint, this is just a class, right? It's just a, just a method that you can apply to any number of endpoints. Okay. So basically, the first one is just require authorization there. So what I can also do is instead, I can start creating policies that are reusable. So this is where it gets a little bit more powerful. Up here, what I've done is add authorization without any specifics. But what I can do here, actually, I'll just do this here. The IntelliSense is awesome. Yeah. But I don't want to turn it off because sometimes it's actually good. So, okay. Yeah. So we'll just do this. Yeah. Okay. So what I'm going to do is take just an example policy here. So we'll go ahead and I'm going to create a new sort of default policy, basically. So we'll do this. And yeah, I want to do it that way. Oh my gosh. There we go. Yeah. I'll get it right as soon as I get past the IntelliSense. You'd think it would be helpful. Okay, so let's do this. All right. And of course, one more. Okay, so what I'm trying to do here is create a new policy. So instead of attaching to the endpoints individually, what I'm looking for here is you can create a policy builder and you can add one or more things to it. The default would have been add authenticated or require authentication for the user, but I also kind of want to make sure the API scope is there. So I want the API scope that I've passed from the identity in my token, that I'm validating that. And then of course I can add on to that the user should always require the user role at a minimum. I could just say that as a base requirement across the board. And then the other thing we can do is we have a default policy, but if you want to be secured by default, you may as well assign the fallback policy to the default policy, which means whatever that base policy is you're requiring, you're going to do that the same on both, okay? And I think I have to do this. And then oh my goodness, yeah. It's really annoying. Okay, so let's do that. Oh, thank God. Okay, so basically what I've done here is I've created a new policy that I've added as the default, which means it's going to apply to all of the endpoints. So I'm not using a named policy yet. And I'll go ahead and break that and build it and run that and go back. And we will refresh in here, which means this is already refreshed, so I can go home. Now I'm logged in as Alice, so I should have plenty of claims. So I've got my admin role, my user role. So if I call the API now, the first one, if you remember I called before, it said, I want you to have the user role. And I do, so I'm in. But these other ones were not protected before, and now they are, because I've added some more, I've added a better default. So what I'm gonna do is try again, and now it'll log me in as Chris, who doesn't have any of those roles. He's a guest. So when I call APIs with Chris, I will get forbidden here, but I'll also now get forbidden on all of them because the default policy is requiring that. Now, if I come in here and make a change like API 2, maybe I misnamed the scope. So now I'm requiring this base scope to make sure that my APIs are secure. So I'll rebuild that and we'll run that. And now when I go back, and of course, this has to refresh, so it will. And then we'll come back in. Of course, click the link. And I'm logged in still as Chris, but now if I call any of the APIs, I'm still going to get errors. Probably the error could say something better, but basically I shouldn't. It's forbidden for a different reason because now the APIs are not going to be secured. So if I log in as Alice, I'm still going to have the same problem. So we'll go ahead and log in as Alice, who has all the claims, and we'll go like that. So we'll call the API. Oh, I lied. Oh, here it is. Okay, so yeah, the default policy, I should have been allowed in, but because the API, it's applied to that API, because I didn't provide a new policy to replace it, the default policy is being invoked, which is saying the wrong API scope. So it's only failing on these two because the other one has its own policy, which didn't include the API scope, if that makes sense. So anytime you place a policy, it overrides the default, which overrides the fallback. Okay. All right, so let's go back. So now, good idea to have a default and a fallback. Probably not a good idea to require a role in there. Maybe a good idea to require your API in there and that your users authenticate it. So we can make a change there. So what I would like to do then is start looking at how do we add policies that can be, reused. So what if I had an admin endpoint? I want to make sure that the endpoint is called only by people that have the admin role. So I can create a new policy. So when you call configuration add policy, what you're doing is you're adding into the pipeline another policy to be, evaluated. And so I'm not adding it yet. I'm just configuring it. We're going to place it in the pipeline by attaching it to one of the methods, okay? And so when I require admin policy, that is the name of the policy. And I'm just saying require role, which is something that you can do. You can also do that in other ways. You can say require claim. And that could say, you know, role admin, right? That was a good IntelliSense moment. And then you can, you know, do like additional things like add requirements, and then create a new instance of something that is called a requirement. So all of these are equivalent behaviors that are asking for the admin role. I don't have to do all of them. I'm just showing you interchangeably that require claim is there, require role is there, and all those are is examples of essentially requirements. So if I take a look at the definition of that, it's an I authorization requirement. So that's the infrastructure beneath all of this. When you create a requirement separately from the actual handler for the requirement, you're able to inject things like loggers and other context with DI. If you create an admin requirement without separating it from the handler, so where the I authorization requirement is bundled with the handler, then you can't inject any DI. So really, you'll typically separate these things for more flexibility. And the idea here is, it's just saying is enroll admin, right? So I'm kind of hard coding, this is an attribute and an authorization requirement that only applies to one role, not very flexible, but illustrating how the base works, okay? Whereas this one with DI is separating it, okay? And inside, again, is still doing the is enroll. It's just, you know, now I can have a logger and other things that I inject with DI. So that gives you a bit of color. So here, what we're going to do is, again, I can do require role, I can do require claim, I can do add requirements, any of those things. And now it's not going to be used until I apply the policy somewhere. So what I'm going to do is scroll down to where we set up the map, and I can go ahead and in here, add the admin policy, for example, okay? And then here I can say, you know, add admin claim policy. So again, all I'm doing is showing that each of these endpoints, one of them is just looking at the token, which is why it was called token on the button. This is saying I'm going to evaluate roles. This is saying I'm going to evaluate claims. And it's just showing different ways to apply the policy. So let's go up here and we'll grab a claim policy right here. Again, simple example of the same. So I have this policy here for requiring admin, and now I'm going to have a separate policy for requiring admin by claims. So this is right again in line where I'm doing the required claim that I showed you up here. Okay. All right. So let me give that a run, and then we'll look at some other things. This is really short. Kind of have to do this. Okay. So, looks like that's ready. And here I am. So I am logged in as Alice, who has all the power. When I call this API and that API, those first two are happy. Actually, role and claims and token are all happy because I have all the roles. I can do all of these things, right? And that's because when I look at my claims, you can see I have all these roles and features and things. So I'm going to sign out. I'm going to log back in as Bob. And Bob is going to only have the user role. So we can go to Bob and we can try this guy. And I have the user role, so I got in. Oh, actually, that we took it out anyways. So that's just checking now my token is the right scope and I'm authenticated. This one I'm forbidden, and this one I'm forbidden because both of those are asking for admin, okay? All right, so having done that, again, all these are just examples of configuring a policy. The point is, you know, you want to do the configuration, you want to be able to reuse it, so then you have to think about how do I want to bundle these things. So if I scroll down a little bit further, something else we can do is we can do something of an external policy. So instead of having the policy, coming from my claims, because so far I'm showing you doing what I said not to do, which is, we're putting things in the token that have features and have roles and have, additional data about the user, which would be just their normal claims. So we want to get away from that. So we want to think about, where do I go and get policy? And there are different tools for that, right? You can use OPA, which would be a way to invoke a policy and get a decision. You can use things like, just your own custom code and load. I have a little tool that loads it from it's just going to load a JSON, right? And it's going to pull that policy in. So what I'm going to do is create this thing called an external policy. And what this will do is, call the external policy requirement. So if we go to the definition of that, there's a list of permissions it's going to look at. It's got an external policy requirement, which is just a marker class for the requirement itself, so I can use it in code. And then that leads to the handler, which again is going to load up some policies from config. So that's going to load up the local policy. It's going to inject that with DI, so it's loaded once and pulled in. So you can imagine if you had a policy cache or something like that, where something else, an engine is loading up as you go through the system, additional data about what you're allowed to do throughout the features of the system, then you can inject accessing that cache into a central policy handler that can access the cache to do those things. And then you can make those permissions or roles expire in the cache so that they're not there forever. If maybe some of them should have rules like it's only valid for 15 minutes, for example, and then we got to refresh against the database so that you're not holding on to your permissions all day in case you were removed from the company or something. Okay. So basically it's centralizing everything. And what it's doing in here, just as an example, is instead of calling a cache, loading from the JSON, and then somewhere in here, obviously, we're going to, check to see. We're going to get the permissions from the metadata of the endpoint, which I'm going to show you in a second. So the job of this policy and the endpoint configuration is that you can decorate your endpoints and say which permissions I need. So instead of doing roles, instead of doing claims, instead of bundling those into an attribute or a requirement, we now have the concept of the requirement is a flexible, reusable thing that looks at the metadata on the endpoint, just like Swagger would be metadata, right? And it will check what do I need and enforce against that. Okay. So this is where that happens, right in here, right? So we're going to check the permissions. And then as long as we haven't failed, we're going to go ahead and, evaluate and see if we have the right permissions. And as long as we have them, we can succeed. So that's the idea. Now, if I go back into program, this definition is just saying, hey, here is the external policy requirement that you can apply using external policy as a name. So let's come down here and let's add the external policy requirement as a transient object, right? So we've got that injected so that we can use it. I didn't show that earlier for the admin requirement DI handler. So when you separate the requirement from the handler, then you also need to, instantiate the handler in the DI system here, okay? And then lastly, what I'm going to do is show you sort of a different thing here, and that is, okay, so let's say we want to bundle endpoints so that they all have a default policy at the top for all of the sort of the root and all of the sub routes. So you have index, WAC, and then you have all the other endpoints underneath, right? So say you have a feature tree, feature 1, area, 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 feature 2, area, area, area. You could have a default policy for feature 1 and feature 2 where it knows where to go get the policy just for that area of the application, and it can load that into the cache separately from feature 2, separately from feature 3, and you can start to scale this out with your design. And the point is, you can still make, so what this is doing is it's saying, let's do the default require authorization. Default policy will be invoked here. And remember, default policy is checking the API token and that user's authenticated above, because I've already written that as a new default policy. And then so this group will be, everything from the root of the group, right? And what I'm doing here is saying, okay, so the default is just my index, which is list claims, which we started with before. And then I have my WAC roles, my WAC claims, and my WAC policy. So 3 different endpoints. They're all returning claims, so the code inside is irrelevant. It's just I've got a route that's going to invoke that code, but it's not going to get there if I don't pass authorization first. So I still have the require admin and the claim policy, and now I've got the new external policy that will be invoked for this WAC policy endpoint. And so notice that we have with metadata. So now I can add, color to the data available to the endpoint, and it's all declarative here, which means, again, we've generated in the past some tools where we go and inspect and can report all of the different endpoints and the required permissions for them and the policies they use in a single view, just using like a unit test even. You can just traverse the system and output that, which makes it really convenient as developers to sort of have a sense of what are we actually doing in the code instead of having to go look at each, MVC controller and looking at the attributes and trying to decipher all of that, right? So it's quite handy. So the metadata here is really just adding to it that we're using a policy where I'm loading, the missions evaluation is my local policy. And it's basically got I'm receiving identity roles, admin, and I'm going to map that to a role that's my application role. So the idea is identity system, or Entra ID or wherever you log in might tell you you're in the marketing department or engineering department or some basic roles that are part of the business. We never want to couple our authorization behavior to business things that could change. So instead, we map it to what my application cares about. How do I want to group my permissions? What are I going to name my roles? What's my convention? And then with that, we can, have a new application role from the identity role. Typically, that's how you would do it. And so we're going to have anybody who's an admin has the app admin role. Anybody who's a user gets the app user role. The subject IDs here, 1 is Alice, 2 is Bob. Chris doesn't get anything. The permissions that I'm assigning are based on the role. So the user's getting read, the admin's getting list, and so on, okay? So what this is doing is applying my permissions. Okay, just again, a simple example just so that we can illustrate. So this external policy is going to read the policy from the JSON. It's telling it which one, because there could be many. And then it's going to require that you have list permission to get in to the endpoint. So remember, Chris doesn't have list, only Alice is going to have list. So that's what we'll do. I'm going to break this here. Okay. And we'll give it a compile. All right. So let that refresh. And we will try it again. So I'm Bob right now, which means, I'm allowed in here. I'm allowed not here. Right? So my policy won't work because I'm Bob. I'm going to log in as Alice, and Alice is going to have more privileges. And so now we know Alice has admin, which means she's going to get app admin. which means she's going to get the permissions we need. So we're going to call APIs, call data, and we're in, right? So again, that's just illustrating again that, the central thing now can have decoration on the APIs, tell you which permissions, tell you which policy to evaluate. That could be done in lots of different ways. Again, if you're using OPA, you can do it that way. If you're using another tool that's an external authorization tool, you might be able to use the same concept. So you're wrapping all that up, the other logic, in terms of where we go to validate inside that evaluator. Okay. All right. So, a couple other things. So I want to get to we're going to go through a couple of other things. I'll give you an idea. So we're going to look at step up, because you can use these authorization structure or infrastructure for step up authentication as well. Like you don't have MFA redirect. You can also decorate your UI. So we have some other problems still to solve, right? Just adding requirements is not enough to figure out, how do I apply this across all my APIs or all my UIs or all my pages that have buttons and things that I want to hide and show. The other thing to consider is that these are decision-based, right? The whole logic behind the authorization components in ASP.NET Core here is it's decision-based. So it's not really returning you a list of permissions or roles that you can use to hide and show things, which means it's going to get pretty chatty when we think about, how do I apply this to a UI and make it scale? So it may not be the best thing for that level of detail. Okay for APIs, because you can cache the results and have them expire after a time, but not necessarily okay for, I have a whole bunch of things I need to hide and show right now, and I need to kind of get all that data at once, which means I need multiple decisions, right? So just something to think about contextual, or in terms of context and applicability. So what I want to do now is, again, we've got this concept of the metadata. The other thing that I want to do is look at the concept of feature area. So what I'm going to do is I'm going to uncomment this guy. So this is just illustrating the power of, also the minimal API and the fact that you can have routes and layers and dynamic routes. So I have, for example, maybe features, and I might have feature A, B, C, feature 1, 2, 3, whatever their names are. And what I'd like to do is create an authorization policy that's able to take whatever feature comes in and have that, look up based on the feature. So if I build a path from features, feature 1, features, feature 2, then I want that path to be able to, authorize based on my central authorization system that might have configured what roles I have in those areas. So I need a place that I can scale that and manage that. So I used the JSON as an example of loading something. And I'm going to quickly use Policy Server to show like a UI so I can illustrate turning something on and off and have that work, because that's easier. But the point is, you can do that with OPA, you can do that with custom code, you can do that with external systems. And so the progression you're seeing here is, I can write little bits of code that say, I require this role, I require this permission, and I can make those reusable, and I can put them in a shared library, or I can put them in a YARP, proxy and have it check before we get to the API, or a sidecar in containers. That's all fine. But ultimately, when you get to a certain scale, you actually want it out of the application and into a centralized place that you can manage and audit and have some level of controls, like maybe even a roll-up, like at this point in time, that user had these snapshot roles when the incident happened, ... So again, there's the, simple, just I need to secure my app approach. There's the I need to scale it to multiple APIs and apps, and I might need to put it into, again, a shared area like the YARP proxy or sidecar. And then that custom code is, going somewhere. Even if it's OPA, you have to write all of that. And then I'm using a system. So that's the progression. So in this case, I'm looking at having features and routes, having them essentially authorized. And what we're saying here is, so I want you to have either the admin role to get in here, or you have to have the read or list. This is just a little mini DSL. The code's in the sample, so you can see that too. That's not really relevant to authorization. It's just convenient for reading, so it might be fun to look at later. So basically, again, I've got that list feature area endpoint, and that's just going to be some code that returns some data based on you getting past the authorization gate. So not much to look at there. The most important thing is the authorization piece, because what we're going to do is we're going to go down to evaluate and have that use like a tool that can go to a centralized system. So I'm using Policy Server as the example for this. So let me just illustrate something for you here. So I have like a policy called features. It's got feature 1 and 2. If I go to features and I take a look at, the roles that I've defined, I've got admin and user. And if I look at admin, I can see that, Alice is assigned to admin, which means she's going to inherit under feature 2 that same role, right? So she's inherited. And then ultimately what I want to do is see, what permissions I'm going to get. Well, if I'm Alice, I'm getting all the permissions because the admin role is assigned all these permissions. And then if I go to feature 1 and I go to user, then we see Bob has been granted the user role under feature 1. And then if we go to feature 2, then we're going to see Chris has been granted the user role under feature 2. So we're looking at feature areas in the application and what I should be able to see based on a policy that's external so that we can, demonstrate that. So I'm not sure if I compiled this, so I'm just going to do that real quick. And actually, let's make sure I've added all the things I needed to add. So what I was showing you here is adding another route separately from the group and giving it a policy to execute against, which is the, authorize with policy for server builder. So this is another way to build. Instead of just requirements, you have a builder that produces the entire stack for authorization. And then up here, let's see. I want to illustrate that we have a runtime client to call it. I want to illustrate that we have a centralized policy requirement handler, right? So this handler here is, the handler that is being used to sort of tee up the policy server parts, right? So basically, it's going through the metadata and it's getting the route, features, WAC, feature 1, features, WAC, feature 2. So it's building the route from the actual map. And then it's using that to go and evaluate the policy for that path, whatever the policy path is, and pass in the user for context. So now we're using context-based because we're passing in user context, profile data, whatever. And we're using policy-based and the route. And we can also use tenant-based, like if you're in tenant 1 or tenant 2, do you have access? Because that's additional context you can do in some of these other utilities. So bottom line is now we've got our kind of everything set up as it should be. I'm going to make sure I've compiled, and then I'll go ahead and run it again. So security is exciting, right? Yeah. Okay, so let's see. I'll go back to the UI. My claims are I'm Alice, so I got lots of features. I'm gonna go to policy server evaluation. I go to feature 1, I go to feature 2, I get in. So that just means it works, right? So let's see it not work. So I'll go in as Bob. And Bob doesn't have, well, he's got feature 1. So Bob should be able to get into feature 1, but he can't because something's wrong. So now we have to figure out why. and then I'm going to log in as Chris. Okay, so Chris, and he's not getting in either. So let's go see what could be going on here. So I'm going to go into my permission assignments, and didn't we say we needed the list assignment, right? So under feature 2, I'm adding the list assignment, and now I'm going to go back in, and I guess I'll run that again. And now feature 2 works. So centralized policy, change whatever you need to, dynamically gets the update, right? So it's not cached or anything. Which means now if I log in as Bob, as long as he's got feature 2, it should work for him too. So let's go back as Bob, and we'll see if he's got feature 2, and he doesn't. So that means somewhere in here, you know, when we look at feature 2 and we look at the user role, it's only Chris. And we look at feature 2 and we look at the admin role, it's only Alice. So that's why Bob doesn't get in, you see? So if I were to add a user and put Bob and then come back again, then I can get feature 2. See what I mean? So all that does is show you how to wrap up, you know, into a reusable component. So we've gone through simple requirements. We've gone through adding them to the map. We've gone through having the map for the API actually structure hierarchy and metadata that you can read from with the policy. We've talked about, you know, putting the code in place here, loading it from a JSON or AKA whatever you like, including potentially a third-party thing where it's a system. So all those things are possible, right? And then the other thing that I want to do here is I want to take a quick journey back to the UI, where we really only did a couple of basic things at first. So let's go here. And one of the things I want to do is take out the authorization that was the default. And what I'm going to do is add authorization and add a policy called recent login. So what it's going to do is expect me to have logged in within a minute. I'm also going to add a features policy, and its job is going to be to allow us to have feature requirements for, you know, each of the pages and buttons that we can apply either to an endpoint, or in this case, what I'm going to do is add a tag on the actual Razor page that will prevent access to a button based on the feature. So, so first of all, this is going to do a step-up authentication for me. So we'll try that out. And then what I want to do is add the feature. So we got our feature requirement handler. So the feature requirement handler is going to be showing, just checking that I have a certain role to the feature. So I guess we're not going to, that's not teaching anything much new that we already looked at, but it's going to be applied somewhere, which is why I want to show that. And then down here, we've already got all of these. Oh, wait, am I in the API again? Sorry, that's not where I want to be. I think that's why I was confused. Let me just make sure I didn't. No, I think that just popped me over. This is where I was. Yeah, this is where I was. Okay, so feature. Then we have, let's see. And then we have the basic require authorization. Okay, that's fine. And then lastly, what I want to do is I want to add the tag. So let me go to security here somewhere. I have a tag helper. So its job is to let me attach tags to, you know, Razor resources that I've applied. So I can have an AZ policy saying what policy to evaluate. And I can have an AZ resource indicating the thing I'm validating against, like feature 1, feature 2, et cetera. And then what this will do in here is when it processes, it, you know, takes the attributes out so they don't render, and then it checks the authorization against the user, the resource, and the policy name. And if it succeeds, we continue. And if not, it suppresses the output, which hides the button so that it doesn't appear. So now what I'm going to do is go to the call APIs. And I'm going to uncomment this guy because he's ready to go. Time of the essence. And so what this is doing is you can see AZ policy feature. So I'm executing the features policy. And I'm saying the resource is feature 1. So if I have feature 1, I should see this custom button. And if I don't have feature 1, I won't see the button, right? That's the idea. And then, yeah. So the feature requirements handler is just being used by the AZ tag helper to tie it all together. So let me go ahead and build that. Okay. And here we go. So first and foremost, let's sign out and sign in again. So I'm going to be Alice at first. And Alice has all the features. So, she always has everything. So we're not calling APIs this time. We're actually going to the API button. And what you can see is I have a new button called data feature. So that's because she's got everything. The other thing you'll see is it's been 17 seconds since I logged in, not quite long enough to do a step up. So it's not going to do a step up just yet. But if enough time passes, then it will, do the step up. I'm going to go ahead and log in as somebody else, though, just so we can show that too. So I'm going to go to Bob. And Bob has feature 1. So he is also going to see the feature. So it's going to be Chris, who's the guy that won't see that. We'll just go in as Chris. And Chris has guest and tenant 2, local. And he does not get the feature, okay? So we see that the tag is allowing me to apply policy at that level. Now that's still gonna do a decision per thing. So in order to cache decisions for every single button and area of a page, it becomes interesting. You can imagine I'd rather have just a list of things that I map to the hide show. Might be easier. I've also seen some folks that we've worked with who automatically generate from metadata on their APIs, CI/CD, scripts that will actually deploy all the policies and actually generate tags and things for the UI. So it all ties together. If the API is enabled, then you get the button. So it's kind of, there's so many things that you can do to help automate and tie everything together. But anyway, it's been 53 seconds. Let's see if it works after it's been a little longer, right? Not quite. I'm 1 minute off. Or no, I forgot to enable something. No. Okay, let's see. Recent login, offset, yeah, that's on. Oh, I forgot to do something. Well, you'll just have to trust me that works, because I probably missed something, so. All right, so just to kind of close up, I've gone through all of this. I think the main thing that I wanted to sort of get to at the end is that, all of the things that we've just talked about are bundling up layers of the authorization story, right? So again, you've got your roles, you've got your permissions, you've got your attributes. If you want to check the time, for example, that would have been an attribute-based, the one that you saw work. And then, context-based is more like bundling it all together, where I can go in and I can see, like, if you're in a tenant, for example, like if you went over here and saw, like, whatever, I have, contacts and I have tenants. And if I pin the tenant, then I can start, adding roles to users only within this tenant, and now I've got context, things like that. So the idea of context overlays with all of this. The idea being tenants, projects, workflow, locations, something about the time of day you're supposed to log in, what you're supposed to do. All those things can be, data that goes into the policy evaluation, right? And so you can imagine that it starts to get really complicated. So to sort of isolate, I would say this, we kind of start with the concept of, modeling your roles, permissions, and so on, which could be this idea of what are my, areas and features and what roles apply to the feature. And do I have assignments, birthrights, where I assign you the role, or is it conditional based on time of day, or is it, something that's inherited? So essentially there's a legend, or there's what we call toxic combinations. You can't have this if you have that, separation of duties. You can map all that stuff, and there's lots of ways to do it. But you have to kind of do that up front as you're thinking about the plan, because that's the hardest part, is getting that designed up front. And then you got to overlay that with your app and the structure of the app and the features and the sub features, and how are we going to break this up? And are we having 200 APIs and 200 micro UIs? We have some customers that are literally like hundreds of UIs, right? Because they're all micro. So in a very, very large enterprise, that's super hard. But even one application can be complicated. So imagine multiplying that. So you have to really think about it up front. And part of the layers that I like to think about here is that, again, at every single module or feature, you're going to have your CRUD permissions available per resource and things like that you have to map out. And then eventually you're going to map that out to what roles give you those permissions. And then you have to line that up with, well, what resources and then what users that would be applied to, right? How am I grouping these permissions and roles and resources? So this is just a little bit cheat sheet that you might find useful after the fact, but just sort of lays out that at an enterprise level, these are all the things you have to do before you really get to the code, which is the part I showed you earlier, including that last bit that totally worked. So anyway, I just suggest, think about your authorization up front. All the fun code that we do and the samples will be made available is great, but the design is kind of like the first thing and pretty important as well. We could do a whole session on that alone, if not a day. So thanks very much. I hope you enjoyed that. And thanks.
Okay, let's go. That one's black, by the way. So nice to see you and nice to be here. And to be honest, fantastic they moved NDC security to March instead of January. I love Oslo, but I love Oslo more in early spring than midwinter. Sorry. So I'm Anders, I'm from Stockholm, and I run a small consultancy business called Sustainsis, and we do, well, when I explain to my kids what I do, I say that I build login buttons. So I do a lot of work with Duend Identity Server. I have a SAML2 open source component that's widely used, at least in Sweden. Norway took a more sensible decision and mostly use OpenID Connect. But today I'm going to talk a bit about security features in ASP.NET Core and use OS Top 10 as a backdrop or comparison to see for the modern threats that we have in the new OS Top 10, how does ASP.NET Core stand up to those? How does ASP.NET Core address those? What is addressed out of the box that we don't have to care about, and what things are not addressed that we have to care about ourselves? So first I have a look at the OWASP Top 10 2025 list, and as everyone knows, when you present a list, you need to go from the bottom. Have a cliffhanger. So number 10 is mishandling of exceptional conditions. Number 9, security logging and or alerting failures. Number 8, software or data integrity. Number 7, authentication failures. As someone working with login buttons, I'm very happy to see that authentication problems is all the way down to number 7, which means that people are mostly getting that right. Insecure design, it's an interesting thing. So when I've done incarnations of this talk for over 10 years. And when I first created this talk and delivered it, the OWASP Top 10 list was very technical. It was things like SQL injection, it was things like cross-site scripting, very specific things. Now there are more kind of a bit broader categories. Insecure design is more of overall design activity, but it's still an interesting thing to have on here. I'm also happy to see that in the 2025 edition, injection has dropped to number 5. It was injection, and specifically SQL injection, was number 1 for far too many years. It's finally pushed down to number 5. Number 4, cryptographic failures. Using crypto wrong. I mean, how hard can it be? 3, software supply chain failures. That is coming more and more. Number 2, security misconfiguration. And number 1, broken access control. How many of you were in this room for Michelle's talk before this one? Yeah, good. Then you had the basics of access control in ASP.NET Core. I'm sorry, some of the things will be very much a repetition. Great minds think alike, you know. But first look at what broken access control is. If we, for example, have an e-commerce site where we have a list of orders, the order list is of course filtered to only show orders that I'm allowed to access. And then I check one of the links. I can see that it's an order number in the link. What if I would change that order number and try to use a different order number? That is where authorization becomes important. What if the order number was a GUID? Would it be fine then to just rely on the GUID to be security? No, I don't think so. The identifier alone should never be the protection. In ASP.NET Core, we have an extensive authorization system, so I can just touch upon the basic features of it. The base is the authorized attribute. If we work with controllers, Razor Pages or Web API controllers, we have an authorized attribute. Role-based access control was a huge thing when it was presented as something that would solve all the problems. It doesn't. Role-based security is still important and solves a lot of problems, but not all of them. So in ASP.NET Core, we have policies where we tie an endpoint to a policy just by name, and then we have a separate place in the code where we define our policies. So this does the same, saying that you need to be admin, but we now centralize the knowledge of the admin role and the definition of that into one place. The policy system in ASP.NET Core is an extensible framework that is also fairly opinionated. If you follow the guidelines, I think this is an example from the official documentation. You need to be over 18 to access the alcoholic beverages page on the web shop. And that can be translated to have a requirement. A requirement is just a small class holding information. And then you have a handler that actually does the evaluation. A stupid example. Let's look at another one where you might have more requirements than handlers. So to read medical records or read journal, at least under Swedish legislation, one of the requirements is that you have to have a smart card login or a strong authentication. And we can have a handler that checks the login method before we allow access to medical records. Another requirement is that as a medical professional, you're only allowed to read medical records if you have a relation somehow to the patient. You can't just go read anyone's medical records. You need to have a reason. We could implement that with a handler that checks our calendar. Wouldn't that be clever? That if you have an upcoming appointment or you had an appointment in the past, in recent past with the patient, then of course you have a reason to access the records. But we also have another situation. Not all medical situations are scheduled. We might be delivered by ambulance to the emergency room, and then we can have another handler that opens up for that. And there's a vote, and the votes are binding. So if one of these handlers vote no, it's a no. But a handler can also abstain from voting and saying that I can't make a decision. And as long as another handler votes yes, it's a yes. This is a powerful model, but it's also opinionated. I tend to not start here. I start with more simple policies with built-in requirements. I rarely build my own handlers until I need them. One reason to build your own handler is if you want to, a handler is a service in the DI, which means it can also inject other services. There might be cases where you want to reach out to a database, API, or some other service to check something as part of your authorization policy evaluation. But then, as I said, role-based access control was said to be the great thing that solved everything. But it turns out that no, in the end, it doesn't solve anything. What about a web shop? We have order 42. How do we make an authorization decision? What are the business rules, you think, for accessing an order? Probably if you are a customer service, you can access any order if you're staff. Role-based security works. But then as a customer, you should be able to access your own order as well, right? And to know who the order belongs to, we need to first load the order. And this was a problem with the old days where you only had attributes-based authorization, because then we had to check the order. You couldn't load the order before you made the authorization decision. Now we can call the authorization service from code, and we can include the order when we send it to the policy. So we can say that, does this user fulfill the policy show order for this specific resource-based authorization? And then we make a decision. If it succeeds, we show the page, otherwise forbid. The policy itself is defined as show order, where we require assertion. Require assertion is my favorite requirement, because it allows me to write an expression returning true or false. I don't have to write handlers to write custom code. I can just use require assertion. In this case, the assertion checks if the user is in role employee, or if the owner of the resource matches the subject identifier of the current user. So we've implemented that customer service or anyone employed at the company can see any order and customers can see their own orders. But there's more to it. The problem with this is that you need to remember to apply authorize attributes and attach authorization policies to your endpoints. And you need to set them right. There is something called a global option, the default policy, which by default means you need to be authenticated. So if you just say authorize without any policy name, the default policy applies. And if you didn't even add an authorize attribute at all, you can set a fallback policy, or the fallback policy applies. So we can say that if the developers forget, I mean, do we ever forget anything? No. But if we would forget, not one of you, of course, one of your colleagues back home, if they would ever forget anything, it might be a safeguard to have a default fallback policy that does something in case there was no authorization policy defined. I prefer this one. Require search and false. What this does is to make sure that the entire system is completely locked down. If we forget to define authorization rules, it's a no-go. No one is allowed access anywhere, because this will force everyone to remember to add authorized attributes. And you can't just add a sloppy authorized attribute without a policy name, because that will also be denied. You need to have a specific one. We can, for example, if we map static assets, we now need to allow anonymous access. Or static assets, JavaScript assets, nothing will be served. And if we actually want any logged in user to have access, we can have a policy called authenticated. So this is a way that if you want to be secure by default and make sure that colleague of yours that forget to add authorization, that they get stuck, this is a way to handle it. Another example of that falls into this category as well, broken access control. I mean, one of the things I've seen with OWASP 2025 edition is that they wanted to include so much, so things that previously were different categories are now merged into one. That's why I'm also spending half of the talk on topic number one, because this is where the most interesting things are. One of the things is open redirects. It's also a form of broken access control that we don't validate the URL correctly. ASP.NET Core and the login system has a built-in feature that if you have a login page that you redirect to, it captures the URL you try to access to allow to redirect back. Once you have logged in successfully, it allows you to redirect back to the page you try to access. That's great. That return URL parameter, what if I try to enter ndcsecurity.com on it? Would it work? No, because out of the box, it only accepts local URLs. The built-in redirect that is in the handler. We can also check, we have an excellent help, a URL is a local URL. And we have a specific local redirect we can use when we return a redirect result that enforces it to be a local URL. Is it a good idea to try to check yourself if a URL is local? No. URLs are terribly hard to parse correctly. So it's one of those things where it's great to have a hardened component in the system. Another thing that is also included in broken access control is cross-site request forgery. So let me tell you a story. This story is by now 20 years old. I had one of these modems. Anyone recognize them? ADSL 2 megabit downstream, 0.5 megabit upstream. State of the art. It's fairly impressive that they managed to get internet running at those speeds on old copper wire that was designed for telephones 50 years earlier. So that's impressive, and it worked. One of the things that this modem had was an admin page where you can go in and set DNS settings, because this modem acted as DHCP and DNS server for the local network. So any computer on the network used the modem as the DNS server, and then the modem had to know about what remote DNS server to use. So you could enter configuration, hit save, and it hit some server-side action and it saved it. So one day, I was reading an internet forum, and a security researcher, Leif Nixon, a great Swedish security researcher, he posted a question: do I know anyone who has this specific brand and model of modem? And I said, yeah, I have one. 10 seconds later, I had a PM. Great, can you click this link, please? And that's when I started to think, is this really a good idea? But, I mean, Leif he's a great security researcher, and I trust him, so I clicked the link, and I literally got a page of kittens, cute kittens. And I thought that this can't be true. I mean, he can't go all the way to ask for someone with a specific brand and model of a ADSL modem just to show me a page of nice kittens. These must be evil kittens. So I checked the source of the page, and yes, there was a hidden iframe in there that contained a form mimicking the form from the modem and posting it to the address of the modem, changing the DNS settings on my home network. And the idea the problem they had, or assumption the modem had here, was that it was safe to expose the admin UI to the internal network. I mean, the evil kittens are on the internet. But what they are doing is forcing my computer that was on my home network to do the post on behalf of the evil kittens. And also, remember, this was in the day before HTTPS was used everywhere, which meant that it was dead simple to set up a copy of most sites using plain HTTP. And if you control DNS, well, you don't need a phishing mail to trick me to click a link to a fraudulent site. I could go to the actual correct web address, and the DNS that he now controlled would redirect me to a different IP number where I would serve the wrong page. This was my first experience with cross-site request forgery. And the problem here is that the modem failed to validate that it's actually this form that was posted and not some similar form from somewhere else. To protect against this, the usual way to do it is to create a token with a random component. It is also of benefit to tie it to the current user, and then you can encrypt and sign it to make sure the token has integrity. Then the token is stored in the form field. So when the browser loads the form from the modem, it includes this token and also stores the token in a cookie. And on posting, the server can now validate that the token from the form field matches the token in the cookie. And this is a valid protection because CSRF, or cross-site request forgery, is a blind attack. With cross-site request forgery, the evil kittens can post data to my modem, but there's no way for them to read data out from the modem. They can't load a form, and they can definitely not get hold of the random value that I got in the cookie in my computer. And to implement this in ASP.NET Core, for Razor pages, you are done, because it's enabled by default. For MVC, you can add validate anti-forgery token, and it's also possible for MVC to add anti-forgery tokens to all endpoints. And this will automatically, it will create a cookie for you, it will create the hidden form field thanks to tag helper, it will validate it on post. So, well protected out of the box. Also, ASP.NET Core adds the additional layer that it ties the anti-forgery token to the current user. So if you have two tabs open and you try to save something, and in the meantime you logged in as another user in another tab, you're blocked to prevent saving things to the wrong account. Also, I should mention for cross-site request forgery that the same site attributes for cookies and same site limitation helps a lot, but not all the way. We still should use anti-forgery tokens. Okay, that was number one. Number two, security misconfiguration. Any questions, by the way, on the access control? Huh? Great. So, security misconfiguration. Security misconfiguration is one part of it is that you don't have security features that you should enable. ASP.NET Core does one thing right. It enables use hypertext strict transport security, saying that if your site is served over HTTPS, the browser will in the future reject going to the site with anything but HTTPS. That's good. Also, a typical thing that has been an attack vector in the past is that you try to download PHP files or script files or something that they are in the web root directory, and you can download script files, config files, things that were not meant to be downloaded. ASP.NET Core by default does not serve anything from your application directory. First, you have to enable it explicitly, and by default it serves a subdirectory root. And it's the same with any other feature. There is nothing enabled out of the box. Everything is you need to add to your pipeline and register. And this helps a lot with security misconfiguration. Then there are things that the support could be better. For example, content security policy headers. Andrew Socks and his Net Escapades brand has an excellent library for handling content security policy CSP headers. So this is an add-on. Let's move to number 3, supply chain failures. This is where things have happened a lot over the last few years. Supply chain failures has been more prominent as an attack vector, but also there's better tooling. So Visual Studio now puts up a large warning. This solution contains packages with vulnerabilities, and on build it also warns if you have packages with vulnerabilities. Here I just installed an old version of my Sustains SAML 2 library, and yeah, I had security issues. So that old version is deprecated because security vulnerabilities. And NuGet helps to some extent, because NuGet, they also do basic vulnerability testing, etc., for packages that are uploaded, but not enough. A friend of mine, Martin Baliev, who does a lot of fun things, he went ahead and tried, can I use source generators? If I could put malicious code in a source generator in a NuGet package, will it be detected? No, it wasn't. He could publish the package. He also did another thing. He submitted a pull request to update a package to .NET 10, including updated in Entity Framework packages. This looks legit, right? Just a version update? Actually, this is one of the cases where AI was useful. Copilot reviewed the pull request and said, the package name contains homoglyph characters, non-SQL lookalikes. Microsoft Entity Framework Core should be Microsoft Entity Framework Core. I have no idea which letter he changed, but he managed to publish a package on NuGet that was not with, I think it's the I, that's not the right I. So still, even though NuGet exists, be careful out there. And this is for the .NET side. Then you have the entire client side. Sub-resource integrity, content security policy helps, but you still need to do it. I would also like to take a few moments to talk about this picture. Because I'm maintaining a SAML 2 library, downloaded some 20 million times, used obviously by quite a lot of organizations out there. And it's an open source package, it's free to use. The origin of this is that I worked on a project where we had need for it. That was over 10 years ago. I don't work on that project anymore. I still maintain the package. I do sell commercial support and commercial consulting. I'm also very clear that the commercial support package for my library is a two-way support. As a user of the library, you will get dedicated priority support if you run into issues. and you will get features if you need them, etc. But it's also the other way around. That support package goes to supporting the ongoing maintenance of the library. And unfortunately, the number of organizations willing to sign up for support or support their open source packages they use, it's far too low. So if I can say, and we can see that there was a story with, it was a Linux package, a crypto primitive used by SSH, where there was open source maintainer burnout. And this guy, John Tian, I think the alias was, joined the team, started to send pull requests, high quality pull requests. He was promoted to be a maintainer of the package. He merged, and later it was found out that he had then merged, when he got the merge right, a backdoor. And it was extremely close that that backdoor made it all the way into OpenSSH and all major Linux distributions. But someone found it. So remember, open source maintainers, they're all often small teams doing it on part-time. And I think it's a vulnerability in itself in the model. And so I think vetting your dependencies and see, can we trust this? Can we trust it is going onwards? And how can we make sure that the business critical component we use is also available in the future? So, end of open source maintainer rant. Let's go on to cryptographic failures. Cryptographic failures is about the problem that it's hard to do cryptography right. Even if you have a perfectly correct algorithm, perfectly correct tools, you must know how to use them correctly. And you must know how to pick the right algorithm for the job. ASP.NET helps some in one aspect. ASP.NET Identity Core uses a correct algorithm to store passwords. PBKDF2 with a reasonable amount of rounds. It's one of the approved algorithms to store passwords. Scrypt, Bcrypt, Argon 2 are the other ones that are commonly used. So if you use ASP.NET Identity Core, they solve the crypto part for you. But then sometimes you need to encrypt things that are, you not only need to store passwords, you need to actually encrypt things. So you might use AES. AES is a perfectly valid encryption standard. It's strong, it's correct, it's used everywhere. And to use it, you call AES.create, and then you need to assign a key and initialization vector to it. So key. Where do you get the crypto key? How do you create it? How do you store the crypto key? Do you remember to rotate your crypto keys on a regular basis? There's a lot of things you need to do to the key. And even worse, what's an initialization vector? It says it must be a random thing in the documentation. So we just use the string random as a const in our code, right? Well, it turns out it's a bad idea. Initialization vector is a very important part of the strength of AES. Because if you have if you encrypt the same crypto text twice, you will get the same result. And there are also some, if you know the same crypto text, there are also ways to recover the key in the end, which is bad. So to prevent of that, AES says that the first block in every data you encrypt with AES should be a random string that is unique for each time you encrypt it, the initialization vector. And now you need to create a random IV. You need to store it with the encrypted payload afterwards. So it's a perfectly valid algorithm, but you need to know a few things and do a few extra housekeeping tasks to use AES directly. ASP.NET Core helps. They have a concept of data protector. Data protector is crypto API as you want it. You can take a source piece of data, protect it and you get some gibberish. And that thing is encrypted. It has a random IV. The IV is in there, and it is also has a signature, so it is an authenticated encryption. And you can then unprotect it, called Hello World. The API looks like this. You inject a data protection provider, and from the provider you create a data protector. The actual protect call is just protect one part. You can insert a string, you will get binary data back. And then you can take the binary data and unprotect it, and you get the string back. Dead simple, right? And it works well, but behind the scenes, ASP.NET Core does all the heavy work of creating keys, storing keys, rotating keys, and it makes an educated, clever guess of where to store those keys. That works fine on local development. It usually works fine in test environments. It works fine the first month in production, and then someone makes a change to production and the keys are lost. So at some point with the Duende Identity Server support, 30% of all the support issues were caused by data protection configuration issues. So whenever you have an ASP.NET Core application, it's always a good idea to just manually set the data protection configuration, so you know where your keys are stored. But if we look at the vulnerability, I think that ASP.NET Core really helps for the cryptographic usage, thanks to this API, because it's simple to use. You don't need to know the details of of how to use a crypto algorithm correctly. But we have the purpose here. What is that? Well, one of the things that the data protection is used for is to bake session cookies. The recipe for an ASP.NET Core session cookie is that you take some JSON that describes the user, you run it through data protection, and here you have your cookie value. Another way where I could maybe use data protection is that imagine if I have a wizard where I have next buttons, and on one of the steps I do expensive validation of the data. And then I just need to keep it around for the future steps. I could just put that validated data in a hidden form field throughout the rest of the wizard, but then any one of you having browser dev tools could change the data post-validation. So I use data protection. I store the validated data in data protection. Now we have a case for possibility for crypto swap. There is no way for you to bake a cookie because you don't have the crypto key, right? But what if you can control the data that goes into the wizard? What if you enter information in there that is run through the crypto, and then you grab the encrypted data, crypto text swap, and swap it with the cookie? Then you could try to enter information in the wizard that makes you an admin in the cookie. And here's where the purpose matters, because the purpose is part of the key derivation function and ensures that if I try to reuse encrypted text that was used for the wizard, it's not possible to try to use that as a cookie. So the only thing you need to know when using ASP.NET Core data protection is that you need to have a unique purpose each time you use it, if you use it in different places in your algorithm, in your application. So, number 5, injection. This used to be number 1. It's largely solved, but still number 5. It also contains a bunch of different things, and not just SQL injection anymore. The most basic thing is actually array indexing. If you have color codes and we have something that tries to show color ID number 3, it's 0 base, so 3 is out of bounds, right? .NET is a memory-safe language, so if we do this and try to access color codes 3, we will have an exception. We will not have corrupt memory. We will not be able to read memory outside the array. Problem solved. SQL injection then. So if we have an e-commerce site where we can display an order, we have order number 17, and we might have a naive way to build a SQL query with just your string interpolation. The way this works is that whatever goes into the query string here is then put into the template here and results in a SQL command that can then be run with the database, and that's fine. You wouldn't do anything nasty if you had the chance here, would you? Who would do this? So if we do this, well, whatever goes here is put in here and results in two commands. Drop table orders. I guess the e-commerce site might have some health issues after this. So considering that this has not been largely solved, ASP.NET Core obviously should have protection mechanisms to this, right? Well, there's nothing you need to do. Because in ASP.NET Core, we typically use language integrated query, which is type safe. We rarely, very rarely generate SQL ourselves. And if you go all the way to generate SQL yourself, I hope anyone doing so knows about parameterized queries. Another kind of injection is cross-site scripting. So imagine we have a rating for products on our e-commerce site, and someone leaves a 3-star comment. I mean, this is suspicious already here. Nobody leaves a 3-star rating, ever. Have you seen one? I mean, either you're upset with something and you leave a 1 and go on a long rant how bad the company is, or you're happy and you leave a 5 because you're nice. So already here is suspicious. It's even more suspicious that someone bothered to write works but nothing fancy. But what they also did was they included a script tag in the review. Their hope is that when this review is displayed on the site, in the future, the script will be run when other people visit and read the review. The mitigation for this is to always remember to HTML escape content before you render it. What if we forget that in Razor? If we just render a string like this right out, well, it will be displayed like this. It will say, because it is HTML escape by default. If you've ever tried to do HTML building tag helpers or something where you build HTML yourself, you have an HTML string and you want that to be not escaped, you have to add APIs and add things to tell Razor that this is HTML, I know what I'm doing, please output it. So once more, secure by default. That's 5 items. Let's look at insecure design number 6. This is not really ASP.NET Core. This is insecure design is more about having bad ideas. Using security questions as a recovery mechanism is a bad idea. It doesn't matter if you make a good implementation of it, it's still a bad thing because it was a bad idea. The recommendation here is to read specs and follow specs where someone has done the hard thinking. When they created SAML2 spec, they had an idea of IDP-initiated single sign-on, which is called unsolicited responses, is the technical way to implement it, and they describe that an identity provider may initiate this profile by delivering an unsolicited response message to a service provider. And then, reading the spec, the latest version, there is an errata saying that, note that the use of unsolicited responses can lead to cross-site request forgery vulnerabilities. So this is an example where they found out that the idea they had in the spec was bad, but they at least listed in the spec now. So IDP-initiated single sign-on using SAML2 is always vulnerable to cross-site request forgery. You can't implement this spec in a way that is not vulnerable to cross-site request forgery. So what to do? Use OpenID Connect instead. OpenID Connect, I mean, these specs have been written by smart people, groups of smart people that have spent extensive time talking to each other, trying to figure out all the things. If you look at one of these internet specs, you will find a long list of security considerations. And reading these security considerations, to me, it is like the TV show Jeopardy, where Every time I see a validation rule, if you read the rules on how you should validate an ID token, it's like having an answer to a potential threat. Everything you need to do is to mitigate a specific threat. So, secure design, my take on that is use standard things. It's not a specific ASP.NET Core thing. Let's continue with my favorite, authentication. Authentication failures, well, we can have username, password. If we do username, password, we post this to the server. The server validates the username, password, and then our web browser makes a new request, and HTTP is stateless, so the web server is like, hey, who are you? How did you find me? So what do we typically do to make the server happy to remember us? We give it a cookie, right? We give it, when we have validated the username and password or the login method, we give it a cookie, and the server is now happy and allows us to go in. You could implement this. I've been interested in this for long. So very early, I wouldn't say in my career, but before my career, in my teens, when I was toying around with this, I might have written this piece of code. This is a very naive, non-production worthy login method. Can anyone find an error? No, you can't find it, okay. We can have a separate talk afterwards. Too much. So actually, when I created this, I created this way back as a small example, and my idea was to add 3 errors. So far, I think people at conferences have found 7 errors in it. Can you find anything more? Who's first? What's the first horrible error? SQL injection, yes, of course, SQL injection. Next. Yeah, that's more of a performance thing. Yeah, I should dispose of them. That's right. That's actually a new one, number 8. Thank you. Because that could be used as a denial of service through exhaust resources. It's a new one. The cookie is open text, the most ridiculous thing. I mean, anyone can just put any username in there. Sorry? You always redirect. I always also set the cookie. I forgot the else. So it doesn't matter what you say. If you put in the wrong username and password, you will have a modal error that will be added, but it will be ignored. Okay, this is bad. So the way to handle authentication is to use a pre-made solution. This is a quote from the OWASP Top 10, where it says, ideally, use a pre-made, well-trusted system to handle authentication, identity, and session management. Transfer this risk whenever possible by buying and utilizing a hardened and well-tested system. So how does ASP.NET Core stand up to this? They have ASP.NET Core, ASP.NET Identity Core. If we have a beer in the party tonight, we can discuss some nuances of ASP.NET Identity, where I don't like the API surface and design, etc. But in general, it's secure. It's a good choice to use. Or even better, add external authentication. Offload it to someone else. Because you have all the components needed included in ASP.NET Core. We can have a cookie handler to manage our session, and then we use OpenID Connect to establish the session. Let's move on with number 8, software and data integrity failures. This was actually quite hard to find one of the examples, because all my old examples I had have been fixed. So ASP.NET Core, the typical examples that you usually have are XML external entities, XML DTD, the billion laugh attacks, where you could send special XML that self-expand recursively. Things like that, they are blocked by .NET by default now. That's good. One example that I had that worked fairly recently is and still is worth mentioning, is deserialization of arbitrary classes. So if I receive a piece of data that is serialized and I deserialize it, I need to know what type to deserialize it into, right? One way to do that is to allow a marker in the serialized data to just tell what type it should be used. And you're shaking your hand, why?
Last year I was here, I saw someone injecting some very complex thing in there and it created in this class that a lot to do anything.
So someone injected something, yeah. So one of the things you can find in .NET is the temp file collection class. It's serializable. So if I have a deserializer somewhere that would happily deserialize any type I tell it to deserialize, I could send them a serialized temp file collection. I mean, why is it serializable in the first place? Can anyone explain that to me? It is. It contains a hash table of files that is in the collection. And then it contains a finalizer that cleans up and ensures cleanup. Which means that if I can send you a serialized version of this, I can tell it to I can essentially send a list of files that should be removed from your system. So in the Newtons of JSON version of this slide, I said that this is secure by default, but don't ever change this setting because then you're vulnerable. I checked system text JSON, what do they do? Type name handling.all, a global setting, not supported by design, period. They didn't just close the door, they removed the door entirely, which is good. Then we have security logging and alerting failures as number 9. This category includes also a variety of topics. It includes both injections. I mean, if you can force data to be written to the logs unescaped, you can make the logs unreadable. Structured logging helps a lot that we have in ASP.NET Core. It also includes where logs are stored on a server, so if the server is compromised, the attacker can remove the logs. I think one thing that has helped a lot here is OpenTelemetry and the move to OpenTelemetry. I see that this is really happening, has been happening over the last few years and is happening. Everyone is moving to OpenTelemetry, where you have a separate external monitoring tool and aggregator, which means that things are just shipped out. And ASP.NET Core has excellent support for that. So what they did is that ASP.NET Core had excellent support for, or built-in support for counters and measuring duration for activities. It's called activities in .NET. And we had the structured logging. What they did was just add an OpenTelemetry adapter on top of what already existed to export it to OpenTel compatible viewers. There is, however, another category of logging that isn't covered, audit logging. So OpenTelemetry is great, but it is a tool for monitoring the health of a system. It is not an audit logging tool. For example, OpenTelemetry often does sampling, and it saves things for just a few weeks. The idea is that OpenTelemetry, that tooling is made to make it possible for you to monitor the health of your system and to figure out why the system is down or why it's slow, what is your performance penalties, what kind of error messages or errors are your users running into. And it's an excellent tool for that. But if you half a year later does a forensic because you had a breach and want to know exactly what users logged on that Wednesday in August, OpenTelemetry was never designed for that. So if you have requirements for audit logging, you have to build it yourself. Another part of security logging failures is also exposing incorrect data. Here they can help. Microsoft Extensions Compliance Redaction is a fairly new library that allows you to classify data as personal information, etc., and they can have some clever redaction mechanism in there. One example is that you can decide based on what type of data it is, if it should be removed entirely from the log, or if you should store a hash of it. Why a hash? Well, because if you don't want to store personal data, username, social security number, whatever, but you may want to be able to correlate across logs. If you store the hash of the user identifier, then you can correlate if it was the same user across many different logs, but you still can't get to what it was. And that is a good idea to do in the technical logs with OpenTelemetry. However, in the audit logs, should you anonymize the user identity in the audit logs? No, the purpose of the audit logs is to keep them. So you need both of them. Final category, mishandling of exceptional conditions. Back in the days, ASP.NET had custom errors that were very chatty and exposed a lot of internal information. The developer exception page in ASP.NET Core is still detailed. It's even more detailed and provides a lot of things that are helpful when troubleshooting. But by default, it's only enabled if you run on the development environment. When you run it on production, it's disabled. And this is the default error page from a fresh project I created, that as it would be displayed for production. Just there was an error, there is a request ID, so if the user screenshots this or gets the request ID, you have something to use in your OpenTelemetry-based application monitoring to search for. But there's more to it. It's also about flow control. This is a naive order processing method. And this reminds me of my days when I was working C++, and one of the problems with C++ is that you need to free memory always. So it was really important if writing code that involved exceptions in C++, it was really important to make sure that if an exception could ever be thrown anywhere, you still would free the memory at least. And remember that. And it's kind of the same here. If we process an order, what would happen if we do it in this order and have an exception? Any one of these methods could throw an exception, right? If the first one fails, charge credit card, customer didn't have money, problem solved. We didn't do anything. What if we charge the credit card, but the license key creation fails? Profit. That is very creative. I would said public relations problem. I actually had a system once where we had we had removed Google Analytics from the page, and we had forgotten to remove an event call on the payment page. So we did this. We took the money, we reserved the money, and then the order didn't complete because there was a failure to call Google Analytics, and the JavaScript aborted. It was extremely embarrassing. What if we create the license key but don't send it? Well, it depends on what it costs. This could be a license key that we create, and also once we create it, we have to pay a supplier. Well, we got the money at least, but still a bad idea. No. One way to do it is to think in terms of transactions. And once again, way back we had distributed transaction coordination, we had transactions, we could wrap everything in a distributed transaction and things worked. With the distributed environment today, that's no longer possible. But we can still steal some of the ideas from that. We can have a prepare phase where we reserve the money from the credit card. Just check that they have the money. We can create the license key and store it somewhere to make sure we have a license key. And once we've done these are operations that can easily be rolled back if needed. Then we have a commit phase where we mark an order as committed. Single instruction, if this goes through and the order is marked as committed, then we have decided that the order will be completed. Then we can try send license key and try confirm credit card, but We can also have a job in the background that monitors retries. If one of these completion steps fails, we can retry it later. We can have monitoring that alarms that saying, hey, now the credit card confirmation or license sendings doesn't work, and catch them up later. This is not something that ASP.NET Core helps with, but it's an important part also of mishandling of exceptional conditions, that you think of what would happen to your flow or control when you do multiple things. So, looking back at the list, what is our verdict? Broken access control, does ASP.NET Core help? I would say yes. Security misconfiguration? I would say yes, it's fairly secure by default. Supply chain, could be better. And the experience from Martin showed that, yeah, there are still things that they are hard. I wouldn't blame the NuGet team. They do a great job, but it's extremely hard to protect all the way. We need to be cautious ourselves. Cryptographic failures, yeah, the default helper methods, they are excellent. And I really love that they have this data protection abstraction that is easy to use and you don't have to learn. And also, if you fail the data protection configuration, it will not make your application insecure. It will make your application stop working maybe, but you will not lose the encrypted data or not give away the encrypted data. Injection, yeah, great tooling by default, both using link as a protection against the SQL injection. The default escaping is great. Insecure design is not a technical thing at all. Authentication failures, yeah, we have great authentication tools built in. Integrity or data failures, yeah, this is where I had it hard to even find examples because it's so good. Security logging and alerting failures, yeah, I would say that this is a question mark, and I think the audit logging is the large thing missing here that I find missing. And my final verdict, exceptional conditions, is that, yeah, it doesn't leak information, but there is no build. You are on your own to design your business logic so that it recovers gracefully or errors gracefully in case of exceptions. So I guess I'm out of time. No, nearly. I have time for one or two questions. We're in Scandinavia. I'm Scandinavian myself. I know what it is. So I'll be around for the rest of the day and most of tomorrow. So just grab me if you want to discuss. And otherwise, thanks a lot for coming and thanks for being here.
So let's see. Hey everyone. Some difficulties with presenting machines. You always think stuff won't happen to you, and yes, today seems to be the day for me. I still have my deck. This is the PDF. It's on the GitHub repo. I downloaded it on my machine, but it's on the GitHub repo that you can get yourself as well, which has all demos, all code tied to it. It also has a pointer to the tool. I did have not time to install the tool on my machine, so I'm not going to bother you with showing you a video of NDC Manchester where I did the same demos. I'm just going to talk you through and then see how it goes. As I said, sorry about that. I'm not going to apologize. Let's see how we can move this forward. So my name is Niels Stanis, and in the next probably a bit less than 50 minutes, we're going to talk about building community-driven .NET analysis for your .NET software supply chain. First, who am I? So my name is Niels Stanis. As from this month, I'm working for a company called Titleist, and Titleist makes software for the maritime business, which is like harbors and coast systems, and coast guards use them. And it's a company that the nice fancy radar screens you see in harbors that track ships, those are the things. And I joined them to build security, which is pretty cool, physical security, software security from scratch. But I have a background in .NET development. And 10 years before, I was part of Veracode, where I'm focused on static analysis of .NET applications, which is quite fun because you get to build software, test software, and look at every SDK that was released. Mostly by Microsoft. .NET was the biggest technology I focused on. And I'm also a public speaker, which I've done over the last decade. And as I said, this is the first time that this is failing me, and I feel really bad. But let's move forward, and this is definitely the last time I'm talking about this. And I'm also an MVP in developer technologies, which means developing, explaining to developers hey, we need to get our security right. And even myself, standing in the trenches again at a company where it's all about third-party risk, it's all about code vulnerabilities, it's all about we need to move quickly because it's a product, right? There's a whole lot of tension. It's a different field. I'm happy to be part of that and to make a difference, right? I love to talk about security problems and explain them in a sense that people can move forward. This is a slide deck I've been using for a long time. The XKCD, let me quickly close out some bits and pieces here, which has of course, a nice illustration that everybody probably knows, right? Everybody has the Bobby drop tables. This is the other one. And it illustrates the old modern digital infrastructure. I would say software landscape is probably the same, right? Stack of blocks we put on top of each other. We rely on everything. And somewhere underneath, there's that small piece that is being maintained by somebody, thanklessly maintained by somebody. And it's been hard, right? Even if you look at open source maintainers in general, put a lot of effort in, and they need to keep it secure, right? And that's a thing. And people, for some reason, are not always willing to pay for it, which is unfortunate. But this is just the game, right? And I think last year in November, or at least last part of the year, somebody else created a newer version. I'm not sure if you're able to see this from a stretch, but this is the new version that somebody created that even included everything else, right? Strategy of big companies like Microsoft, Cloudflare failing. We have, of course, AI, agentic coding. Everybody can get up to speed pretty quickly, right? As we have seen over the last time. And then at the end, we have the one on the bottom is the shark that bites the cable, right? That's the top one, or the bottom one. I find this is amazing. I'm going to use this one as well, combined with the other, right? So it's hard. Even looking at open source libraries, NuGet and the ecosystem in general, we all rely on stuff that's already there, right? And why would you reinvent the wheel and do stuff yourself? You're just using stuff that's there, and you cannot expect them to have full-fledged security in a way that a big company does. So there's a bit of a tension field, right, in order to get that. So the agenda would consist of the following pieces. First, I want to just briefly look into some of the .NET security intelligence we have and some of the examples that were shown over the last, I think, couple of years. And then I'm looking more hey, what can we do on securing our supply chain and where can we start? There is a section called Fennec Labs. So Fennec Labs is consistent of tools that I created over my last 10 years when doing .NET research, right? So it has some tools that I use to look into binaries, to look into .NET IL and get stuff out that I find important and then make a better judge decision. Because we want to know what projects do for security, right? As I said, if it's a two-people thing, then yeah, hopefully some tools, but if they have a process in place, how do they deal with security problems, with vulnerabilities, and so on. One other thing that I always talk about and stress about is like, hey, if we take a package in and we start developing on something, like, do we exactly know what's inside of that package? Are you mostly certain that, let's say you have a GitHub repo that points out to the source of the package, that that's the source that was used to build that package that you're running on your system, right? Those are all pretty, pretty question. I think that's questions we need to ask ourselves, right? And then I want to smoothen out and help. As security people, we need to review packages more, I think, for the .NET ecosystem for sure. Other ecosystems are doing it more, and for .NET, there's definitely some improvements that we can do. And then I have some future ideas and some other stuff. And as I said, it's unfortunate that the tools are not running, but I will show you some screenshots and show you what it's capable of. On average, a code base. This is a code cartoon that's drawn by Lynn Clark. And she has a lot of nice cartoons where she explains security problems. You're going to see a couple of them during this talk. And on average, we say 20% of the software is software that we write ourselves, and the 80% comes from somebody else. And there was multiple studies, and people would argue like, hey, but if I'm taking that library, I'm using a small bit of it, right? Not everything makes sense. But let's say a big chunk of what we take into our applications is written by somebody else. I think that's the right assumption to make. What could possibly go wrong? This is, as I said, I've left Verico, but I've been involved in the last version of this report, which is the state of software security. And as you probably know, Verico does static analysis, and based on the data we have, we always look into like how good is the industry evolving, what is changing. I used to do that, and every year there is this report, and this is the one that was published, I think, a week or so ago. They still luckily shared it with me. So Niels, this is the outcome. Look at it, we improved, right? So there are two diagrams in this thing. And if you have seen this talk before, if you have seen another video, you will see me only talk about last year's edition, but this is a comparison to 2025 and 2026. And on the left-hand side, we see first-party flaws, right? So the amount of security depth we have in our applications has dropped from 64% of the flaws are in first-party code compared to 63 this year. So there's the prevalence, right? So that means like, the amount of flaws that's available. And on the right-hand side, we see that's the third-party risks that we're facing. 70% of the apps they have seen, it's a past sentence, consisted of security flaws in 2025, and in 2026, it's only 62%, right? So it's good to see that there's a movement that goes down, right? If we look trend-wise. The bigger problem in the dissection, the thing that they also look into in the report is more like, hey, how much does AI coding influence this, and what do we see there? So if you want to see the report, there's a link inside the notes version of this slide. You can get it, right? But there's still a lot of work to do, right? Progress in a good sense of direction, but still a lot of flaws are there. And on average, if you look at a code base within .NET even, we usually grab a dependency because we want to develop something. We grab a hold of a framework or a library that does something for us. And the package never comes for free. Like it will only, a package never comes on its own, right? There's always additional packages, transitive the packages coming from with it. So if we have the top one, which you see over here in this illustration, and it has transitive ones, then with .NET, the process that starts will have access to system resources, and every library that's underneath there will have similar, right? Will have similar access to similar system resources. Unless you do something about it. But by default, this is the behavior, right? So if it wants to do other stuff, then that might happen. So let's say if there's a vulnerability found, then somebody might be able to influence the application and might be able to say, hey, could you just, this is a hacker calling, an attacker calling the library, right? But it has the ability to influence the library's behavior and do something with it. Is this still a thing, right? If you look at .NET in general, I think we're lucky with .NET CLI itself because we can use it for a lot of good things. So this is a project Most of the demo projects I'm referring to are in the repo as well. This is just a simple console app. It has a dependency on ITEX 7 that you can use to render PDFs. And if we look into the list of packages, people say like, hey, what's the packages? Are there any vulnerable packages, right? We can do it with the CLI, with the developer tool. I think that's good, right? Same as NPM, same as some of the other ecosystems, but we can do give me all vulnerable components right now. This is .NET 9. Unfortunately, with .NET 9, the behavior was still that it only took the first layer of dependencies and not the transitive ones. Because if we look into give me all the transitive dependencies you own, then the list will become a lot more bigger, right? And if we then ask, give me the vulnerable ones, then we see we have a dangling one underneath somewhere that has a vulnerability tied to it, right? Aside from the fact that, of course, severity high, and you need to look into the context and see how applicable it really is. But in this case, the tools allows us to review it. And it was unfortunate that until .NET 9, it only does first-level dependencies. I know that, I think it was 10 years ago when .NET was considering this, the teams were considering putting this in. It has taken a really lot of effort to get all this information available and used. And as from .NET 10, if you install the latest SDK that was released last November, this is the default behavior. And it will just show you always the dependencies that are vulnerable, and including the transitive ones. And those will turn into build warnings at least, right? But it will be visible. I'm assuming that if you're developing stuff and if you see this popping up in your console at some point, if you're building a project, this is something we can take and fix here, right? Because you're touching the code. So this is good. This is a good movement. Look at that, vulnerable assemblies. This is the path forward. And then, of course, we have the SCA tools and all the other tools we can do in our CI/CD continuous, right? That's good. But this is the best part because this is close to where the developer is working on it, and we should fix it here. Another thing that was nice, .NET Conf is usually done together with the .NET release. And last year, Barry Dorrance, who is the technical PM, or at least he's the PM for Microsoft .NET security as a whole, he did a review of what happened with .NET over the last year. And I think he reviewed a total of 9 CVEs that were published in relation to .NET. And he also explained, I believe there was one with ASP.NET that had a severity of critical, or was really high. But it all depended on context, right? On how you look at it and how you would use it. And he also explains that. But I think the nice bit about this is that being transparent and explaining what was inside, that helps, right? And I sincerely hope, this is probably an indirect shout out to him, that he needs to do this, as far as I'm concerned, each year and talk through about like, hey, these are the things that were disclosed to us, or these were the things that we found ourselves, and this was the impact, and this is how the problem was fixed. These are nice stories. I would encourage you to watch this one as well, right? So a year in .NET Security, done by Barry Dorrance, looking at the vulnerabilities that they published and fixed inside .NET. What else could go wrong? And then we have another drawing, which is a malicious assembly in that case matter, right? So it will wear a mask, and it will do malicious things. And as I said before, .NET, the base would be every dependency that's pulled in will have the same access. I've done sandboxing .NET stuff in the past, which is technically really hard to do, but we had, for people who have done .NET in the early days, we had code access security at some point, right? This was like some kind of isolation happening at that level that might be able to narrow it down, but right now it will all have access, right? So in this case, hey, let's open up the file system, right? And look into that. That's possible. And what happens with malicious assemblies, right? So there's a series of things happening, and this was, I think a while ago, this was already 3 years ago, but you can find newer ones on this, malicious assemblies where people are, I think, targeting, let's say, crypto wallets and their contents and gain something out of that, right? So people would say like, hey, NuGet is pretty solid. Not from that perspective, right? Malicious packages are being created. If there's money to be made, then people would be motivated to do it. The other thing is, I'm going to talk about reversing labs. They have like 2 pieces of research, which is pretty cool. The other thing that they focused on is more like homoglyphs, right? So different ways of typing, naming, and so on, together with IL weaving, which, as I said before, if you have the source code of a library, and you look it up and it get up and it says it's open source, everybody can see it. Like, it doesn't mean that somebody could still weave additional stuff into it, right? And this is what this research talks about and shows some examples. Right, so homoglyphs is like naming different, convincing the developer to use stuff. And then I'm not sure what the like objective was in this case, but this happened, right? And targeted, if there, as I said, if there's money to be made, then that will happen. Do we know what's inside? And this is not a .NET example, but this definitely shows a good example of what could happen, right? If people are here familiar with what happened with XZ, at some point there was a backdoor planted in that, right? And XZ is used in SSH on a lower level, I believe, within Linux, on Linux distributions. And have you read the full story, how somebody figured this one out? So there was a developer that worked on Postgres for Azure, I believe, and he was running tests, and he saw that his timing of his tests was a bit off. And then he thought, like, hey, why is that happening? And then he decided to look into the details a bit more, and saw that there was some timing happening, but also certain conditions that were met, which was quite, it was an attack. That was eventually what happened. If he didn't decide to look into why his test results were off by timing, this could have been like, a bigger problem, right? And you can also look it up, like what the motivations were, like who's behind it. But doing that on that kind of level on such a library is probably highly motivated to achieve something, right? This is the example of the thing that if the guy didn't see the tests increasing in time, he would not have looked into it. So we need to have a better understanding of what's inside our libraries. And once again, if I say, does .NET suffer from this? Yes. So Socket published this one last year. I think it was around in November of last year. And they looked into 9 malicious packages, NuGet packages they identified, that had time-delayed destructive payloads, which is a thing like, okay, what's happening here? So if you look into the details itself, there's a whole narrative. If you read that blog post, you can find it. But the thing I found most, let's say, obvious or like a bit weird is that 99% of the code was just valid, right? And it was just misusing database queries, and I think it was increasing some of the timing. It was failing now and then. And it was also focusing on a bit of library that was targeting industrial PLCs. My guess is that's probably the value part that they were interested in. And they had delayed logic that was supposed to execute 2028, which is like, why is that happening? Is somebody doing some job security and hopes that he can get back to a company and say, hey, I know you have some performance issues, I could probably fix it for you because I put them in myself. That might be a thing. What they did is like, hey, and then 20% of the database queries were terminated, which once again is an anomaly. If there's a big thing happening and if stuff fails, like that happens with the system, right? So it's not obvious, right? But it might be interfering enough to cause problems. And the one that was targeting the PLC, so the industrial machines, that was like directly active. And it was mimicking hardware failures, so that will be a hard one to get. So for some reason, somebody was highly motivated in doing this. And you can look into the article, like how they attribute it and towards which direction it goes. But I think this is important, telling us like, hey, we need to know what's inside and what's inside of the library. Because do you know what's inside? And as I said before, if we look at reversing labs, they also did some research in NuGet where they looked into the fact that sometimes there's additional binaries put inside a NuGet package. So .NET, you can do interop, right? You can say, hey, I can do a COM wrapper around a piece of unmanaged code and then do some invocation. And let's say for several libraries, I'm not sure if it's the next slide, yeah. You can do all kinds of stuff like zip, WinSCP, puttygen, and put it inside. So that means that there is a library in that's not part of the NuGet ecosystem, but it's adding functionality, right? And it's a binary that's put inside our NuGet package, but it's not visible because it's not part of the NuGet ecosystem. That makes it a hard one, right, to guess and to get. And what they also figured out is that at some point there was a library that relied on a zlib compression library implementation, and it turns out that you can only find the source of that. There's no compiled binary. And the version that they run across had vulnerability since 2005. So that's tucked inside that NuGet package called via interop, but you don't see it unless you look into the library itself and the binary and maybe Some other tools can look into it, but from the outside world, it's not part of NuGet, right? And that makes it hard. So we need to know what's inside. So what can we do, right? If we look at third-party libraries and what can we do to do a better job is to have a better understanding of what we consume for what reason. Microsoft created the S2C2F framework, or the consumption framework, where they talk about how you can deal with third-party libraries. And I was talking about this in November of last year, about the standards and about there's different levels of what you can do, right? So you can probably imagine that if you have a library that you really rely on, and if it's a library that's maintained publicly, you might be able to consider to take it internally and build your own version for a lot of reasons, right? Because you don't want to rely on the fact that, hey, if somebody becomes malicious or decides to remove it, right? If that's a big risk to your organization, that's something to consider. But the nice thing about this framework is that it gives you several levels of maturity that you're allowed to grow. And this is part of the OpenSSF project. And what I was trying to say before is that if you would search for it right now, it says deprecated because it moved into something called SLSA or SALSA. And where SALSA is more a framework that helps you out securing your supply chain if you're building open source, right? About provenance, about knowing what artifacts was used to build your end product, right? And having a trace of what's inside. That's what SLSA does. And SLSA dependency track is the transformation of S2C2F into that, right? So if you're searching for it, look into that one. I think it's good to have best practices on to deal with third-party libraries and how to ingest it, right? And deal with that in a better way. One other thing is that people always say, and I even see it in my current day job, it's like, hey, dependencies, we just need to update them, right? But with some of the targeted attacks that were done, even on NPM, would it make sense to maybe wait for a bit and not taking the latest version, right? And that's something that was described in this article, which I think, like, oh, that's a funny take on doing this. And I think looking at, let's say, for example, Dependabot and the RenovateBot, they can do cooldown periods as well. Although I'm questioning, like in NPM, if it's really possible to take one bit and then have transitive ones that are gathering in that might have got newer versions already tied to them. But I think this is definitely something to consider. Don't take the latest version by default, maybe wait for a bit, right? If something services and if something is really a target thing, then somebody would find it. If everybody does this, then we are in the opposite side of the spectrum, right? But I like this take. It's good to consider. Cooldown, as I said, is a feature of some of the Dependabot update functionalities you can get. So now we get to the point where I'm going to say, okay, we need to know what's inside. We need to audit what's inside. And this is a nutrition label of a Club Mate bottle. And the left one is the one you get in the US, which talks about serving sizes to a certain amount. And on the right-hand side, you see one that I got a hold of in Germany, in Berlin. But the nice thing about this is that it will show you the amount of salt or the amount of sugar that you probably need to stay away from. I'm guilty as well, but it will allow you to take well-informed decisions. If you're in a grocery store, grab something off the shelf, you can look into it and say, okay, this is not a good thing. This has 3 cubes of sugar in it. Maybe I should take just a glass of water, that's better, right? But this will allow you to take well-informed decisions. Wouldn't it be nice if we have the same for open source libraries? And yes, that is. There is a project called OpenSSF Security Scorecard, and it does a set of automated checks that we're going to go through in a bit as well. But it has a scoring system, and it will look into security best practices done by the project. It's ease of use. It will just be a tool, and it has a lot of community support, right? So that's a nice thing. And let me quickly show you the project website that you can find, because I can still open some stuff, right? And let me see if I can zoom in a bit. You can just download binaries, and you can point it out to any Git-based repo. That's GitLab or GitHub. Some of the checks we will see in a bit are focused on GitHub, but there's also stuff covered by GitLab. But it's something you can do on a repetitive basis. And the data then will explain to you the following. So let me go back to the slides. It will tell you something about Are there any vulnerabilities known? How well is it maintained? Like, is it touched in the last 90 days or not? Does it have a security policy defined? Is there anything mentioned about, hey, if you find something, you can reach out to this email address, or you can push something here, or if you want to have a bug bounty, this is how it works, these are the guidelines, right? That helps in order to understand it. Does it have a license, right? Legal stuff. Does it have some CII best practices badge that they also is a separate project that looks into your CI/CD, and there's an attestation done by somebody, and then you will get a sign-off, which is like certain best practices. And also, does it do a run and update tool? And you see like there's a different level of things. There's high, low, medium. And each of it will end up to the score of 0 to 10, right? That's the bandwidth. And 10 is good, 0 is bad. But the high one will have a bigger chunk of the end score that's calculated, right? That's the differences. Do they run any continuous testing? Or is there any fuzzy done? Does it do any static analysis, right? That's also an indicator like, hey, is something done with security and what did they do, right? Are there any binary artifacts in? This is the exact thing I talked about with the baggage part, right? Is there any compiled artifact inside the repo that is used to create the end result? Because you cannot reproduce that. I think that's the problem. Branch protection, and dangerous workflows are things related to GitHub. You can look into that one as well. There's a couple of articles in the notes that will point you out to some best practices on that one. Does it have, thank you for not installing that driver. So does it have any code review before stuff is merged? Is there an implicit workflow happening? Somebody pushes, somebody else reviews, and then it gets pushed into the main thing. And does the project have contributors from different organizations? And I think that's the key thing as well, because you could question, are a lot of contributors a good idea, right? And I can assure you that we've done some statistics in the past related to state of software security as well at Vercode, when I was still at Vercode. And it turned out that if you have multiple contributors from different orgs, that's definitely a better thing than to have only 1 or 2 people, right? Because there's a risk to that. But then they will check if there's multiple bigger orgs involved, right? That makes sense. Pin dependencies, right? Version tied stuff happening with your, if you use GitHub Actions, right? It's better to have the hash included, or like the identifier included, and not only the version, because versions can be replaced. And how is stuff done with token permissions? Is it part of a packaging ecosystem? For .NET, it's important that everything is part of NuGet itself, right? Of the ecosystem. So you can update, you can distribute stuff if stuff needs to be fixed. And does it have signed releases? This is a high one. You can argue if a signing thing would mean that you can trust it, right? But let's say from supply chain perspective, if at some point I know a builder has reached out to Cosign or Sigstore to sign things and signed it, then I know for a matter of fact that that happened at that point in time, right? So there's a traceable thing that you can do. So signed artifacts at least give you some guarantee of this was signed by that person at that point in time. So as I said, this is a demo. This was like one of the demos. And if you download the OpenSSF scorecard, you will see you can run it. You need to have a GitHub path token available that will only have public read access to repos. But the gist of this demo, and this is unfortunate that the other demo is not running, is like, how would you do this on a solution file with .NET or on a project? Are you going to go throughout all the projects that are in? And the answer is no. If you go, I will share the video link to the NDC Manchester talk I did, and I will make sure that I put in the notes to each of the demos that you can just click through. I have a demo where I have Fennec, CLI, that you can install, and it will iterate over your solution and over all the project, and it will get all the scorecards of that project and combine it into a single file. And then a single file, JSON-based, you can use it, store it somewhere, or need something. I thought like, okay, everything needs a report, so I just vibe the report against it easily to show like, hey, this is the data you can get out of it, right? But it will allow you to automate it, all the scorecards for your project. And that's good, right? It's a measurement. I don't think you need to only solely look at the score. It's almost looking at severity within flaws. That's not necessarily a thing, but look into the stuff that matters to you the most. And you can make better, well-informed decisions based on the scorecard data. So as I said, that's the demo. And it's unfortunate that it's not running. The other thing I've been doing from the beginning, if you look at .NET, .NET is IL, right? And the analysis done by Veracode, it was based on binaries. So we looked into the MSIL of a binary to look into what it's doing and why it's working like that. When I started doing binary reviews, I created a tool that dumps all function calls that were done, but in a way that it's a flat file. So it will have a class name, method name, namespace, class name, method name, arguments, and then the body of invocations that were done. So there's no control flow thing happening. It's just a flat out thing like these are the calls that were done. And then you see in my demo, it's a flat text file and you can easily search through it and then, hey, system.io.file. Where is it used? That method. I need to look into that method and see how it's called, right? Allowing me to identify sweet spots inside of that binary and say, this is key. This is functionality that it does a process start on something, which is like, oh, no. Or in the old days, binary formatter, it's deprecated, but it was used, right? And you can find those and identify those pretty easily. So with Instrument, you can create flat files and search through them. That's what I used it for. And then I thought, okay, what would be nice if we're able to identify certain characteristics of a package? So the next thing I would love to do is take that flat representation of that binary and then identify, does it use cryptography libraries? Does it rely on HTTP requests? Does it have certain features that it needs to do? And this is an application that was released, I think, in 2019 by Microsoft called Application Inspector, and it runs on source repositories. You can run a report, and it will show you what features are in this library and how it's used. And I think this is the key based on the instrumentation files that I created. Identifying authentication, authorization, cryptography, right? And it's mostly confident. The thing that it does over here overall is like, also does, it allows you to navigate through the code base and say, this is the thing that you're interested in. So it will allow us to have a better view of what's inside, right? And even identify anomalies. Why at some point would a library include a process start or diagnostics thing for that matter, right? That should be a tripwire saying like, hey, we need to investigate this. We need to see if something is happening. Getting to the next bit of Fennec Labs, reproducibility. So as I said, it's key to identify or being able to answer the fact like, hey, if I take this source repo, does it build into this package that's exactly the same, right? Reproducible builds or deterministic builds have been part at least of the .NET compiler stack from Roslyn. A while ago, there's a design document where they explain that the compiler will be mostly deterministic based on what's installed, but I think over the years they evolved. And you can probably assure that if you create a project and rebuild it second time, that it's almost the same. I have one demo in my demo scripts. If you take a console, copy it, a console project, build it, copy it, and then build it again, and then compare those two binaries, you will see that they are not the same, if you look at it from binary level perspective. But that has to do with PE headers, debug symbols, and all the additional stuff, right? The IL, that's the thing that at least matters for me for .NET. So are we able to reproduce? If you want to run that script, I have a demo video of previous talks where you can find it, but that script will show you how you can do it. What I have in Fennec Labs is the following piece. You can point out to a Git, to a NuGet package version. Let's say the demo I had was Serilog, latest version. I will grab the source from GitHub as well. I will repackage and rebuild a release build of that same package. And then I will ask Fennec Labs to compare those. And I'm not looking into, let's say, the binaries and the PE headers because I know that they are different, but I will look at the sole IL level and compare the two things. And what you can do is you can just see, hey, can I with most certainty say that this is the same version or this is the source code that was used to build this, right? And yes, there are other artifacts that you can use like build provenance that will explain to you that happened, but this will show you the build you've done yourself and you can compare it to the version that's on NuGet, right? And think it and mark it off. If more people don't do that, then maybe we can sign off as a collective saying like, yes, this is the source that was used to build this version. As I said, fancy demo, it works. Look the video. As I said, I will make sure I have the links in the video and the thing. It will also allow you to do a comparison. even if a newer version gets released, the first thing I would be interested in, even after Microsoft publishes new packages, like what is the difference, to understand what the problem was that they fixed, right? I also have same logic implemented that will take two versions from NuGet and compare them towards, like next to each other, and then it will show you the difference. It will first give you an overview of like this is on main level the difference, these method bodies different, and then you can zoom into those method bodies and see what's inside. And it's all a textual representation because it's a CLITL, it starts to get there, and it needs to mature. But we will get the ability to compare things, right? I think that's good. The other thing, and it's the same, there's two areas that I think also need improvement. One of them is fuzzing, the other one is static analysis for a lot of reasons, right? If we can do fuzz testing on libraries, we're able to just throw invalid data against it and then see how it behaves, right? And as we have seen this morning with Michael Howard's key talk, like C, C++ has caused a lot of issues. They're pretty good at finding those problems, but will we have any value inside of, let's say, a managed language like .NET? And the answer I always give is like, yes, because in the past there have been projects like fuzzing.net with SharpFuzz, where people have shown that this helps, this can work, right? We can fuzz this, but we need to have a more guided way of looking into it, like using the functionality as is. And SharpFuzz is a library that will allow you to instrument a thing in such a way, and there's a code snippet after this slide. It explains like this is the value, these are the bug bounties and the CVEs that were published. But it will allow you to create a bench, a test mark bench, right? And take a component and fuzz it in a way that it's intended to use, right? I think that's the thing with static analysis. You can look at a repository, but does it say anything about the context, right? If I use a library in a certain way, then I want to analyze it in the same way, like, hey, this is where it starts, this is where it ends. And this is some kind of a skeleton, right? That will instrument at least the fuzzer, but it can also help out for static analysis to understand what's happening, right? There's an improvement. And can we do stuff with this, right? And of course, right, there's a lot of success stories where an LLM should be able to help out to us to like synthesize test cases. That helps us out to put a library on a bench and test stuff, right? And this is Fuzzomatic, that's a project that did this for Rust, for the Rust ecosystem. I think it's pretty cool, right? Focusing on logical things. And there's a room of improvement that I would love to see also land into Fennec as an improvement for the future. So every project or everything, and that's also with security, right? We want to help out people, but we don't want to shatter a lot of additional information to the developer and don't know exactly what they need to do. So it would be nice if there's like a dashboard where you can just look up the risks of your project, see the scorecards, have some things in it that says something about the reproducibility of the project, right? What about if there is a collective dashboard, like a site you can go to for a package and say, I'm interested in using this version, and you will see all those same metrics, right? And it's the same for having the ability to review and share security data for a project. If I review a library and if I know the example I'm doing with the instrument demo at NDC Manchester is I take the AWS SDK and it has some abstractions on top of file system that you're not aware of if you just take the library in and just use it, right? And at some point there's an abstraction, and if we know like, hey, these are the code paths that end up in file instructions that open files on the system that we can maybe identify. And wouldn't it be nice if there's like a Roslyn analyzer that will just put squigglies underneath that API call in the code base, saying like, hey, be aware, as Michael Howard put it at the end, validate, right? Your input data, that's step one. Be aware that this data element later on gets used to open a file or to construct something else or to start a process, right? I think that's visual, and that will help developers making better decisions if we can take that information and show it that way. What I'm also been doing is I'm not sure if you're familiar with an MCP server called Serena. It's an LSP, right? And I think like the big tools have an LSP already inside. Cloud Code has it in it, but Serena is a standalone piece you can run as an MCP. You can put it on a code base. So for .NET, it will make sure it has, I think it's OmniSharp underneath the hood running. That will allow you to navigate the code base, right? So it's not a text file it looks into. No, it can navigate and say, where is this method call used? Where does it end up? I created some prompts. I think I used Kilo for that, a Kilo code. which has got like some open Minimax LLM you can use for free right now, and just throw it against some open source libraries and say, this is my prompt. I'm a security reviewer, I'm interested in data flows of stuff, of data that enters, or the library or the system, and how it's used, and any risky operations, which is like a definition file, and then let it go loose, right? I think it can help, and even putting an MCP or something else, or even creating a skill, right, on top of this would help people looking into security differently and putting it inside of the developer's hands. So that will be the thing. So with that said, as I said, it's unfortunately that the demo time is not included, but I'm going to conclude right now. I think doing security is hard. Even me walking into a new organization a month or so ago, it's hard to build up stuff and to convince people that it's good to do it from the start, right? Because security professions don't scale. Luckily, tools are catching up, and if we can automate the hell out of it, create better metrics, create better data sets that people can take in decisions on, right? Which is also like implicit goal of Fennec Labs, we can help, right? Because as a whole, and there's a lot of stuff published by a lot of security researchers, the ecosystems of package management systems have been targeted, right? Supply chain attacks, if you're able to grab hold of a library that's used by a lot of people, you have a lot of foothold to get compute or data and then extort people for data and get them to pay money for it, right? So as I said, the goal is to help reviewing and to allow everybody to make better, well-informed decisions. Fennec Labs is close on getting released. So you will find a package inside the repo itself you can install locally. The source branch I'm working on right now is not public yet. I'm assuming I can do it in the next couple of months. It's always like so much time, so much fun stuff to do. But we need to make sure that this lands, and I want to move forward with that. So if you go to NDC security repo, this is the one here. I've opened here as well. You can find all different types of demos. So there's the Fennec Labs that contains the package itself, and you will find how to install it. Within the security scorecards, I believe I even put in some output files. There's the demo script, right? If you look into a scorecard that you can release this is the output of it. And there are some JSON representations of the same. This data is also published by Google. There's deps.dev. I need to make sure deps.dev, that does the same. It has a lot of ecosystem stuff, Newtonsoft.json. If we take that one, that's the package that everybody talks about, mostly used. But there's scorecard data as well embedded in this view. That's cool. So you will find all of it. There's a slides section that has also the notes version with all the links. And there's a simple web app that will just allow you to run the Fennec scorecards, and it will have some vulnerabilities inside the dependencies that you can use. So with that said, I'm going to wrap up, and I'm going to say thank you. Hopefully the rest of the presenters have a less uneventful thing happening. I'm sorry. As I said, I will make sure I will share the video in the chat on Slack for this room. I will look up the time slots, and I will say these are the demos. And you can see it there. And thanks for hanging out with me today. And I hope you enjoy the rest of the conference.
each offending followed a very similar pattern. So when
Want to see your crush kiss you? AI has got you covered.
It has somewhere in the neighborhood of 1 billion
WR, let's go. Okay. All right. So good afternoon, and hope you've had a wonderful NDC security so far. I always like speaking at this conference. It's one of like one of my home conferences because I'm based out in Stavanger. How many of you have seen me talk before? Great. How many of you used to a bit of a fun talk? Bit of a laugh, giggles? It's not this talk. I'm really sorry to say. I will warn you, I built this talk out of a little kind of conversation I had with another parent, and it's about child safety online, how to keep your kids safe, what can happen, and it is an ultimately dark because I take and I reveal what really happens online. So it is, I give fair warning. I give you 2 warnings. This is the first one. I will be talking about things like child sex abuse material, pedophilia. I'll be talking about suicide, revenge porn, or revenge imagery, blackmails and catfishing, and drugs. And it's quite dark what I'll discuss, but I just want to make sure that you are well aware before you walk in here, and it is perfectly acceptable to decide this is not the talk I want to go see because I like thinking nice things today. So with that in mind, I normally call this talk, Won't Somebody Please Think of the Children? And it's called Internet Security because of the fact that when I talk to one of my other really good speaker friends called David Whitney, he kind of says, anyone who says, can somebody please think of the children, is usually not thinking of the children. It's usually the exact opposite. And I kind of agreed with him, so I'm going to retool the talk name. My name is Niall. I am an ATS at Microsoft, which means I'm a virtual CTO from Microsoft towards some of our large oil and gas and energy customers. I work with Equinor specifically. And previous to this, I was the head of cybersecurity at Capgemini in the Nordics. I've worked with security for a long time, and I am a parent. I have 2 lovely kids. I have a 13-year-old boy and a 9-year-old girl. They are both digital natives. They haven't grown up without security, or without computers in their house. There's more technically connected stuff in our house than there was in the internet in 1980. But we have more devices, and most of you in this room will probably be the same. You have a connected TV, you have connected phones, you have everything. So before we begin, one of the things I kind of want to tell people, because I give this talk for free to schools. I've taken this talk and said, this is a public service thing. If your school would like this talk or towards your parents or a version of this that is more appropriate to children, I do that as well if I'm in the area, and I just try and link up with the school and help them out. And I was asked by one school, and they said, what would it cost? And I said, it costs a cup of coffee. That's it. If I'm there, I'll do it for free. I feel this is good stuff. That said, I am not here to tell you how to parent your kids. If you are a parent, I am literally on chapter 13 and chapter 9 in the manuals because of who I have. But when it comes to cybersecurity and tech, I am usually very far ahead of everyone else. And I tell this to all people I talk to because I want them to understand that I am still learning as a parent. Everything I'm doing, I'm still learning. I make mistakes a lot. And the more I make mistakes, the more I learn. And if you're not a parent, but you might be that lovely person who is the technical support for the people around you, and where because you're here at NDC Security and you're probably interested and you're technically minded, there's people who say, hey, my kids are on the internet, what should I do? Then this talk is also for you, because this will help you understand and be able to give advice to the people around you. Now, that is kind of where this is coming from. How this talk was built was because I was on our local FAO. For those who are not Norwegian speaking, it's the the Parent Association, PTA. And I had a parent who desperately said, listen, Niall, I've been dying to talk to you because I don't understand this tech business. And I went, okay. And my son is the only person I can ask, and he's the person setting up his own phone. I don't know what he's doing. I'm terrified something's going to go wrong. I went, let me show you. And I sat down with him for 2 hours, and I went through a lot of this stuff, and I said, no, not what I'm going to show you, but I said, this is what you can do. And he goes, I wish someone would teach us. And I said, I can do that. So this is what it is. So I always start with my lovely kind of analogy for the internet, scissors. When you're given a pair of scissors as a little kid, the first thing your parents will say to you is, don't run with those. because you might fall and you might stab yourself, you might hurt yourself. And it's great because we know parents understand the risk. Sharp things with little kids invariably leads to someone getting cut, hurt, or whatever, because that's what happens. They'll make mistakes. The thing is, the internet is very like a pair of scissors. We have the most powerful tool that humans have ever created. It gives you access to all knowledge. You can go and Google and go on Wikipedia and you can say, I want to find out when was who was the second pope? Everyone knows who the first pope is, but no one ever knows who the second guy was. And I was like, if you've ever ended up in the Wikipedia drain hole where you've clicked on one link and all of a sudden you're 16 links deep and it's 2 o'clock in the morning, but you're very knowledgeable about popes. So that was, and I said, like, cool. But when you're given the internet as a child, you're never told, be careful. You're just told, best of luck, good luck. Here it is. You can have Snapchat, you can have this, you can have that. And no one kind of says, let's give you some guidelines on how to behave or what to do with it. Because the internet is dangerous. It can provide ultimate great harm. We have seen disinformation, elections trying to be manipulated. We have seen an incredible amount of imagery and gore and other stuff and all this type of thing being sent out and people accidentally finding it and going, ugh, and causing them great harm, mentally and physically. So I'm going to start with a little bit of information. And I'm going to ask a general question because most of you may know, maybe not know. For those of you who are familiar with social media apps, you nearly always have to be 13 years old to use them, right? Does everyone know why? I will take that the standard Norwegian answer of, yes, we do, we're just not going to tell you. Shit, I made a joke in the middle of a very dark talk. It's a US thing. Yes, it is not because of content. Most people think it's because you have to be 13 because it's content. Because when you get that, you're U and PG, and when you get to 13, we might see some boobies, or we might hear the words, some stuff. There might be something in there. It's not because of that. And that's usually where most parents go, really? And I said, no, it's because of COPPA, the Child Online Privacy Protection Act. And COPPA is an act that was designed in 1997 and enacted in 2000 in the US. And what they determined was children under the age of 13 were not adults, and their data had to be protected. And if you wanted to have people's data from that age, you had to protect that data, you had to have audit, and you had to have stricter controls to get access to it. And companies in the US went, no, I don't want to do that, so therefore you have to be over the age of 13. Because when you don't pay for an app, where do you pay for it? You pay for it with eyeballs on advertising. And they can sell you the 12-year-old's data to an advertiser, so they say, right, we don't make any money from this, why should we be investing money to keep it? So they decide not to do it. Now, it is a very lax interpretation of the, did you check for their age? Yes, they said they were 13. We're good. And that's all that matters, but they still have to say that's why you're 13. And now, with newer kind of versions of phones and whatever, they actually do check to your other ages and you can't just bypass it. So think of it very much like GDPR for children. It is to ensure that they maintain the right for privacy. It's a fact that it's a lot older than we think it is, but that's because someone had the smart idea back in about 97 that this could be a problem. Now, my 13-year-old, he was 12 at the time, I took him to an open debate in Stavanger, in southern Norway, where we had the Minister for Education was talking about this and this is for our non-Norwegian speakers, should there be a 15-year-old age limit for TikTok and Snap? Now, this was a public debate. It wasn't we were trying to implement it. And we had 14-year-olds here kind of giving their views, and they weren't as polished, of course, as the politicians. And my son was watching back and forth, and he's saying, this is what I said, listen to the arguments for both sides so you can understand what's going to happen. And he says, well, what do you think, Papa? And I says, I personally think it's both a good and bad idea. I said, if you look at Australia now, they've implemented 16-year-old for social media, and there's the UK and Ireland are thinking of similar things, and there's other kind of areas. Will this work or not? I don't know. Because generally we find if we put blanket bans on things, it can cause problems. Like if we want to see in 1929 they had prohibition in the US or whatever, and all of a sudden there was bootleggers everywhere, you know. And we'll find variants of Snapchat, like when TikTok was pretended to be banned in the US, all of a sudden there was TikTok variants just popped out of nowhere. It just, you can't blanket ban this stuff. You just have to have better understanding and thoughts around it. I also follow some social media online because, you know, it would be weird not to. But this one is from Polity Survest. It's one of their netpatruljas. It's a fantastic resource. It's really kind of clever because they put out a lot of information for parents. But this one struck me because my wife sent this to me. She says, "Niall, did you see this?" She knew I was building this talk. And I said, "Vi föräldrarna har varit naiv länge nog barn på 9 år ska lika vara på social media." For non-English speaking or non-Norwegian speaking, we parents have been naive for too long. Children as young as 9 should not be on social media. I definitely agree with this. I had a lovely mother argue with me saying, "Why shouldn't my daughter be on social media at 9? She's very smart, and if she gets on early, she'll get very good at it." And I looked at her, and I wish I had the common sense and thoughts at the time. You know, when someone says something to you and you get the smart reply as you walk away? That was this. And I went, "Do you let her drive?" And she goes, "Because, you know, we could practice from when we're 9 and we'd be very good at it by the time we're 18. And I thought of this and I said, but it was just this naivety and this kind of, this, it's okay. And I didn't want to criticize her. I said, but in my head, I was like, you are definitely wrong here. And I kind of then took a sharp turn and said, let me show you why. So here's the second warning. From the next about 20 minutes, it gets exceptionally hard and dark. I gave this talk in Hello Stavanger in October. I just about managed to keep my shit together. There is language in this, there is a lot of adult themes, and I'm warning you now, and if you stay in, good luck. This is Andrew McCartney. Andrew is from down in Antrim County Down in Northern Ireland. At the time of his arrest, he is probably one of the most prolific pedophiles they've ever caught. He, in the course of 4 years, and this is when he was 22, in the course of, or 21, in the course of about 4 years, he managed to catfish approximately 3,500 victims with an average age of 12, but with ages ranging from 3 to 17. Over the course of 4 years, he managed to coerce young girls, predominantly, to take intimate photos of themselves, send them to him, and he kept this going for quite a long time. How he was discovered was the Scottish police received a tip from a girl who said that this had happened to her, and through their investigations figured out this was actually happening with someone in Northern Ireland, and they sent a request to the PNSI, the police, or the police service in Northern Ireland, to follow it up, and through their really good investigative work, they managed to discover that it was him. They raided his house. They discovered 64 different devices containing thousands of images and videos that he had received and shared with other pedophiles around the world, containing multiple different identities. He had catfished these children over the course of 4 years, and is the first person I know of that was convicted of manslaughter over social media. I cannot describe the depravity and or the cruelty of this man in adequate words. So I'm actually going to show you a video here of a police officer describing this.
Each offending followed a very similar pattern. So when he had identified a victim and got that first photograph from them, he actually had a pre-prepared threat saved in his phone, which he would cut and paste into the chat to advise the child that they were now being catfished, that he had their image, and that they had to do what he said or else. You had little girls, sort of an average age of 10 to 12 years old, many times, being threatened in the most depraved way to do these things to themselves and provide McCartney with the images. His offending was round the clock, you know, and it was difficult to know when he actually did anything else. From the beginning of the case, the level of abuse was so horrific that we were fearful that when these children were identified, would they be okay? Unfortunately, our worst fears were realised when we discovered some way into the case that one of the little girls had taken her own life. The real feature of this case is the complete cowardice of McCartney in targeting children who were so young and very vulnerable. We were absolutely determined to bring him to justice, and you know, the bravery of the victims was just an inspiration to us, because as police identified them, they were giving us evidence. Some of the children had raised the alarm, which helped police to actually identify him in the first place. But some of the children, until police knocked the door, they had never told anyone what they'd been through.
The little girl in question is Simran Thomas. She was 9 years old. She was catfished by McCartney, and over the course was adding more and more kind of videos. And then he discovered she had a little sister, and told and said, I want you to involve her. And she said, no, I would rather kill myself. He pasted back a picture with a timer of an hour and a half and says, tick-tock, get on with it. The little girl went downstairs, took her retired veteran father's gun and shot herself. And her father found her. 18 months later, he committed suicide, not knowing why his daughter killed herself. It is one of the reasons why he was convicted for manslaughter as well as paedophilia on this charge. And you may be wondering what particular social media platform they were using, and it was Snapchat. And through Snapchat, it was very easy because it is a very popular, it's the most popular messaging app with teens and right now, including my son. He spends, it's how he communicates with a lot of stuff. If I want to send him a message, I use Snapchat. I don't text or call because he'll never answer. But a snap I'll get back in seconds. And what he would do, and this is a redacted kind of and a sample of what would happen here, is that McCartney would use a similar language, assume the persona of a 13 or 12 or 13-year-old girl, connect to the person, because you know you can find people through quick ad, etc., and use that then to kind of just get in contact, because the kids were like, oh, someone added me, I kind of recognize their name, they might be a friend of a friend of a friend, and would strike up a conversation, and over time would do this kind of catch the person out, etc. And it just grows from there. Now, I went online, I did a lot of research on this, in the fact that I went on to likes of Reddit, and I went on to I read a lot of police reports, and I've read a lot of different kind of information on this to try and show you kind of what's coming out. And this is like from a Reddit support forum where people who have been sexploited or kind of blackmailed through kind of catfishing put forward some of their what's happened. And this is usually how it starts, as very kind of simple as this. But you'll see here it says, oh, yep, how old are you? Based on you're older than me, I was just beginning to be polite and replying, I'm just 14. I mean, that's not a problem, lol, I'm 25. In any other conversation, this would be considered very, very weird. But this kind of being open and people kind of thinking it's okay, etc. It leads very quickly to a kind of discussion here of, I have to unfortunately read up here, bitch, are you ready to pay $500 to my Apple Pay because I'm ready to spoil your life? I'm ready to mail all the damn pictures to your handbill and etc. Bitch, you will blame yourself. The victim is blamed because they made a mistake, not the aggressor. It automatically forces you to think you are at the person who is wrong. It's a very standard psychological tactic to force you to kind of go, I made a mistake and now I have to try and fix it. It gets more aggressive. This is a standard issue bit. I will fuck you up, posting all your nudes until totally visible to everyone you know. All I have to do to get me to do what I want, and I'll consider not posting your information out. It's a aggressive tactic. Or else I'll post this and ruin your life. All this is from Reddit. It's unfortunately a growing trend, and there is a standard issue playbook for this. They're known as lore books in the undergrounds, where attackers will try, and they know these things will put pressure on the right people and get them to do what they want. And they'll get paid for $500. We're talking very limited amount of money. But for a lot of people, it's too much. Sextortion is growing. And unfortunately, it's not just women it's also affecting a horrendous amount of teen boys. And even more so, when I looked at this is when I was doing research in 2025 in October, it says, is a growing threat to teen boys and has led to at least 20 suicides. When I gave this presentation in October, it was more like 44. And that was just in the US alone that I could find. And it's horrible to think that someone will die because they sent a naked picture of themselves accidentally or on purpose, and it shouldn't happen like that. My timer is about to go off in 1 second now. That is 9 minutes. That is the length of time it took McCartney to blackmail one of his victims. You're still sitting here, and he has done and managed to get the photo out of one of the kids. 9 minutes. It's a terrifying thought when you have it. I want you to meet Jordan DeMaio. Jordan looks like any atypical American collegiate all-star. You'd see him on Dawson's Creek or any soaps, whatever. He's blonde, blue eyes, plays quarterback. You could say he's straight out of a soap opera. And Jordan was catfished by a group calling themselves, I think, what is it called? Danny. So at 10 o'clock in the evening, Jordan, 17, leaves his home, or his girlfriend's home. And Jordan received an unknown Instagram message from a person called Danny. And at around midnight, he sent a nude photo to Danny. And minutes later, the blackmail began. 3:30 in the morning, 3.5 hours later, he sent a final message to his girlfriend. And moments later, Jordan ended his life by suicide. He actually sent another message to his mother. And I'm going to just change my resolution here so I can actually read this a bit more, because this is a horrifying view into the last moments of a teenage boy. Why are you doing this? I am begging for my own life. 10, 9, 8. I bet your girlfriend will leave you for some other dude. I'll be dead. Like I want a KMS right now. Kill myself. Sure, I'll watch you die a miserable death. It's over, you win, bro. I'm KMS right now because of you. Good, do that, make it fast, and I swear, or I will do it, and I swear to God. 3:30 in the morning, Kyla, I love you so much. I made a mistake, and I wish I could continue, but I can't do this anymore. This was a choice I made, and I must pay for it myself. He sent his mother a message at 3:43, which was, Mother, I love you. And 3:45, we estimate he was dead. He was found by his father the following day, and they've discovered it was two brothers from an African country and another one where they were extradited to the US and given 17 years in prison. Unfortunately, he's not the only one. When I built this deck, I showed it to my wife. And at one point she says, Niall, you need to stop. You're going to hurt people with this. Calm down. Don't terrorize an audience. Make it factual, but don't, be good. And I said, okay. So I said, I wouldn't show you as much of what I was. There's hundreds of photos, unfortunately. But these are all kids who have lost their lives due to catfishing. And I of the honest belief that no kid should die because they sent a nude photograph to somebody. Amanda Todd's video is out online, and it's a cry for help due to bullying. And she just does it via cue cards, and it's still online on YouTube. If you want to watch probably one of the most harrowing and heartfelt cries for help, it's there. And it should be a required watching for people who think that bullying over the internet is okay. It is absolutely a masterpiece and a testament to her bravery of what she did. Riley Basford was 90 minutes from when he was originally contacted to before he was dead. So I'm going to give you something. If someone is attacked like this, give them brave. Block the predator. Report the account. Ask for help. Validate. Remember, the victim, the criminal is the only one at fault here, not the victim. Don't blame. And educate. And this is the educate business. We need to be brilliant as security professionals in our trade and our craft to help people get through this. To ensure that no one loses their life just due to something so stupid. That people understand that, yes, mistakes happen, but I shouldn't die for it, or that the only way I think out of it is actually suicide. It's a horrible thought. It is a difficult topic. I'm going to pivot a little bit to drugs, because unfortunately Snapchat is a very good way to buy drugs. Danish researchers did a phenomenal job on this, because this was a fascinating view into understanding how these systems work. I came from where if you wanted to buy drugs, you had to go onto the Silk Road or know people. Now all you have to do is open up Snapchat, type in a slang word and a location, and you can probably find the local drug dealer in your area. By looking the word snow, Copenhagen, they were able to kind of find the different people they wanted. And you can see Snowman, better delivery than Bring, Snow in Copenhagen, Snow Copenhagen, etc. And the thing is, as soon as you connect to these people, you will get offers. Here is what you will, like you buy, if you buy in bulk, you get it for cheaper. And there's like, the first taste is free, whatever. And it's a very quick way to find how to get drugs. And it's Snapchat. Most people think this is a fine thing to give my 12-year-old. They enter the wrong thing. They're sitting on doing this word stuff. And the thing is, by using the quick ad afterwards, you can find other people who are doing similar things. You can get the idea of the brick for the block of hash, or you can buy steroids. But it also leads to other different parts. And this is where I kind of had this conversation with one adult, and they said, well, you know, my son, he's always getting these reps, he calls them. And I says, yeah, you know, when we were young, we used to call them just fake merchandise, you know? And he goes, are they really that? And I said, they're not replicas. Replicas is a posh way of saying it's not real, and therefore they're fake. It's not Gucci, it's Fucci, you know? And the problem is that you can start here and it leads to other parts. Because once they get you hooked on certain things, they will go and say, hey, you want to do something else. Like, hey, I'd like to get a driver to deliver my drugs. I'm seeking a driver, will pay for the weekend to deliver pift, slang for cocaine. And it leads to other offers, like, for example, who's willing to give, like, you know, consists of selling things like masturbation videos, strip videos, and of course, dirty talking. With the general rise of certain kind of social media tactics, people are thinking this is okay, etc. But I'm not advocating against sex workers. I'm advocating against underage sex workers. This is not a case. And it's a very difficult thing. And by using things like SnapMap, you can also see where potentially you're being left out, or where other people are, etc. It's a difficult topic, because for most people, once I show them this, they're going, I didn't know you could do that with Snapchat. And I said, well, that's unfortunate, because that's how other people are using it. And that's where I learned from my son. I said, show me how you use Snapchat. Now, I know how I don't really use Snapchat that much, because maybe I'm just the wrong age group for it. It's not something I grew up with, or something I feel the need. I like to remember stuff. I'm forgetting enough stuff as it is. I'd like to remember more. But I kind of think he works in that way, and I'm happy he does. But I've asked how he uses it, and I'll show you some of the stuff that we've done with him to make it easier. TikTok has actually hit PST's national Trusselbilder, as in our national threat picture, as a potential area for radicalization of young people. And I find this fascinating, but then I understand why. I was having a good chat with Michelle Bustamante, if you haven't met her, she's a lovely security woman from the US. And we were discussing the fact that, people who feel that they're not wanted or don't have enough friends and they find somewhere where they're validated will kind of go, I'll go back to it. And the more they hear something, it becomes nearly like it's been repeated, therefore it's okay, and it becomes normal, and then it becomes a standard for them. And they've said that it's actually becoming a thing for inciting terror. They're turning the peaceful religion of Islam against people because of, someone's saying this is what you're doing, or they're fighting, and it's causing issues. So the PST has actually said we think people are being brought into right-wing extremism, and specifically in Rogaland. I found this online. I had to go and read the PST report to kind of understand what they were saying. And it's just because the fact is that it is appealing to some folks and then it becomes normalized. And when stuff becomes normalized, then it becomes like standard issue racism or whatever, where it's like no one cares. And people don't go, yeah, you're being wrong. They actually just don't call you out on it. So it's a very challenging bit here. So this is a kind of a Norwegian, I'll skip over this one bit. But I want to introduce you to Una. And Una's 18 years old. She loves video games and football, and she's finishing her high school year. Speaks many languages, and she's completely AI generated. And AI, as we know, is the new thing that everyone's using. So I looked at AI and I tried to figure out how much of, say, a Facebook feed is AI slop, and it's getting extreme. And you're seeing AI voiceovers of some stuff, and it's just getting challenging to actually find correct content, etc. But AI is a difficult nut to crack. It is another superb tool. I've been using it to do proof of concepts with Claude. I think Copilot CLI, bang out this piece of code, I feel productive and I can do stuff and it's awesome. But then I also remember my security background and it says, okay, validate your code you just wrote. And it goes, it ain't good. Let's do some work. So I'm going to give you a little test. I'm going to ask you, which one of these people is AI generated? And I'm going to get you to put up your hands. I'm going to ask you, is it number one? If you think it's number one, put up your hand. A couple of people, not so many. Number two. Some people. Number three. You've played this game before. Number four. Okay. If you put up your hand at all, you're right. Because they're all AI generated. Now, I do this with adults and I do this with kids. And I get the kids get upset with me because I don't give them the full talk. Believe me, I don't give them the whole stuff you just saw. I give them other stuff. But they said, Niall, you said one of those kids is AI generated. I said, yes, there's one of all of them. Every one of them, one is in four, it works. All four are AI generated. Now, they find it fascinating and they think, oh, but it's, that's not so bad. This comes from thispersondoesn'texist.org. You can go in, you can type in who you need to get, create a face, and off you go, job done. No issue. And they find that extremely interesting. And then I have parents going, yeah, but we've had Photoshop for years now. No one cares about making fake photos anymore. It says, well, what if I could make them move?
Want to see your crush kiss you? AI has got you covered. Just upload 2 photos. That's it. Try Reviva for AI kiss, hug, and more.
Anyone see the problem here? Your reaction, madam, is exactly what I thought. Oh boy. Reviva is actually, it's marketed as an app to help your pictures come alive. Now, it's a very simple thing that can be misused by, someone taking 2 photos they can find online, putting them together, and all of a sudden you look like you're making out with your local cousin. But I'll be very open with you. I was bullied in high school. The bullying was at school, but it never went home. I never worried about going home. I only worried when I went to school, and it didn't last for too long. I solved the problem doing it a very Irish way with severe violence. It's not my proudest moment, but it started a problem. Now it is possible for the bullying to follow you home. And even more so, it can be stuff, like we've all heard the tattletales, oh, I saw you, you know, hanging out with XYZ. I wasn't doing that. And now there's videos of everything. But then we can now create the videos of everything, and then it becomes a more difficult problem to solve. And people are going, yeah, but like, you know, this is an app and whatever, but like you can't really do much with that. And I says, well, yeah, no. This is using Hugging Face, and this is from September 2025. One thing I want to point out to you is that LLM models will be their worst as they are today. They are only getting better. So these things are only getting smarter and better as we go along. And I have shown this to, for example, in another talk where I show how people have been using it to apply for jobs or try to deep fake people out of it. And this is just an example of what people are up against now, because it looks legit. And you can be whoever you want. I have a great video of Elon Musk and having a chat over TikTok, or you've possibly seen one of the new, Brad Pitt fighting Tom Cruise at the top of a rooftop. It looks just like out of a video quality. It looks straight out of Mission Impossible level quality, and it's just completely AI driven. And it's a fantastic view as to what is possible right now, and it's only getting faster. This is done, by the way, on a local desktop with a gamer PC level of machinery, nothing too fancy. But bullying does happen when I talk about this, and this is why I kind of go from like the very difficult part and I go to what more people are more understanding of, is that bullying very often happens due to either mistakes that are made and they just get out of control. And I want to ask you, how many of you recognize this chap? Star Wars kid? Legend, yeah. Do you know his real name? Giselle Rana. He's based out of Canada. And what's very interesting is he's probably one of the first ever viral memes that was out there. I think launched in about 2003. And of course, if you don't know the backstory of this was a video that was found by his friends that was recorded by him in a school hall and then uploaded to the net. And it went wild. Do you want to see what Gazelle does now?
It has somewhere in the neighborhood of 1 billion views, a number that's still growing. But it was in those first days after shooting this video, something no one was ever supposed to see, that things exploded.
Within about 2 weeks, it was on the cover of the New York Times.
Giselle Raza was only 15 years old when classmates found a video cassette he'd shot at school. They uploaded his video to the web and it snowballed. People added sounds and effects, and it kept growing. When producers from Leno and Letterman, and admittedly this journalist, reached out, he and his parents turned down every interview request. The fear was that people weren't laughing with him, but at him.
At that time, when you have a 15-year-old going through this, I'm not convinced more attention was the right remedy.
But the #1 viral video on the internet is the so-called Star Wars kid.
Now, 19 years later, Raza's part of a documentary shining light on a story he never before wanted told. It's not just a look at what happened, but also what it meant. He revisits the trauma, how he had to leave school, and how the media attention forced his family to move out of their home.
I'm just like...
But he also meets one of the people who originally spread the video. American blogger Andy Bea was 25 years old when he saw it, linked to it, and named it the Star Wars Kid.
I have an enormous regret posting the video. I haven't talked to anybody about this. This is the first time, and I'm just profoundly sorry.
Now, that's something Raza never heard from his former classmates, an apology. His family sued the students and settled out of court. He's moved on, he studied law and rebuilt his life. He's never seen the other students again. Now, one sad irony in this story is how his image was used and spread despite being a minor. The law would have protected him better, he says, if instead of making a video, he'd committed a crime. Mike Armstrong, Global News, Montreal.
So I show this video to kids and I explain this is what happens when you accidentally share. This is why you shouldn't share without permission, etc. And I get them to look at the person beside them and say, imagine this person had to leave their home because of you. And it usually sparks a kind of, oh, I didn't think that would happen because I did this. I said, okay. And we start the discussion about what is, consent and sharing, etc., and making sure, because people are always chasing, I want to be the next, viral YouTuber, I want to be the next viral influencer, etc. And it becomes very difficult for them to kind of see beyond that boundary rather than understanding that it can affect and have blowback on everyone else. So this is all exceptionally horrible stuff. But it does get better. You have to talk to the kids. And it's one of the single and most simple things you can do, but it's honestly, it's probably one of the most difficult things that people don't do. It's like, hey, I'm going to sit down and talk to you about what this stuff actually means, etc. And so you can understand what's going on. Now, my kids they know for a fact, short of them throwing the computer out the window and it ending up looking like this, I can probably fix it. They know, and they know strongly that I have been a security expert for years, so they know there's a hacker in the house, so they know I know all the tech stuff, so they can't argue with me on stuff as easy as others. So I'm taking that into account as well. But my kids understand they can come to me and talk and say, something went wrong, Papa, can you help? Now, I sat down with my son and I said, dude, if it goes wrong, come to me immediately. Don't wait. Just come to me. And know that I might get angry. And I'm not angry at you, it's because I'm scared. Because I'm now trying to figure out what I've got to do. I might get scared. And if I get scared and I get angry, and then I start shouting or do something at you, you remember one thing. And he goes, what's that? I said, time. Time out. Time, something. It is a technique I have learned when I'm under stress, because when I was under stress, I would always do this. If you've ever watched me doing talks, I'll do time out, redo, take two, whatever. It focuses me to fix the problem in front of me. So if he does time, it is a signal to me as a dad to go, Niall, get your shit together and sort out the goddamn problem and protect your son in front of you. Fix this and blame later. But fix it now. Use that magnificent brain of yours to do what you are here to do and what he's asking you to help for. And he knows that. Now, my daughter has the same code, time. They both know this. I told him, do not be ever afraid to come and ask me for help with that, because I will always do my best. Now, I told you I'm still on chapter 13, I'm still on chapter 9. So we talk to our kids. We have at the dinner table, there's no phones. It's harder for me than for the children, because I usually am dealing with the US as they wake up and I want to talk to them, and I just put my phone away. So at dinner time, we have no phones. But we talk, and I ask them stupid things like, what was on TikTok today? Something goofy. Are you all in the same chats? I have asked my son to show me what he learned in computer class, and he learned copy-paste one day. And I sat there for 10 minutes as he showed me how he copies and pastes in a document. It was hard. It's extremely hard, very hard in patience. However, it's very interesting to see, and then it builds trust. Now, I also said that friends are people we know in real life. I showed him this side, he went, who are those? I felt very old then. And I said, people we know in real life. I find who your friends are, people you know in real life. You cannot have, I said, at your age, you cannot have digital friends. People we don't know. And he's in a Snap group with a load of friends. He's a big car nerd, loves to go car spotting in Stavanger. And I said, I don't know who that person is. Oh, that guy lives over in Hundvåg, and it's a little island in Norway, or in Stavanger. And I said, why don't you all come to our house and watch the Grand Tour Top Gear? And he goes, that'd be a great idea. So I got to meet the kids. Cool, nice and handy. We learn from the people around us. We learn from our parents. If we're constantly online, they're constantly online. It's a challenging problem. We have to talk to them and understand what to do and help them understand what to do. And if you're wondering what kids are actually installing, it's online in Bufdir, and they'll show you. What I can't understand is those who have for like Tinder when they're like 12 or like all this. But it's YouTube and Google and Snapchat, and Vips came along in 24 when I think they allowed it for under 12s or under 13s. Now, you can put in parental controls on your devices. I'm going to show you all of them, but you cannot control everything. It's absolutely impossible because it takes an immense amount of precision and practice to get right. I've made mistakes. And I will tell you one of my worst ones. I have my son, we have a family group in this lovely device called family sharing. So I have all my kids, I have the 2 kids and my wife's, we're all in the family sharing group. Mine was connected up with my payment card, and I had disabled it so he could use to buy something and forgot to re-enable the block. And he ended up buying 10,000 kroners worth of Robux. And he emptied out my slush fund. Now, myself and my wife have a joint account, and we get I get a little amount of money, a kind of stipend or pocket money, so I can buy Lego or whiskey, because otherwise our house would be made of Lego bricks. And it's there, and he managed to empty that, and he was upset. Not that I was angry. I wasn't angry at him. I was angry at myself because I made a mistake, and I have 25 years in this business, and I still screwed up. I tell this story to all parents because I want them to know it does happen. And you are not a failure if you do this. Because I don't consider myself a failure. I just consider it a very expensive learning experience. Family sharing is phenomenal. My son has it. We have the location sharing turned on. And it's not because we want to know where he is. We want to know where he left his phone or his AirPods. But it has a really interesting, cool thing. He can send me a text message with either the Batman logo or the Joker logo, clown. If it's Batman, it's come get me. I want out, come get me. If it's Joker, come get me and look goddamn crazy. Be angry. And he goes, but why would I want that one? I says, think about it. You're in a thing, you don't want to be there, but you don't want to lose face. I will be the angry dad, the asshole father. The one who said, get your ass in the car. What the hell? Why? I've been searching for you for 2 hours. You all right? Yeah, I'm good. He knows he has that safety net. It's great. It's an ideal. He just has to say, he loses nothing. He doesn't have to say, I sent a text message. He sends me a thing. And if he does like a missed call or something and I can't get hold of him, I'll see where he is and I'll give him a call back if I don't get him again. I might just go and wait and ring him and find out what he wanted. We have to work that bit out yet. Google Family also works great. There's also Microsoft have one specifically. For those of you with Snapchat, believe it or not, there is a family center for Snapchat as well. If people aren't using it with their kids, I highly recommend it. It's very good. You cannot see what they're texting. You can just see who they're texting, which is a very handy thing, especially if you're trying to figure out what's going on. Family pairing also exists for TikTok, believe it or not. And if you have Instagram, which a lot of folks do, there is teen accounts which are locked down and much more aggressively secure up for you. Discord is massive if you are a gamer. My son, first thing when he turned 13, he wanted Discord. And he wanted me to put it on the PC or a laptop because it didn't work so well on the Xbox. For those of you who don't know about Discord, Discord is not actually just an app, it's a platform. It supports video sharing, voice calling, messaging, etc. Unfortunately, Discord is having a massive problem with people with nefarious and very often kind of dodgy intentions trying to track kids. And it's also used in conjunction with Roblox quite a lot. And I'll explain that in a second. If you have the Xbox, of course, you probably have screen time for your family sharing or whatever, the same with the PSN or with even Nintendo. And then we get to the Roblox thing. Now, for those of you who have children in this age group, this is a virus, in my estimation. However, it's a game platform. It is not a game. It allows creators to build applications that they can run and sell to other people on the platform. It's a fantastically popular, really crap graphics thing. It's basically like Minecraft in that kind of graphic style, but it allows them to create games. What has been coming along is there's a virtual in-game currency called Robux. Remember that 10 grand of Niall spent on Robux that he didn't want to? That's this. Now, you use it to buy skins, buy other games, access, etc. But kids are mad to buy Robux because it's in-game currency and it's freemium or free to play, but it's if you want, you play to win. And unfortunately, there's a number of accounts have been cropping up which are people who are contacting children saying, get onto Discord, if you send me a photo, I'll give you 200 Robux, etc., and are basically buying for $2 or whatever, $1 worth of real currency, naked photos of kids being supplied by the children themselves so they can buy the latest skin in-game. 34,000 accounts were shut down last year in the last kind of thing, and it's been a massive challenge, and it's really coordinated with Discord. I'm nothing against the two platforms. I just mean that they just need if your kids are playing with them, they need to understand this. And my daughter started playing with my son on this, and we've had this conversation. If anyone contacts you or tries to contact you that's not Magnus or my son's name, please come and contact us, talk to us directly, and we'll help you understand it. She understands that it's not me mistrusting her, it's more I mistrust everyone else around that. And she's happy, she's okay with that. So if you're using WhatsApp, Telegram, and Signal, these don't have family controls. And very often WhatsApp is a common thing being used by sports groups and other things to coordinate because there's a lot of people using it. Unfortunately, it doesn't have the same controls. And while I don't think I'm not against end-to-end messaging encryption, I don't think we need Pentagon-grade Signal chats between my 13-year-old and his other friends, where reporters can drop in. The core message of this talk is talk to your children. Engage with them and help them and navigate and understand that the internet is hard and can be potentially dangerous. My kids are both Irish and Norwegian. They're Norwegian first, they're Irish second. It's where they live. Here, they speak Norwegian, they speak English as well. When I take them to Ireland, I have to remind them they need to eyeball the driver when they cross the road. They cannot do the Norwegian, I'm just going to walk across here. There's a crosswalk, I'm walking, it's fine. In Ireland, the cars don't stop till you put your foot in the road. And they may not stop in time. It's not out of badness, it's just the way it's a different driving culture. And I said, when you're there, you stop, you acknowledge the driver, you make sure, actually it would be this way, you make sure, I have to make you laugh a little bit. I realized when I did this the first time round, people were dying in the audience, so if I'm going to make you a little bit so you come out on a high, I look this way and I say, eyeball the driver. Tell them you want to cross the road, make sure they stop, and then cross. And they went, why? I said, otherwise you're going to be looking like a hood ornament on that car. And it's not because we're bad drivers, they don't think. So they've learned this. They also have learned that it's different cultures in Ireland, so there's different things being said and whatever, so they have to learn that. And it's the same thing. So we talk to them a lot about this stuff. I talk to them about the stuff online. I've talked to my kids' school about this stuff. And I've helped them understand that it can and will be better if they talk to their parents or an adult they trust. There's a hell of a lot of information on that. So I've made a nice GitHub repository where you can download all the links, all the links there, all the information from sorry, if you can't connect that, all the information from the various Norwegian security, like for example, Politi, Bufdir, Mediatilsynet, Barnetilsynet, etc., all those great organizations, and they're kind of proper good stuff on it. So you can kind of there, and I am taking pull requests. If someone wants to go, hey, wouldn't it be great if we talked about this? I said, yes, fantastic, let me help you write that out. Ladies and gentlemen, this is a horribly hard talk to deliver. It's a horribly hard talk to listen to. I appreciate that you sat through it. I hope that you take the message away that we will be better and make sure that everyone around us is safer. because we know more now. And also that we are going to help people. Like, you don't have to go up and say, hey, all this is wrong. You just have to kind of say, listen, have you thought about it? And help people understand to be better. With that, are there any questions? Yes, sir.
Yes. I know there's an initiative going on now, because at like the children level schools, basically no smartphones until you leave, the first, like until you're 13.
Okay.
What's your take on it?
So for the video, what is the take on a lot of the Norwegians schools going for no smartphones till you're 13? Yes and no. I believe having phone-free schools is a good thing. My son is in one of those. He has to deposit his phone in the morning and he gets it back when he goes home. You bring up an important point, which I didn't mention. A lot of the problems people have with this is the fact that when one of the kids gets access to an app, all the other kids have to get access, which means your choice as a parent or guardian has been taken away by some other parent, which is another thing of it takes a village. And by doing it at this kind of level, it kind of makes it easier because we've offset, I don't want to be the strict parent. I had a parent say to me once, I find it very hard to say no to my children. I said, I find it very easy to do that. It's actually quicker than saying yes. It's 2 letters versus 3. And I absolutely, Sindra, I take your opinion on this. I think there's no kind of good answer for this, other than the fact that if you are a parent, you're saying, oh, it's okay, my kid has this, remember, and then you've made a decision for all the other 30 kids in the class, or 20 kids in the class. And if you then go, ooh, it's like everyone has to have a red bottle. Well, then I would probably be a little bit more skeptical to it, So you have to understand, and this needs to be taken up at a kind of both a school and a family and around a group level, whatever. And it's really hard because not everyone understands this. So I think if you're looking for an initiative that helps other parents survive this kind of wave of, oh, well, John has Snapchat and he's 12 or he's 10, I want to have Snapchat because I'm the only one left out. It's a real hard, there's no easy answer for it. I have an opinion on it that I believe they could have phones, yes, whether smartphones, it'd be cheaper for the parents because they're like, if they give them a Nokia, 5210, it'll never break. You could put that thing on the front of a tank and it'd knock it out. But it's hard. Everyone wants the new stuff. It's hard. Yes, it is hard to say no to kids, but I find that just give them a reason as well as why they can't have it. Yes, sir.
Kids learn so much more by imitation than by anything verbal. What are things that we can do as parents to demonstrate responsible technologies, especially to very young children?
Wow. What can we do as parents to demonstrate responsible technology to young children? I told you that we put our phones away at dinner time. We do that. When my parents come to visit, my dad finds this hilarious. I've told him to put his phone away and turn it on silent. And he finds that he's not allowed to take calls at the dinner table very odd. But I said, my house, my rules. You did that for me for 18 years. If you ever watched this, sorry, Dad. No, I think there's showing them, like, for example, putting your phone down for a bit. Like we have started watching like Mestrens Mester or Team Pulse as a kind of family activity. And if you've ever haven't watched Team Pulse and you're Norwegian, Jesus, it's like someone's cutting onions inside in your living room. But we do it because it encourages us to be together for at least an hour and have a common thing to talk about. I'm sure my grandparents went through this from when the television and radio and went from the paper to this. I'm sure. I believe that if you show your kids that it's possible to leave your phone down, it's very hard. I turn my phone to silent. I have it shut down from midday, or not midday, sir, from 10 o'clock at night. I don't take any work notifications after about 7. So I just put it down. And if that's all I can say, really, just show as best you can. I believe we're at time. 1 more minute. I have one more question. Yes, madam.
What do you think it might take for them to put some sort of upfront technology, AI, whatever, on a camera that would just stop the ability to take these photos, share these photos?
what would it take to put AI up in front to say, hey, you can't do that? Apple have some of that with their whole kind of nudity filters. I think it'll be bypassed. Listen, I saw there was this, so I've worked with biometrics before, and it was back in 2001, and I managed to bypass fingerprint validation with a gummy bear. But I don't think, I had this discussion with someone that says, I remember saying to someone, I've never said to my sons, don't send news. I said, don't send news to anyone you don't know, or you don't want them to be seen by, or you don't trust. And he goes, okay. And the woman was really upset with me. He said, well, why did you say don't send news? I said, well, I really don't think it's going to not happen. So I'm hoping I can just help him, guide him, but I don't know. Do I think there will be an AI solution for this? Possibly in the future. Do I think it's a good idea? No idea. I'd have to think about it. It's a great question. But yeah. Yeah. I think that's hilarious. Yes. Yeah. Man shaves his nipple. Oh, it's gone. But you know, it's really hard. There's bypasses to everything, and humans are ingenious at getting around stuff. All right. I'll leave that as the last question, and I just want to thank you so much for suffering through this, and I appreciate it. Have a great rest of your conference. Thank you so much.
Hello and welcome to Save by Design. I'm going to talk about the UX of secure banking. I am Dora Moxie. I live in Norway. I really do like books, and let's be honest, the Norwegian weather makes it really possible for me to read a lot of books. But it also makes it possible to go for a hike. And during a hike, I really do love to think about multiple problems. After a good hike, I do enjoy a good cup of coffee. Now, after I'm energized by a good cup of coffee, I deal with UI and UX, especially with data analysis and problem-solving part of the UX. And when it comes to my learnings, I really do love to speak about it. Now, today, I'm going to share a lot of stuff that I learned recently, and since this topic is going to be very heavy, I apologize first and foremost, but I'm going to look at my speaker notes because there's going to be a lot. Usually, I don't do that. I usually speak from the heart, but this time I'm going to share a lot with you. This time, I'm going to talk about security bank application. So, let us begin. We will start with a seemingly simple authentication problem that quickly reveals deeper tensions between usability and security. We will look at what actually happened when different stakeholders tried to solve it and how complexity emerged. We will uncover the core insight: authentication isn't a static feature, but a dynamic system involving risk, uncertainty, and human behavior. We will explore principles that make security systems remain safe, even when things fail. We will see how these ideas translate into real design decisions and practical solutions. We will close with what this means for how user experience design teams and security teams should think and collaborate moving forward from day one. So this is the journey I would like to take you on today. Attackers rarely break your login system. They don't need to. They go after recovery, forgotten passwords, account resets, support calls. Basically the fallback paths, because recovery flows often have fewer safeguards and more human decisions. Therefore, your security flow is only as strong as your worst recovery flow. In a banking application, those moments aren't considered as edge cases. They are everyday reality. And designing them forced us to confront a deeper question. How do you stay secure when users forget things, devices change, and technology fails? In security, we often talk about the CIA triad: confidentiality, integrity, and availability. Confidentiality means only the right person gets access, and this is what we usually focus on, preventing unauthorized access. Integrity means only the right person can change things. In practice, it means actions that are legitimate: transactions, changes, approvals when it comes to a banking application. Availability means the right person can get access to the system when they need it. And this is often underestimated. If legitimate users cannot access to their accounts, the system has already failed, regardless of how secure it is. Authentication directly affects all parts of the CIA triad. If it's too weak, confidentiality and integrity fails. If it's too strict or fragile, availability suffers and users get logged out. In mobile banking, we typically balance this by using 3 factors: device binding, something you have; biometrics, something you are; and a PIN or a passcode, something that you know. These aren't just login methods. They are mechanisms for balancing security and access. Deciding how they work together especially when things fail, is where user experience becomes critical. Authentication is where all these three can collide. The context for all this was actually very simple. We were working on a mobile banking application, and the goal sounded straightforward. Biometric authentication as a primary method, and a PIN as a fallback. That's a very common setup today. Users expect it, the platform support it, so it's kind of simple, right? But as soon as we started designing the real flows, not just the happy parts, reality showed up. Security requirements conflicted with usability. And suddenly that simple fallback turned into a whole ecosystem of edge cases and risk decisions. Those decisions are exactly where user experience and security must strongly align. Let me walk you through the 6 problems that we ran into. One of the first problems we ran into is very human. Security policies assume people will create unique access codes. People assume they won't have to remember them. If we ask users to create a PIN for the banking application, many of them will reuse the same PIN or passcode that they are using for their own mobile device. Now, from a security perspective, that creates a huge risk. If someone gets access to a device PIN, they might also get access to the banking application and thus the finances of the user. Now, the independence between authentication factors is completely gone. When credentials are reused, protection and access-related risk increase immediately. This pattern, humans reusing credentials, is behind many real breaches. In the Dropbox breach in 2012, attackers used passwords that employees had reused from other compromised devices. Once attackers obtained those credentials, they were able to access internal systems and eventually steal millions of user records. The technology didn't fail. The assumption that people use unique credentials did. This leads to an important question. Can we build security that doesn't depend on perfect user behavior? If a PIN is reused, the risk of balancing protection and access does increase. But that doesn't automatically mean the system is broken. If authentication factors are truly independent, then the system still has protection, even when one factor is weak. Security shouldn't depend on user perfection. It should depend on layered, independent controls. And that brings us to the real insight here. The problem isn't that users reuse access codes. The problem is that we designed systems that assume they won't. Resilient systems assume error. And once you accept that, the design approach changes immediately. Systems fail when they assume perfect behavior. Resilient systems assume mistakes. And once you accept that, that changes the design approach. Be honest. How many of you reuse one PIN somewhere? I assume so. The second problem is also very human, but a bit ironic. Biometrics are great for usability, and people use them all the time. But because people use them all the time, they forget their PINs. This often happens when users urgently need money. We had users who couldn't access their account because their biometric sensor was damaged. They weren't trying to hack anything. They just dropped their phone, but the system immediately treated them like a threat. When biometric authentication fails, which it will, users suddenly need a fallback they haven't used in months. And suddenly, we are in a recovery situation. In this case, do we allow a quick reset, like an email or a one-time password, which is good for usability, but potentially weaker for security? Or do we require something stronger, like a full KYC, know your customer process verification? Which is secure, but let's be honest, very frustrating, going through on taking photographs of your identity cards, and then NFC reading, and then selfie video upload, and then manual support. It's too much. When biometric authentication fails, users suddenly need a fallback. Yes. The core question becomes, what level of identity proof is proportional to the risk while still having good user experience? This isn't just about working authentication. It's about managing risk without breaking availability when people behave like people. Quick show of hands. How many of you have ever been logged out of your own account? Yes. When we talk about forgotten PINs, we are really talking about recovery. This is dangerous territory because recovery is authentication, but usually with fewer safeguards. Recovery is where attackers often win. If we make it too easy, we increase confidentiality risks. Attackers may be able to reset access. If we make it too strict, we damage availability. Legitimate users get locked out of their own money. Recovery decisions are always CIA trade-offs, and this is where design decisions matter. Instead of choosing between easy or secure, we can design progressive assurance. For example, if the user is on a known device, maybe an SMS or an email confirmation is enough. If the device is new, we might ask for biometric verification or a selfie check. And only if the system still isn't confident do we escalate to something stronger, like a full KYC. The most legitimate users recover quickly, while higher risk situations still get strong protection. That's how we balance security and usability. Biometrics are great until your phone decides that your face is suspicious. The third problem is about biometrics, and specifically third-party biometrics. In our case, we are using a recognition API for face recognition. It's a powerful service, but it's also continuously evolving. Models change, thresholds change, performance changes. And Amazon is very clear about one thing. They provide a technology, but how we use it, especially in security-sensitive scenarios, is our responsibility. So if the system fails to recognize a legitimate user, or worse, incorrectly matches someone else, the risk doesn't belong to Amazon. It belongs to us. Because when the system is uncertain, we cannot block the user. That hurts availability. We also can't blindly trust the result. That risks confidentiality and integrity. When biometric technology is uncertain, and it always is, the question isn't whether failures will happen. They will. The question is what happens next. Biometric systems produce probabilities, not certainty. That means authentication always contains some level of uncertainty. We can't remove that uncertainty with a single technical control. If confidence is high, authentication proceeds normally. If confidence drops, the system asks for another signal, like a PIN or another verification step. From the user's perspective, this feels like a smooth fallback. Under the hood, it's managing risk. This is where UX plays a critical role. It absorbs technical uncertainty and turns it into a predictable user experience. The fourth problem is about retries. And this is where things get counterintuitive. From a security perspective, limiting attempts makes sense. Fewer retries means less opportunity for brute force attacks. But from a human perspective, mistakes happen all the time. People mistype their PINs, or biometrics fail, or the sensors are broken. Now we have another tension. Security wants fewer attempts, while users need tolerance. And here's the surprising part. Retries themselves can become the attack vector. We've seen this in real incidents like the Uber breach in 2022. The attacker didn't break the encryption. They obtained employees' credentials from the dark web, and while pretending to be IT support, they started to send multiple, absolutely maximum amount of multi-factor authentication requests until a certain point when the user had enough and just approved one. And bam, they were in. So the technology still worked. The weak link was the human being. The deeper question is, are lockouts actually improving security or just moving the risk somewhere else? When we introduce lockouts, the intention is good. We want to protect confidentiality by stopping repeated attempts. But lockouts also damage availability. And when availability drops, new risks appear. Users get frustrated. They contact support. They look for shortcuts. And those moments, frustration and urgency, are exactly what attackers exploit through social engineering or recovery abuse. This leads to an important realization. Security that frustrates the users creates new vulnerabilities. Because the moment users lose control, they start making rush decisions we can't predict, and that's where systems become fragile. The fifth problem appears when something very common happens. A person reinstalls an application. From their perspective, nothing really changed, right? It's the same phone, the same person, they just deleted and reinstalled an application. But from the system perspective, everything may have changed. Device binding might be lost. The cryptographic keys might be gone. We are losing the possession factor, which directly affects confidentiality and integrity. And now we have to decide, do we trust this device again, or do we treat it as completely new? Platform differences make this even more complicated. On iOS, secure storage can sometimes survive the reinstall, which helps continuity. But on Android, reinstall often looks like a brand new device, which increases friction. Device binding is incredibly valuable because it strongly protects confidentiality and integrity. But when that binding disappears, for example, after a reinstall, availability takes a hit. Users face more friction, more verification, more uncertainty. When a system trusts that you physically control a device, that is a very strong signal of identity. It's much harder to fake possession than to steal a password. And this is where UX design plays a crucial role again. If we can restore continuity in the same way, recognizing the user, guiding them smoothly, escalating only when needed, we rebuild the trust without weakening security. Because when systems feel consistent and predictable, users trust them more. And that's why invisible continuity isn't just a usability improvement, it's a security mechanism. Users trust systems that recognize them because recognition reduces friction and uncertainty. When systems remember context, users feel in control instead of being challenged. Imagine you cannot access your money right now when you need it. Would you calmly read the instructions, or would you just tap anything in a hurry, right? The last problem is probably the most human one. When users cannot access their money, stress rises immediately. Under stress, cognition changes. People do not read instructions. They do not behave rationally. They just want the problem to disappear. Even perfectly written guidance may be ignored, and the experience feels broken, even if the security is technically correct. And this is not just a usability issue. It's also a security issue because stress is an attack surface. Social engineering works precisely by creating urgency and emotional stress, emotional pressure, pushing people into decisions that they wouldn't normally make. So the question becomes, how do we design authentication and recovery experiences that still work when users are anxious, frustrated, or in a hurry? Calm users make better and safer decisions. But when users feel blocked, confused, or locked out, they lose their sense of control. And once that happens, behavior changes. They start guessing. They rush the decisions. They contact support in panic. They may fall for social engineering. Under stress, their brain shifts from analytical thinking to reactive thinking. That is why they don't read. But it's not laziness. It's simple biology. What started as an availability issue can quickly cascade into confidentiality and integrity risks. That's why taking emotional stress into account during designing isn't just a UX concern. If we can keep users calm, give them clarity, show progress, and provide predictable next steps, we reduce risky behavior. So emotional regulation, helping users stay in control under stress, becomes a security control itself. Up to this point, we've talked about problems conceptually. Now, let's look at what happened in reality. This is the first workflow that was created by product managers. Their idea was to reuse an already existing flow for the B2B, business-to-business mobile application of the same bank. They didn't want to establish a new flow from scratch. They wanted to optimize, to patch this already existing flow. They knew that this is not a good enough flow for the users, but under time pressure, this seemed to be the best idea. This is where the flowchart started to look more stressed than the users themselves. At some point, the team realized that they must do something about the flow. It came from discussions between product management, security, compliance, and even legal professionals, with the goal of covering every possible case and edge case in one system. But this took weeks, even months, multiple discussions and meetings. And just think about it. This has become a very expensive problem, right? Multiple meetings for months, well-paid professionals getting nowhere. This is not just pointless. This is money. So this became a problem. Without UX design and development involved in the beginning, the result became extremely complex as well. Multiple branches, edge cases everywhere, hard to reason about, hard to implement, hard to explain to the users. Complexity is very dangerous, not just for usability, but for security. Complex systems always hide vulnerabilities and have inconsistencies and opportunities for mistakes. Complexity is the enemy of both UX and security. The reason is actually the same in both domains: people. When systems become complex, people stop understanding them fully. Designers lose the overview. Developers make assumptions while developing. Even when we were looking at the first flowchart, we could feel it. We started following one branch, and then another, and eventually we lost our train of thought. And if we can't reason about the system clearly, we can't secure it either. Complexity inevitably leads to gaps, edge cases that weren't considered, inconsistent states, unclear recovery paths, implementation mistakes. From a UX perspective, complexity increases cognitive load and confusion. From a security perspective, it increases the attack surface. Based on historic data, attackers don't break simple systems. They exploit the parts we don't fully understand. Simplifying flows isn't just about usability. It's about making systems predictable, understandable, and therefore more secure. Now, I know that 60 minutes is a bit too much, so just let it move a little bit and, bear with me. Yes, move yourselves, don't be shy. This is very important because this is helping for your brain. I mean it, come on. This is very important. Yes, stretching and, we are still human beings. And I know that we are in a security conference where everyone is very, very strict and yes, but we still need some fun, right? Because we still have a few minutes to really dig deep into this, because there are 4 more acts to discuss. So here comes realization. At this point, we had 6 different problems on the table. People reuse credentials. People forget credentials. Biometrics fail. Retries create risks. Devices change. Users get stressed. At first, they looked like separate authentication challenges. But when we stepped back, we realized they were all symptoms of the same underlying issue. We were treating authentication as a static technical feature, something with fixed rules, fixed flows, and predictable behavior. But in reality, authentication lives in a dynamic environment. The real problem wasn't pins or biometrics or retries. The real problem was that our mental model was too focused on one thing. That led to the realization authentication isn't just a login mechanism. It's a continuous risk management process involving human beings. And if that is true, then UX cannot sit on the top of the security as a presentation layer. UX is an enforcement mechanism because adapting to risk, uncertainty, and human behavior isn't optional anymore. It's necessary for the system to remain secure. If risk changes step by step, identity confidence should too. We do not jump from 0 to full trust in one moment. We build the confidence gradually. The system starts with the signals it already has. Maybe it recognizes the device. Maybe we confirm possession with a one-time password. Maybe we add biometric verification. Full KYC becomes necessary only when the system still isn't confident. Instead of forcing every user through maximum friction, we increase assurance only when the situation requires it. Why this matters is that it protects confidentiality and integrity while preserving availability for legitimate users. And this approach turns recovery from a painful experience into a controlled, risk-based process, which is exactly the kind of balance we've been talking about until now. This pyramid shows how identity confidence grows by layering independent authentication factors. At the foundation, we start with something the user has, for example, a trusted device, that already provides meaningful assurance with relatively low friction. To increase confidence, we add something the user knows, like a passcode. Then we strengthen it further with something the user is, biometrics or within biometrics Face ID or touch or fingerprint. Each layer is independent, meaning that this independence is what creates this strong security and ensures it. And only at the top, when the risk is high and uncertainty remains, Do we require full identity proof, such as KYC? The important idea is that security doesn't come from one strong control. It comes from layering independent signals and increasing confidence step by step. Most legitimate users stay in the lower layers with minimal friction. Stronger verification only appears when risk justifies it. If authentication is really a continuous risk management problem, then security strength cannot be fixed. It has to adapt to context. Instead of applying the same friction everywhere, we adjust. This is how we protect confidentiality and integrity without unnecessarily damaging availability. We are dynamically balancing the CIA triad based on real conditions. This is exactly where UX designers and security experts start working together instead of against each other. And this became very clear when we looked at competitors. We saw very different decisions being made. For example, in some cases like Revolut, if the app had previously been installed, users could regain access simply with something relatively lightweight, like an email verification. When we discussed that within the team, internally, our compliance and legal teams and even the security teams had much lower tolerance for that level of assurance. Their view was simple. Email alone is not strong enough proof of identity for a banking access. We are protecting financial data. We are protecting a lot of very sensitive data. We cannot have this kind of risks for ourselves. This is a small company. So that revealed something important. These flows are not purely technical decisions. They are risk tolerance decisions. Every organization is implicitly deciding how much breach risk it is willing to accept and what impact it can absorb if something goes wrong. And those decisions directly shape the user experience. Authentication design isn't just about technology or UX. It's about organizational risk appetite. This table shows how authentication isn't just about factors, it's about decisions. This is a coordination model. If we read it from left to right, we move from low friction recognition toward high assurance identity proof. Each column combines 3 dimensions: the technical tools we use, the primary security concern at that stage, and the user experience goal we want to achieve. What this really shows is that authentication design isn't just a technical escalation. It's coordination between risk, security controls, and user experience. And that coordination is what allows the system to remain both secure and usable in real-world conditions. We usually design for success, the happy path. But security is mostly invisible when things work. Users only notice it when something fails. And failure is exactly the moment where everything becomes fragile. Users panic, attackers look for opportunities, and trust can collapse very quickly. Instead of starting with a happy path, we start with possible failure cases. What happens when biometrics fail? Credentials are forgotten, devices change, and confidence drops. If those moments are safe, predictable, and recoverable, the system stays secure. And when they are not, even strong technology can feel broken. So designing for failure isn't a UX technique, it's a security strategy. This visual shows what happens when authentication fails. On the left, failure creates uncertainty. Users don't understand what went wrong. They try random things, random actions, frustration grows, and the risk increases. On the right, the system stabilizes the situation. The user receives clear feedback, predictable recovery path, and controlled next steps. The failure itself doesn't disappear, but the system absorbs it instead of escalating it. And that stabilization is what prevents small authentication problems from turning into security incidents. Secure systems don't come from discipline alone, from one discipline alone. Product ensures decisions are aligned with risk tolerance and business reality. Security ensures that the system is failure safe. And UX ensures it's usable under real human conditions. When those three perspectives work together, we get secure user experience. When one is missing, the system becomes either unusable or vulnerable. This realization changed how we approached every decision afterward. Instead of asking what is the right authentication method, we started asking different questions. What is the current risk? What confidence do we already have? What signal do we need next? Authentication stopped being a fixed flow with predefined steps and became a system that adapts to context. And that shift matters because static systems eventually break when reality changes. Dynamic systems absorb change. We didn't have 6 problems. We had one wrong mental model. When we fixed that mental model, that was what allowed us to align protection with usability, not in theory, but actual practice. Resilience means the system stays safe even when components fail. And resilience is what prevents small authentication issues from turning into real problems. The real question isn't how to avoid failure. It's how to design systems that stay safe when failure happens. A few principles consistently help with that. First, start with designing for failure. Authentication becomes visible the moment something breaks, so that moment has to be predictable and recoverable. Second, remove dead ends. When users hit a wall, they will improvise, and improvisation immediately creates risk. Third, reduce the need for credentials and use familiar patterns. The less cognitive effort tasks require, the fewer mistakes users make. And finally, let friction follow risk. Low risk should feel easy. Higher risk requires another verification, but only when necessary. All of this builds resilience. There is a common assumption that better usability means weaker security. But what we've seen is actually the opposite. Good UX increases the probability that security used correctly. If systems are predictable, understandable, and recoverable, users do not need to invent workarounds. They do not write things down. Do you remember how many people used Post-its around their displays, right, to store their passwords? This is a classic example, but it actually happens at every single company. This is just crazy. And if the systems are predictable, understandable, and recoverable, the users won't panic. They don't bypass controls. And that is directly improving security outcomes. Confidentiality improves because unsafe behavior decreases. Integrity improves because actions are clearer and confirmation is stronger. And availability improves because recovery is smoother and less disruptive. Good UX isn't a compromise with security. It's one of the mechanisms that makes security effective in the real world. The strongest control in your system is that one people actually use. We've talked about problems, patterns, and principles. Now I want to show what happened when we actually applied them. Because theory is interesting, but implementation is where security either succeeds or fails. Remember the original huge chaotic flow that I showed you before? Now you see what happened when UX stepped in. Instead of one massive flow, we separated the scenarios. Each scenario became simpler, easier to reason about, easier to follow, and thus easier to secure. And we had to realize security problems often look complex because we are mixing different situations together. When you separate the context, both UX and security improve. Once we changed the mental model from static feature to dynamic human risk system, the implementation direction became much clearer. For us UX designers, it made sense to separate these flows. This is how we could think it through. This is how the flows were simple enough so that we could think of potential security failures. But with this, we also achieved one more thing. The system could adapt. When risk was low, known device, familiar behavior, access felt fast and effortless. When uncertainty increased, new device, unusual context, the system added verification. And when the risk was truly high, we escalated to stronger identity proof. From the user's perspective, this doesn't feel like more security. It feels like the system understands the situation. And that's the key idea. Adaptive security removes unnecessary friction. We weren't choosing between usability and protection anymore. We were adjusting security strength to match reality, dynamically preserving access while maintaining trust. We designed predictable recovery paths, progressive escalation, and clear guidance. We also adjusted retries and lockouts, not just to block attackers, but to avoid pushing legitimate users into panic or unrealistic, unsafe behavior. And something interesting happened. By making failure safe, the overall system became more secure because small problems stopped turning into security incidents. What we really implemented wasn't just new flows. We implemented resilience. We protected the system with layered, independent factors. We supported the human with clarity and familiarity. And we adapted security strength to risk and confidence. That allowed us to solve the 6 problems while still preserving confidentiality, integrity, and availability. This is the key idea. Security works best when systems are designed for how humans actually behave, not how we wish they behaved. And that leads directly to the final takeaways. After everything we implemented, the biggest lessons weren't technical. They were about mindset, about how we think about users, how teams collaborate, and about how security is designed from the start. These are the ideas I believe matter most when we are moving forward. One of the biggest takeaways from this project is simple. Humans are not the weakest link. They are part of the system. People reusing credentials, forgetting things, getting stressed and making mistakes, none of them is unusual. It's natural. It's predictable. When we design with that mindset, when we design for real behavior, not ideal behavior, we reduce unsafe workarounds, improve the recovery, and ultimately improve confidentiality, integrity, and availability. UX and security are often seen as contradictory forces, like security adds friction while UX design removes friction. In reality, both disciplines want the same thing: safe outcomes. Security understands threats and controls, and UX understands cognition, emotion, and behavior under stress. Both disciplines are risk management, just from different angles. When those perspectives work together, we get systems that are both usable and secure. When they don't, we get systems that are either unusable or vulnerable. Collaboration isn't optional, it's architectural. What this really comes down to is when decisions are made and assumptions behind them. Security often gets designed first, and then UX designers are asked to make it usable afterward. Remember that huge chaotic graph that I showed you? That started when product management approached me, actually, and they just told me, okay, we need screens for every single little box. And I was like, no, this won't work. And they didn't really understand why. They got used to the designer saying, okay, yeah, sure, we are going to deliver those screens for you, and then we will see how it works. But when I saw that chart, I was like, nah. And that was the point when they involved me and backend developers and security experts, and then we started to think about real-world scenarios. We are all using mobile banking applications. So we actually started to compare them. Okay, what does Revolut do? What does Wise do? So we compared these use cases, and we saw that this can actually be simple if we want them to be. And that led us to the separated scenarios. When we finally understood that these flows can be simple because they are separated according to their context, that was the point when we actually reached a breakthrough. We've seen that this order that security is asked afterwards doesn't work well anymore. Authentication today isn't just a technical control. It's a human interaction under uncertainty. So UX couldn't sit on top of security. It should be involved when security is defined, when we model threats, when we define recovery, when we decide acceptable risk, when we design failure paths. That is how we build systems that work not only in theory, but reality. And when systems work in reality, the users, all of us, we will trust them. We've been talking about authentication, risk, uncertainty, and design decisions. But underneath all the technology, something much simpler is happening. Every security control eventually meets a human being, a person entering a PIN, a person responding to a prompt, a person trying to recover access, a person under stress, in a hurry, or being confused. And in those moments, the outcome isn't determined by cryptography alone. It's determined by whether the system guides the person safely or leaves them struggling. That's why user experience design isn't separate from security. It's part of how security actually works in the real world. Because in the end, security only works if users can succeed. Thank you. One more thing, since we do have a little bit of time. If you do have questions or you do not agree with some part, just reach out to me on LinkedIn or right now, and then I will try to answer. I don't know if you noticed, but in the beginning, my slides were a little bit mixed up. That was due to a very interesting story. I will tell if someone is interested. But I'm sorry for that. I usually speak from the heart, and I usually use slides just to support what I'm saying. But right now, it was very hard to bring it together. But still, I do hope that I could give you something with this talk. Thank you.
Laughter will sort of make people come in from outside. Or maybe, maybe not. Let's see what happens, eh? At least there's one complete row. That's a win. I did a talk in Russia before Ukraine, back in 2019 or something, in Siberia, honestly, at this time. There were fewer people than, well, there was about 4. It was the only time I've ever done a conference talk, and I've bought the whole audience a pint afterwards. It was, I mean, that bit was fun, but the talk itself was like, well, I said to them, we might as well sit around a table. Right, let's go. Hopefully, I hope I didn't get anybody in here on false pretenses, right? Because I'm going to talk about some robberies and what we can learn from them, but I might be lying occasionally, so we'll see what happens as we go. So what can we learn from the world's biggest heists? Well, let's crack on. So, I'm James. Nice to meet you all. If you come and talk to me afterwards, that would be fantastic. I'm not a security engineer, or even, I guess I am a security professional, but I was a software engineer. I moved into consultancy. Then I was a VP of engineering, head of platform, stuff like that. And then about 4 or 5 years ago, a company I worked for, a startup, I said to the CEO, if the person in the company that you own that knows most about security is James Burney, you're in real trouble. And that enabled me to get the budget to hire a head of security. Unfortunately, that startup then started running out of money, and 6 months later or so, I was forced to make him redundant. But then he consulted back to our company, and about a year after that, he was badgering me saying, please come and work with us in this new consultancy I've set up, because the problems that we have in security delivery are the same as XYZ delivery, right? It's just less mature. So we need someone like you, because my background was more in software delivery and making funny systems work, like the people's systems and everything like that. So for the last, coming up for about 18 months, I've worked with Matthew. We've set this company up called Foro. We're doing strategic consultancy, really. I won't dwell on this, but the cool thing about this is we're doing now a couple of gigs on quantum threat preparation. So years ago, before the lockdown, I did a talk on quantum computing and how it was threatening the world's cryptography. And finally, we managed to persuade a client during the back end of last year that they should invest in understanding the threat and getting their systems ready. So if you're working for a company that doesn't even have quantum computers on the threat radar, give me a shout afterwards. I'll happily hand over a business card. We've got another couple of prospects coming up. So we think that's the next big thing coming generally in cybersecurity. So, Oslo. I've never been to Oslo before. How many of you are actually from Oslo? A few. Excellent. Because sometimes I've given a talk in London and I say to the audience, who's from London? And I do this and there's nobody. I'm like, oh, Christ. So I've never been to Oslo before. I got here last night. Now, this won't look weird to any of you if you're from Oslo, but what's striking to me as an English person is how dark it is, right? It just gets incredibly dark. I did notice that Oslo is further north than the Orkney Islands and about level with the Shetland Islands. And if you're from where I am, that's really far north. So I guess that's why it's so dark, but honestly, it really leapt out at me. This building I found interesting. No idea what it was. If you're from Oslo, you probably know. But then there's one immutable rule of every big city, or every city I go to in mainland Europe, which is there is always an Irish pub, without fail. Now, they're nothing like the pubs in Ireland, as far as I can remember them, but it's been a while since I've been in Ireland. But a new one on me was I found an English pub named after Winston Churchill. I was like, wow, that's interesting. So I thought, you know what? I bet there's no pubs in the UK named after Winston Churchill. So I Googled it and I came up with one. There's one called the Churchill Arms. What kind of makes me slightly suspicious about it is it says it was built in 1750. So I somewhat doubt that was its original name. But hey, there you go. Who liked the conference merch today? I thought it was amazing. I like to go running, and that was a great set of conference merch. If you didn't get the running gloves, unlucky. I'm sure they work equally well for cross-country skiing. But, So I went out today for a run. If you're from Oslo, you probably know what this building is. I thought it looked amazing. I have no idea what it is because I had no time to check. But it's important enough that there was a bloke with a gun guarding it, so I assume it's something important. There I am, just to prove I did go running, and I did use the Norwegian-style headband ear warmer thing. They're really good for bald people, right? Because you need to sort of sweat out of your head, but keeping your ears warm is important because there's no hair to do that. I show you this sign. This is my Google avatar, just to give you a clue about where I'd really love to go tomorrow before I have to catch my flight, which is, of course, the National Museum, because there's one version of the screen there, I'm told. Yeah. So I'll probably go there if I get time tomorrow. I was intrigued by this as well. I shouldn't have been, but I guess Oslo, I'm not great on geography, is at the north end of a big fjord. Kind of looks that way on a map. So does this count as sea ice, or is it not really sea ice? I don't know, because it's right up north in a fjord. It's pretty sheltered. But I was just kind of thought, oh, blimey, I didn't expect there to be ice in the sea. Again, it's further north than the Shetland Islands, so maybe I shouldn't have been that surprised. Just so you know, I love that building. That red building was this photo. But as I took the picture, something was making a noise just to my left. And if you're British and you're not from Manchester, one thing that scares the shit out of you is trams. Because they make no noise. We don't know what direction they're coming from. And I mean, I've nearly been run over by trams in Amsterdam. Maybe that wasn't to do with the trams. But I mean, more than once, right? And the other thing when I go to Europe, particularly when I'm running, that confuses me is the zebra crossings, because they have very strict rules in the UK. You get on the crossing, the cars stop. Sometimes people abuse that, particularly in London. And my technique is always to look straight in the eye of the driver and make sure they're stopped, and then I'll go over the road. Unfortunately today, of course, I had this situation. Now, this may not look weird to anybody in this room that isn't me, but remember, we drive on the other side. So as I was approaching this zebra crossing, I thought the driver was doing this. It's really scary. So, of course, a junction that, whoa, looks like that absolutely makes us blow our mind in the UK. It combines all the things that we just don't get anywhere. But it's not as bad as this one that I once encountered in France. If anyone could ever tell me what's going on in that junction, great. Right. Normally I get a warm-up act, but they didn't have the budget, so that's that bit done. I just always have to say this because I give a lot of talks at conferences. Sometimes I mention the client. It's kind of not necessarily the client I'm working with or this client or that client. I do like to mash up the stories. Sometimes I sort of make them together to make it sound better. The Germans have a great word called Treppenwitz. Do you know what that means? It's on there. There's no direct word in English for it. It means staircase wit. It's when you think of a rejoinder after the person made it. So when you're on the staircase afterwards. So you're in a meeting, someone says something, and you think afterwards, oh, I wish I'd have said that. And of course, when you tell the story later, you did say that. You absolutely did. So I cannot promise that if I mention an anecdote from my previous life that I'm not using Treppenwitz. Let's get on with this. I'm going to talk about some big robberies, heists, whatever. What opportunities might have been missed? What can we learn from them? And like every talk at every conference, there has to be top 5 lessons at the end. That might be a lie. We'll see. That coffee's good from that little pop-up stand outside. I recommend it. Cool. Let's talk about, is everybody familiar with these 3 robberies? I've just realized that when I was editing the slides earlier, that's not the order that I'm going to talk about them. That doesn't count as a lie, though. A lie has to be intentional. That's just an error that I've just spotted. I'm guessing nobody in the room hasn't heard of Bitcoin. One of the interesting things, there's lots of interesting things about Bitcoin, but Bitcoin and similar, they facilitate crime in many ways, right? And, people think that Bitcoin's anonymous, which it's far from anonymous, because the blockchain has a record of every single transaction that's ever taken place. It's an immutable record, of course. And in order to convert Bitcoin into real money, or Ethereum into real money, you have to go through a crypto exchange. Well, that's if you want to convert it to dollars or sterling or any Western currency. Not sure how it works in Russia. You can probably convert it to money down the pub in Russia, who knows. But that means that KYC exists in Bitcoin. So laundering heist money is as problematic with Bitcoin as ever. But one thing it does have over traditional ways of robbing stuff is that it's portable, right? if you steal $10 million worth of crypto, you don't have to put it into God knows how many suitcases to carry it across borders, right? So for that reason, a lot of the biggest, well, almost all the biggest robberies that there have ever been are to do with crypto in the last few years, and it's only going to carry on being like that. That's the current price of Bitcoin. This is just another fun fact. It's gone down a bit in the last few months. It peaked at just over 90,000 US dollars. It's down to 50-odd thousand. This was earlier this week. But if we look at it over the last 5 years, it's still a pretty good bet. 5 years ago, it was 15,000. So it's gone up, 4.5 times in the last 5 years. So that's a pretty good return on your money. If we look at this longer term graph, we'll see that back on the 4th of November 2017, it was trading at 5,600. The reason why I picked that one out is because that was about the time that certain of my colleagues said to me, you've got to invest in Bitcoin. And they were looking at it all the time. How much spare cash have you got? And I don't know how much I had at the time. Anyway, they're all millionaires and they've retired and I'm here. So I think you can guess whether I invested or not. Who's heard of the Lazarus Group? Yeah, a few. So the Lazarus Group is the North Korean state nexus. They are pretty good hackers, and they generate funds for the North Korean regime. So a lot of both of the big crypto heists I'm going to talk about were down to them, and they're in the news all the time. They are stealing stuff all over the world to fund, kind of everything, I think, in North Korea. Because you're pretty much, I think they trade with Russia, they trade with China, but they're cut off from the rest of the world. They constantly need US dollars to fund the bits of nuclear weapons they buy and stuff like that. So the Lazarus Group, I don't know who called them that, one of the threat intel groups, no doubt, is very important to their economy, I guess. Yeah, they did the Sony hack. That's an interesting one. If you're interested in just lols in hacks, there was a guy, it was the guy that did Family Guy, I think, or one of those things. He made a film which was a pastiche about, it was called An Interview with a Dictator or something, and it was about somebody interviewing a dictator that looked suspiciously like Kim, and then he was hired to be a CIA hitman. And that's why the Sony hack happened. The North Korean group went after Sony, because Sony was the distributor. They ended up cancelling the film. I think you can get it in various places. Sadly, I've never seen it, so I don't know if it's any good. Moving on. Yeah. Interestingly, this is a year ago now, just coming up for a year ago. North Korea is the third biggest holder of Bitcoin in the world. There you go. Who knew? After the US government and the UK government, that was true as of then. And that's as a result of all these thefts by the Lazarus Group. Right, one or two people had heard of the Lazarus Group. Has anybody heard of Axie Infinity? No hands going up this time. So, Axie Infinity, it's a computer game, or was a computer game. Don't know if it's still in existence. It got really popular apparently during the lockdowns. It's one of these games, I don't know, I haven't played computer games since I had children. Don't have time. But it's to do with breeding things called Axies, and then you fight them against other Axies, and then you can trade them. Now, my children, my older children, my two old girls, they both played Roblox a lot. So I'm sure some people in the room have children that play Roblox, but some people in this room are so much younger than me, they probably play Roblox themselves. And what happens with Roblox is it has an in-game currency called Robux, but it has like a black market currency off the game in real life, where people do trade their Roblox stuff for money, and people get burnt all the time, And every game there's ever been before, that has an in-game economy, there's always a black market economy that grows on the side. And the reason for that is because the game developers, the game owners, don't want to hold people's money. If they trade in real currency, then they're going to be subject to, in the UK, FCA regulations and whatever the financial regulators are all over the world. So they can't build a game economy based on dollars or GBP or any fiat currency, right? So what Axie Infinity is the name of the game. Sky Mavis, the game developer, they thought, well, why don't we base the game economy on crypto? Because crypto isn't yet regulated in the same way as dollars or pounds or whatever. So that's what they did. You build these things called axes. They're based on those salamander things. What are they called? Axolotls. And you trade them for Ethereum. And that all works really well. And they found that trouble is Ethereum trades take too long. They needed the ability to make trades happen like real time. So instead of using the Ethereum blockchain, they made what they call a side chain called Ronin. And all the in-game trades take place on Ronin. And then there's something called the Ronin bridge that connects the Ronin sidechain with the Ethereum main chain. If my soundboard was working, I'm saying to the chap at the back, I would at this point play the music that comes off at the start of Jaws, you know, to indicate there's danger coming. But just play it in your head, you know, or whatever works culturally for you in terms of danger comes. You can see that there might be some sort of weakness there, right? Because the Ethereum blockchain is a thing, this is a thing, they've built something that joins the two. Yeah, that probably sounds like a seam in the system, doesn't it? Anyway, there's a bit about the Ronin sidechain. I always do this when I give these talks. I forget that I've probably said everything on this. Let's just read it quickly. The Ronin bridge, oh yeah, I'm glad I did this because there is a bit. So on Ethereum, usually the way that things work, the way that things can happen, there is a smart contract. I don't have time to go into what smart contracts are, but they work. Smart contracts are immutable. They sit there and they are in instructions to do stuff. Now, when you want to execute a smart contract, you have to give it the parameters, and there will be rules about how to make that actually execute. So usually in Ethereum, and believe me, I've been studying this, but I don't understand it fully. I'm not the world's expert. They call it proof of stake, I think. Is that right? Yeah, because the Bitcoin blockchain works on proof of work. Anyway, suffice it to say, there were 9 votes that could vote on a transaction on the Ronin sidechain, and 5 of the votes needed to vote in favor. So the idea with that is you distribute the responsibility, so no one person can steal all the money, right? So anybody can say, let's do this transaction, but a majority of those 9 nodes need to agree to it. You might notice an impending problem here. Sky Mavis owned 4 of the nodes, right? So in their eyes, they've distributed it. There were 5 other nodes around the world. I don't know. I don't have visibility in how they chose where those nodes lived, but Sky Mavis themselves owned 4 of the nodes. So sometimes I give a talk abroad and I try and make a joke and it falls flat, and I always say, maybe that joke doesn't work outside the UK. This joke, on the other hand, I think is just a crap joke. What I've done is I've put a 4 in a shadow to say I'm going to foreshadow something. You're welcome to groan, or even I'll give you a moment to leave the room if you want, because honestly, I think that is crap. So just a bit of foreshadowing. Does everybody, surely you can work out what I'm saying there, right? It might involve fishing. Maybe that's a crap pun as well. And there's some dusty stuff under some dust sheets, that's been lying around in storage for ages. Yeah, that might be a bit of a clue. What else is there? Hygiene. Boring thing, right? Hygiene. But, bad things happen if you ignore it. That's enough. Again, I'd have the Jaws music at this point if my soundboard was working. All right. How did this hack go down? Now, this is probably why people have come. I now apologize in advance for the graphics. My daughter is at university studying art and history of art and stuff. I offered to pay her to do the graphics, but she said she didn't have time. So I obviously used ChatGPT. So the inconsistencies will pop up from time to time. You're welcome to laugh at them. So how did this go down? So this happens a lot. And the Lazarus Group are really good at this. Who thinks here that LinkedIn is a vulnerability for the company they work for? I would expect every hand to go up if you're a security professional. So it's very easy on LinkedIn to find out where people work, what they do. And also, any company with any reasonable degree of employees, you can work out what their tech stack is, right? You can even start to work out their org structure based on what people have done, what their experience is, and who they've worked for. So it's fairly easy to identify developers. And we all should know that developers are a big weak point in most networks. Because developers need to do stuff, and then they're not going to muck around with PIM unless you make them. So we'll come back to that later. So some person at Sky Mavis gets offered a job, really good job opportunity, right? I guess this is the fishing part. So, of course, they do interviews with people. My guess is that the people they're talking to probably never switch their cameras on, but hey, I don't know, maybe they employed someone in the right country to make it look good. They got through the early interviews. I can't even read this on this screen. So, of course, as often happens in the software engineering world, they get given a tech test. Is that a thing? Have I said that? Does that translate into other languages? I hope it does. So it's thought that this tech test, and I'm sure this has happened to a lot of you in this room. It happened to me. Well, I didn't get hacked because it was before hacks, but years ago, I got sent tech tests when I worked for ThoughtWorks, and I used to send them out, right? So this one apparently is thought is like a Docker file. So expand the Docker file, do the tech test, and send us the results. I think you could probably see where this is going. So the Docker file expands, whether it's a Docker file, some sort of container, installs some malware on that computer, right? So that's great because they've pwned that computer. I don't have visibility in what the Axie network was, but there's a good chance that when you pwn a computer, you've also got the whatever access tokens are lying around. If it's a Windows computer, Christ, you own the whole network, don't you? It might be a bit more difficult if it's a Linux machine, a Linux-based network. So the malware's there. We have to assume he does the tech test. Well, it might not have been a he. Like the reports I've read didn't say he. I don't know if they got the job. We can assume probably not. So, his computer's pwned. I quite like that picture. The little guy looking in the dark there in the background. Got the keys to the castle. What do? Well, they do their recon. This is, I think, fairly unforgivable. With those creds, the attackers were able to compromise, get ownership of those 4 voting nodes I mentioned earlier. So they've got 4 of the 5 voting nodes that will enable them to execute a transaction on their own in sidechain. Not enough, obviously. So now they've got to compromise one of the external 5 voting nodes, right? So you would think that makes things difficult. How do they do that? It's not really publicized where those 5 nodes are outside of their network, but they're other companies, they're other entities, they're other organizations. I've read 2 different explanations of this. I'll go with the first one first, which was in setting up the infrastructure they needed to be a voting node, they had to have developer creds on those machines. Some other reports I've read say it was to do with Sky Mavis had set up a DAO, a distributed autonomous organization, which I don't have time to talk about, to vote when it was busy times. Either way, either because of a developer cred that wasn't cleaned up or a temporary access to this DAO that wasn't cleaned up. So something that wasn't cleaned up, there were access tokens there that enabled the attackers to get control of a 5th node. So I think you can guess where this is going. They pwned the Ronin Bridge and onwards, as the guys on Risky Biz say, to great victory for them. They managed to siphon off 625 million-ish in US dollars. This was in 2022, I think. So you can do the maths. That's probably worth a lot more now. It was mainly in Ethereum and USDC, which is I think that's a stable coin, which is one of these coins that's linked to the US dollar. So that I suppose is as good as US dollars. Although you've still got to transfer it out, right? And then therein lies, oh shit, did that go? No. The problem for the Lazarus group, you've got to cash the money out, right? So I won't dwell too long on this, but they've got all this crypto assets. They need to convert it. The North Korean people still need to convert it into dollars in order to use it. There was a service, which was a DAO, called Tornado Cash. It was set up by 3 men, and a DAO is a distributed autonomous organization. You can set up, and I'm halfway through doing this. It's one of these things where, you know, as a software engineer, or in my case, an ex-software engineer, you think to yourself, how hard can it be? So I sat down to study it, and I really want to do a talk on DAOs and hacking smart contracts. So I started learning this stuff a few months ago, and like after a few weeks of, how hard can it be? I'm like, yeah, it's pretty hard. So I've got some work to do. But a distributed autonomous organization is an organization that is defined purely by the smart contracts that govern what it can and can't do. So the way that Tornado Cash works, and the founders are adamant that this was a privacy service, is you pay it some crypto, you pay into it, you activate a smart contract by paying X Bitcoin into it. Then that smart contract, which is immutable, it basically says, James Burney has deposited 10 Bitcoin. But then it's all in the background, it's all off ledger. So I'm now, later on, I can say, okay, transfer part of my Bitcoin to this Bitcoin wallet. So it breaks the chain of custody, right? So that's called a Bitcoin mixer. Tornado Cash was supposed to be based on privacy. It was supposed to be enabling Bitcoin to be private. And in a way, it does that. Problem is, as soon as the American authorities found out that the Lazarus Group was using it to launder funds, they sanctioned it, which caused a bit of an uproar. Famously, an activist, because the sanctions said that anybody that pays money into or receives crypto from Tornado Cash is subject to the government sanctions, right? So an activist paid some money into Tornado Cash, and then made microtransactions to loads of famous Americans and loads of people in the government, and then asked, are these people now subject to arrest? So it kind of illustrated the absurdity of it. All 3 founders are subject to sanctions. 2 have been arrested and jailed. 1 is out on appeal in the Netherlands. The other one is going through an appeals process in America. It's all very murky. The 3rd is beyond the reach of American justice in America. That's the latest for that money. And of course, Tornado Cash being a DAO, a DAO, it can't be shut down. So it's still there. It still functions as a crypto mixer. And actually, you can now use it again as a privacy tool. So if you want to buy coffee for, if somewhere does take Bitcoin and be truly private in your transaction, you could use Tornado Cash to do that. The sanctions were removed last year sometime. So, it does function as a privacy thing. I wouldn't recommend laundering 600 million US through it, though. Up to you. If you've got 600 million to launder, good luck to you. All right, who's heard of the Louvre? Yeah, I'd have thought so. Converted Royal Palace in Paris. That's hard to say. Oh, come on. We all know what the Louvre is. It's got the Mona Lisa in it, right? I want to talk about this robbery because, funnily enough, it has similar failings. So, what happened? I guess we're all familiar that there was a robbery in the Louvre, right, last year? Yeah. Oh, here's that terrible joke again. My apologies. Yeah, I really wanted the sound effect here for the clown music. Is that universal, that clown music that says there's some real clowns at work here? So imagine that music, go on, because it is a clown show. So this is what happened. Oh, and by the way, this is where you get a really good idea of what happens if you lose patience with getting ChatGPT to make your pictures. So, first of all, the museum opened at 9:30. I thought that picture wasn't really useful in terms of this presentation, but it's the only one that actually made complete sense, so I thought I'd leave it in there. Apparently, 2 gang members turned up on a boat. So it's right next to the River Seine. So they turned up on the River Seine side. From what I've read, I was reading, there used to be loads of street-level entrances to the Louvre, and they've closed them all. And the only way in now for the public, as a rule, is underneath that glass pyramid that's at the front. So all the street-level entrances, they've permanently closed. So they turned up in a boat. So, yeah. A bit like how many times have we heard about pen tests where they're getting through the back door because, you know, the alarm was pissing everybody off, so the security guards just leave it open. It was that sort of thing. Now, you'll notice there's a slight error on this next picture. They used a furniture lift, which apparently are very common in Paris, to get up to the first floor and break into the building. But no matter how hard I told ChatGPT, it had the two men climbing out of the building. The only criticism that it actually listened to, I said, can you please put them in yellow and orange jackets so it's consistent with the description. So they go up there on a furniture lift. They then break their way into the building. They didn't start to destroy their furniture lift with disc cutters, despite what ChatGPT insisted on showing us. They broke in through the window using disc cutters. I particularly like the deliberate error in the next picture, which is, according to the reports I read, I didn't write any of the reports, they then threatened security guards because they set an alarm off, which it did pretty well, right? It set the alarm off, you can see that. They then threatened some security guards with their power tools. Interestingly, the security guards were armed with the same power tools. I cannot vouch for the authenticity of that piece of the picture. And apparently that was enough to see the security guards off. Frankly, that's unsurprising, right? Because presumably they didn't carry anything more fearful than a circular saw. So then they used the furniture lift to get back down to ground level. There were two guys waiting for them in mopeds, and they sped off on the mopeds. They did drop Empress Eugenie's crown on the way. I don't know if it looked like that. Probably not, because that's ChatGPT's notion of a crown, which rather looks a bit like the UK imperial crown, which is in the UK crown jewels. So they dropped Empress Eugenie's imperial crown, but they still got away with 8, it's over there, 8 items of jewelry worth over 100 million, it says. I bet they got nowhere near that amount of money, and I bet they've all been melted down, and it's absolutely tragic. But there you go. At least with Bitcoin, nobody loses any priceless relics. So that's what happens. Oh God, yeah. Here I have to have a side rant, excuse me. Off by one errors. We've all experienced them in software, right? Now, my partner, I was explaining off by one errors to her recently, and she said, that doesn't happen in real life. I was like, it does. It happens all the time. When I was doing the research for that, some of the reports said first floor, some of the reports said second floor. I'm like, whoa, what? I mean, this really gets my goat, right? There's the ground. The first floor you build is the ground floor, right? Right? At least if you're from the UK. The one above that is the first floor, then the second floor, and so on. Underneath the ground floor, you've got the basement and the sub-basement or whatever, right? And I agree that that is not necessarily logical. In America, they put the first floor at ground level, right? Then the one above that is second and third. So you see where the off by one error is going. I don't know what they call the level underneath. Probably, I don't know, the car park. In any sensible country, in any sensible system, you're going to name this floor that we're on is going to be what? I'd say floor 0, right? Then the one above is 1. The one above that is 2. If you are going to go down underground, then you're going to go to -1 and -2. For God's sake, I mean, surely it would be easier to standardize on this than time zones, wouldn't it? Come on, world. And it really winds me up. Of all the things that there's an off by one error when you're trying to research a robbery. God. However, having said that, has anybody noticed the lifts in this hotel? This is not floor 0 in this hotel, it's floor 1. You have to go down to the gym to get to floor 0. Last night when I checked into the hotel, I was trying to get back out to go outside to find somewhere to have dinner, and I ended up in a bloody gym. However, not as bad as an NDC, I'm talking to you. Did anybody here go to NDC Porto 2019? I'm going to guess not. I did, and it still rankles with me that this was the lift in NDC Porto. The ground level was number 1. The one below was -1. There was no 0. What were they thinking when they built that building? Apologies, that is nothing to do with cybersecurity, but I thought I had to get that rant in there. Excuse me. I don't know why they assigned an hour for every talk. There's no way we need an hour. What time did I start? 33 minutes ago. It's got a little timer on it, of course. Yeah. So what happened at the Louvre before the heist? This is the interesting part. This is the real clown show. So at the time, it was reported that there was an outage which was thought to have been a cyber attack, which meant that the security cameras were out of action. From what I've read since, that seems to have been discredited. It wasn't that there was a cyber attack, it was just that all their systems were constantly crap and had been for some years. What is known, from what I can read, is that the password for the security systems was Louvre. Whee! And apparently weak default password is the oldest recorded thing with a CVE number, or the oldest recorded vulnerability. And the museum was still running Windows 2000 and Windows XP at the time of the robbery. Whether it still is, I don't know. I'd have thought probably yes. You'd think by now they've probably employed some people to put in place some sort of compensating controls for the fact that, hey, security doesn't exist, but who knows. And it's also lots of employees have gone record down the years, people that have left the organisation, basically saying that there were 3 separate audits that I think I've called out there by the France's National Cybersecurity Agency. And staff apparently have constantly warned management that their security is rubbish. Does this sound familiar to anybody that works in cybersecurity? I bet nobody in this room has ever had a warning rejected by management, right? Nobody at all. Who knows about Bybit? Yeah, one person's got their hand, well, I wouldn't say up, it was kind of sideways. Yeah, nice. Bybit. I think this is one of the most technically, is cool the right word? Respectable, impressive hacks that I've heard of. Because let's face it, most hacks exploit the usual stuff, right? Or they use, somebody else has done the research on a vulnerability and it's on the list and people just haven't patched it, right? Yeah, there's no skill in that. The Lazarus Group did Bybit as well. And I'll talk you through it. So Bybit's a crypto exchange platform. So as I said earlier, if you've got Bitcoin or Ethereum or whatever, you want to convert it to real money or convert real money to those, you need to go through an exchange. So by necessity, they handle loads and loads of crypto assets. Quite sensibly, they have a hot wallet, apparently, which is connected to the blockchains. And that enables them to service their day-to-day business, right? So someone comes in and says, I want to buy some crypto, and then they want to transfer some crypto to this person over there for whatever legitimate or illegitimate means they want to do so. So they need some liquidity in their day-to-day. So I guess that's a bit like a shop that keeps money in the till, right? You need that liquidity. But then the vast majority of their funds are held offline in an air-gapped cold wallet, as they call it. And the idea being, and I guess that's a bit like a bank that has, an underground safe behind a locked door and everything, right? That's where most of the money and the gold bars and stuff is stored. So they have to transfer money, I guess, on a regular basis between the cold wallet and the hot wallet, right? So either they need to put more money in to give themselves more liquidity, or there's too much money there in the sort of touchable public realm, so they need to take some out to keep it safe. So that all sounds so far so sensible, right? So in order to facilitate that, you need an easy way of moving from A to B and from B to A. They used a company called Safe Wallet that makes software for transferring, to facilitate those types of transfers. We're kind of at the periphery of my knowledge of how all this technology works, so my apologies. They had 6 people who could approve transactions. So the way it works is one of them, and I assume these were all senior people within the company, one of them needs to propose a transaction. So we'll say something like, we need to transfer X amount of Ethereum from the cold wallet to the hot wallet, and it requires 3 others to agree with that transaction. So there's a proposer, and then it requires 3, approvers? Yeah, to agree with it. They used Ledger hardware, Ledger with a capital L, so that's a manufacturer. They make these little crypto devices. I've got some photos of them in the later slides. What they are is they're air-gapped things, they're USB devices, and you plug them into your computer, and when there is a transaction that's being proposed, it comes up on this UI, and this has got the encryption keys hardwired into it, I guess a bit like a YubiKey. So, and then you have to authenticate against it somehow, presumably with a fingerprint or something. So the whole system is supposed to be air-gapped, and it's separating concerns in what sounds like a reasonably sensible way, right? You may say that doesn't sound like it has vulnerabilities in it, that system, and I think perhaps it doesn't, but we'll see. I've just got some notes on the side here. Yeah, Ledger is a manufacturer. ChatGPT told me it makes things called the Ledger Nano S, the Ledger Nano X. They're small USB-like devices. They have a secure element chip. They have physical buttons that help you to approve or disapprove. They have a small screen, which we'll come back to later. And they have isolated signing capability. So the key materials on the device, I think I said that. Yeah, and physical buttons to approve. So it sounds pretty good, right? I guess that's like the old-fashioned 2 keys needed for something. Sorry about that. That's the last time you'll see that crap joke. This is going to involve a fish again. Everything starts with a fish, right? It's going to involve this type of vulnerability, though. This came out, I was astonished. It's got a CVE number. When was this? March of last year, so coming up for a year ago. This vulnerability specifically was about sharing LNK files in Windows, and that's been something that people have done for ages. You know, download this link file, people install it on the desktop, double-click it, malware gets deployed, right? The thing about an LNK file is you right-click on it and say View Source. It then brings up a window, which has, I don't know, I think Microsoft did something about this, but at the time of this vulnerability, the window comes up and it's like yay big on your screen. So this vulnerability was about sticking tons of white space in. So you've got the thing that the shortcut does that is benign, and then there's zillions of white space right down here. So you have to scroll down to see it. It will say, do something malicious, right? So I think there's a name for these type of vulnerabilities. It kind of feels like it's I guess it's obfuscation. It's anti-security by obfuscation. It's hiding what it's doing, right? In a way that it probably also plays on fatigue, right? People get MFA fatigue, right? And then they stop reading things correctly. So it's that type of thing. I don't know if there's a general class for those vulnerabilities. This is you can probably guess what this is illustrating. This is me saying that there might be a supply chain attack involved, because the supply chain is often the weakest point, right? If you've got really good security, yeah, maybe look at the supply chain. So how did the hack go down? It starts off with ChatGPT pictures, like always. They must have done some recon on Bybit and worked out that Bybit's security was really good, right? Or good enough, right? Because they can't compromise enough of those handheld devices to, how are they going to do that? What are they going to do? Like somehow simultaneously kidnap 3 people, and I don't know. So they looked at the supply chain. They compromised something in SafeWallet. Every report I've read speculates that it's probably a developer. Let's just assume it was similar to in the last hack. Somehow they get some high-level creds, right? Again, should SafeWallet allow its developers to do stuff without PIMing, whatever? Who knows? So they've compromised Bybit. They then deployed some malware on Bybit. Now, the cool thing, and I've got much more detail on this, but we probably don't have time. They didn't just put some malware that changed everything, right? They put some malware that effectively said, if somebody from Bybit proposes a transaction, do this. So they planted it there, and it was specifically aimed at Bybit. So the early reports of this hack were, when I first heard the reporting, people were saying, oh, somebody was just doing a widespread attack to try and gain creds, and they got lucky they happened on Bybit. That isn't what happened at all. The Lazarus group targeted Bybit specifically through their supply chain, through SafeWallet. So they effectively wrote some code that said, if Bybit requests a transaction, do something naughty. Now, what that did, this is effectively, they planted a new contract on the blockchain. It's there. You can still see it if you're interested. As I say, I would find it impossible to read that. And what that contract did was effectively, what then happened was Bybit made a transfer saying the usual stuff, right? It's run of the mill. It says somebody proposed transferring so many of their Bitcoin one way or the other. It wasn't Bitcoin, Ethereum one way or the other. Then that goes to the approvers. The approvers approve it. Now, they approved a malicious transaction, but, and I'll show you on the next few slides, it's easy to see why they did. So 3 of the approvers approved that transaction, which later led to a row, and I don't know how that got resolved, between SafeWallet and Bybit about who's responsible for this hack. Because SafeWallet, Bybit is saying you got hacked, right? You let this malicious contract go. And SafeWallet says to Bybit, you approved the contract. You signed the thing that signed over $1.5 billion of your crypto assets straight to the Lazarus Group. Because in approving their contract, and apparently it triggered the actual thing, so it gave the attackers a little bit more time to get away with it because it wasn't immediately obvious, apparently. So they got $1.5 billion of crypto. I wanted to sort of show somebody celebrating on the next slide. You can see again that ChatGPT got it slightly wrong because it seems like Kim Jong-un is happy to send money to the rest of the world, which I'm sure he isn't. So I said to ChatGPT, please give me the same picture, but just reverse the directionality of the arrows. And it did that. In the end, and he just seems to be even more happy about that now. Who knows? So I gave up after 4 or 5 attempts. The trouble is it takes too long, and I only had a limited amount of time. This write-up, if you're really interested in the technicality, this write-up is brilliant. This explains exactly what was going on in the hack. This part here, this is showing the off-chain attack. So off-chain, I assume, means off the blockchain, right? So the bits in yellow are where they missed opportunities. So the Bybit, somebody proposes the transaction from Bybit. They say, new transaction, please. Now that triggers the SafeWallet to create this new transaction, but it's already been compromised. This is where the code kicks in that says, if Bybit requests a new transaction, do this. So that then signs out asking for signatures to the people. That message is different from the original, right? But we can only assume that they didn't notice. So it's a bit like what I said with that LNK file. It's just the attackers are relying on the fact that people aren't going to read this carefully. Then it goes backwards and forwards. At this point here, the signers, didn't notice that the message has been tampered. And then it saves the additional signatures because apparently it triggered a different contract later on the blockchain, which required those signatures. So it needed to save the signatures and use them again. So that's the implementation detail. I'd thoroughly recommend that if you're, unlike me, somebody that understands all this stuff a lot better than I do. This is an example of what is going on, right? So this is just me showing you how hard it must have been for anyone to realize. The contract, the smart contract, is in JavaScript, or the parameters to it are in JavaScript. So this is the kind of thing that people might have to understand, right? You see where I'm going? I mean, surely you can do better than that on your UX. The last talk I came to today was about UX. Yeah. Someone could have thought about it. And this made me laugh when I was reading this a few weeks ago, to simplify the code, and the person writing the article wrote that, and I looked at that and thought, that's not simplified it enough for me to understand what's going on. So is it really going to simplify it enough in the head of one of these 6 approvers who presumably are business people and not software engineers? Who knows? We can assume not. And this kind of summarizes what happens. The malicious JavaScript, you can read that. So it's effectively replacing the data with something that looks very similar to do something malicious. And whether it's like MFA fatigue or it's obfuscating, that's what they did. This is from the same article. This is the UI that these are examples of what they would have seen. I can see that the brand of these little handheld things is not the same brand that was mentioned in the other report, but I'm assuming it's similar. So the people that wrote this blog are probably got better information than me. So if that's the extent of what you see, it's easy to see why what looks like just a run-of-the-mill thing, right? I don't know how often they approve these transactions, but they're like, it's another one. You know, John proposed it, so I trust John, so yes. They might even have been in the same room, who knows? Or close enough so they just send an email saying, I'm transferring 10 million, can you just sign it? You know, so who knows? I don't know. I bet they weren't air-gapped to the extent that everybody... I bet there was some mutual trust between these people which shouldn't exist, right? So it wasn't operating in a zero trust fashion. That's just my speculation. But I doubt that it would have worked in any other way. All right. Those are the hacks. Those are the 3 robberies. Missed opportunities. The usual stuff. It was phishing. Why did they not notice the malware? Did they not have EDR? Huh? Really? Axie Infinity was designed badly. It wasn't really a distributed network. They owned 4 of the 9 nodes. That's not a distributed network. They had bad hygiene. They left stuff lying around. Bybit, again, starts with a fish. Did they do a proper supply chain audit on their suppliers? Maybe, maybe not. But if they had done and their suppliers had given them assurances, maybe they'd have a better case in court. Who knows? Yeah, did they really think that UX that we just looked at was good enough for transferring millions and millions and millions, potentially? Did they not think about maybe a compensating control? Just like my bank app only lets me transfer £10,000 at a time, which is a lot of money, but it's still a compensating control for someone nicking my phone and cutting my finger off to get my fingerprint, right? Clearly, they didn't have compensating controls. The Louvre, yeah. That comes down to just nobody cares about security, right? So, what can we learn? This is the payoff, right? You know what? I think everybody in this room knows this stuff, right? What can we learn from these attacks? Has anybody learned anything new in terms of how attacks happen by me describing it? My guess is probably not. I mean, you might have learned a bit about smart contracts from my sort of sketchy knowledge of it. But ultimately, these attacks have not changed in character since I've been working in cybersecurity, since I've been working in computing, right? It's, you know, even like the insider threat thing, it all starts with a fish. That's what happened in the 1960s in gangland in London, right? You didn't rob a random van, you paid the driver. You paid the driver to take a cosh over the head and took all the money, right? It's always been a thing. So do we in this room really need to learn lessons from these? I'm not sure. So the title of the talk, this was the lie that I was saying earlier. What can we learn from the world's biggest heists? Sort of maybe it should be, who should be learning from these, right? Because I'm not convinced it's us, right? So this is what I'm saying, like, I don't know if you can read that. In cybersecurity teams, we've probably all had these type of issues, right? I got this list off ChatGPT. I said, find me a list of common complaints from cybersecurity teams. The things that problem this. So it sort of boils down to we don't have the right tooling, or maybe it's not configured correctly, right? Maybe we don't have the right staff or the right skills, so on and so on and so on, right? We can't keep up with the changing threat landscape. Oh, damn it, there's an extra bullet point there. Didn't check it closely enough. Yeah, at least the picture looks nice. But what's the biggest problem? The biggest problem we have in cybersecurity? I'm going to let that hang in. You think about it. This is what I think. Is it lack of resources? Do we lack resources, or is it lack of expertise? Is it lack of the right tooling? I don't think so. I think the biggest problem we have in security is that. The biggest problem we have is getting the rest of the business to give a shit, to understand that there is even a problem there, right? If you take what happened last year in big business in the UK, Jaguar Land Rover clearly didn't give a shit about security. Neither did Co-op, neither did M&S. They damn well do now. But Jaguar Land Rover was such a big hack that caused the GDP of the UK to go down, right? They had a £500 million government bailout. Pretty sure they care about cybersecurity now, but usually it takes that sort of thing for it to happen, right? So what I'm saying is we need to tell the story better, right? I think since I've worked in cybersecurity, we're not great at telling the story. This example here, does anybody know Darknet Diaries? It's a great podcast, yeah. There was one a while ago about a pen test company. They did pen tests on children's toys, these type of dolls that say stuff, right? And they had a remote control, right? And what they worked out was the thing that you pressed on the remote control that would make it cry or say daddy, daddy, whatever, or mummy, mummy, it was vulnerable to a replay attack. So if you go to the CEOs of the toy company and say, this is vulnerable to a replay attack, they're going to say, get out of the room. What the hell is that? So those pen testers found, okay, they tested it. They did the replay attack so many times that they made the doll catch fire. Now, that's a story you can take to the CEO, right? Because how many of you have had a CEO that sits in front of the board or stands up in front of the company and says, our big goal is to reduce our attack surface? Exactly never. So my big contention is we as cybersecurity professionals, we need to start telling a story, right? So here's the top 5 things you can learn. I even put 6 things there just to emphasize that this is not the important message. You're welcome to take a photo though. You know what? As I was going through this, I felt they were all of same equal importance, right? I think one thing that we could do better as a group actually is the last couple, right? Zero standing privileges and PAM access, right? All those developers that get compromised and then someone owns the whole network, we should be using decent PIM systems that require them to PIM up and get approval for doing stuff, right? It'll add some friction, but you know, we should, I guess those are my technical recommendations. Those are newest technologies, do that. But basically, the main message is, most importantly, be a storyteller and bring your technology and business leadership on the same journey that you've been on. And then we'll all be happy as this guy. Thank you very much.